computer was born to solve problems that did not exist before. Bill Gates. But how computers build? How does computers work? And what are the parts of a computer? Hi everyone, I'm Carl James M. Rojas from group number 2. After knowing from group number 1 all the things that we must know to start building our knowledge to the most helpful technologies nowadays, the computers, the next thing we need to know is what makes a computer works to be able to do its task. And this is the task of group number 2. We will cater all the information to fulfill all of your curiosity to the main hardware of the computer, the components of system unit. In this topic, we will discuss the 9 essential components of a system unit. The motherboard, also known as the MOBO, the processor, or the central processing unit, the data representation, the memory, expansion slot and adapter cards, ports and connectors, buses, base, and power supply. In the end of this topic, you are able to identify the different components that complete the system unit. Know the evolution of each components and explore the different types of the particular components. Let's dive into the topic.
So, motherboard. Components of system unit presented by Group 2 BSIT 1C. So, pag-uusapan natin ngayong araw is about sa motherboard. When we say motherboard, ano ba yung pumapasok sa isip natin? Di ba? Papasok sa isip natin pag sinabing motherboard is computer. Kung ano yung part ng computer, tapos kung ano yung mga nakalagay doon, like RAM, ROM, ano ba, CMOS, kung ano yung mga yun, tapos kung ano yung printed na kulay green na malaki. Di ba yun napapasok sa isip natin pag sinabi natin computer? Pero ano nga ba ibig sabihin ng motherboard? So, si motherboard, the main circuit board of a computer. Siya daw yung main circuit board ng isang computer. Kilala rin daw siya sa pangalan ng main board or logic board. A motherboard provides an electric connection by which the other components of system communicate. Siya din daw ang nagpo-provide ng command at electrical connections para sa ibang components ng system. So malaki pa lang role ni motherboard, hindi lang siya basta nandun. Hindi lang siya basta susuksukan mo ng wire, hindi lang siya basta susuksukan mo ng kung ano-ano. So pag sinabi natin na motherboard, siya yung magbibigay ng command sa lahat ng part ni computer. Siya yung magbibigay ng kung ano dapat gawin, siya rin na magpo-provide kung gaano kalakas sa electricity dapat nang papasok sa component na yun. So, pag-usapan naman natin yung characteristics of a computer. So may tatlong characteristic daw si motherboard. Form factor, chipset, processor socket used, kung ano yung type nun. So pag sinabi natin form factor refers to the motherboard geometry, dimension, arrangement, electrical requirements. Advanced Technology Extended or ATX is the most common design of motherboard for desktop. Siya yung pinaka-ginagamit na design, si ATX. So, pag sinabi ba natin na form factor, siya yung sukat ng dimension ng isang motherboard, yung pagkakaayos ng electrical requirements ng isang motherboard. Tapos yun nga, ATX yung pinaka-common design ng motherboard kasi siya yung nasa atin ngayon. Siya yung pinaka-latest ngayon, si ATX. So when we say chipset naman ang pag-uusapan natin. Chipset is a circuit which is used to control the resources such as bus interface with the processor, cache memory, RAM, expansion card, etc. So si chipset naman daw yung kumokontrol sa mga resources gaya nila bus, nila processor, cache memory, RAM, expansion cards. Nagko-coordinate din siya ng mga data transfers between the various components ng isang computer. So, yan yung role ni chipset. Processor socket daw is a connector into which the processor is mounted. The basic input-output system or BIOS and complementary metal oxide semiconductor is CMOS. Yun si CMOS. Are presented on the motherboard. So pag sinabi daw natin na si processor socket, siya yung pinaglalagyan ni processor, tsaka ni CMOS. Siya yung pinaglalagay. Siya yung pinaglalagyan. Doon mo siya ipapatong, doon mo siya ilalagay para magawa niya yung role niya sa motherboard. Next na pag-usapan natin is different types of motherboard. Ngayon nag-uusap na tayo about sa history ng computer, no? Sa pinanggalingan nila at kung saan sila nanggaling. Napakinggan muna natin kay TechWiki, isang YouTuber na kilalang kilala ko sa pag-discuss about sa nature ng computer, kung ano yung mga kailangan na parts ng computer. Pakinggan natin sa kanya yung history ng computer.
Thanks for watching TechWiki. Click the subscribe button, then enable notifications with the bell icon so you won't miss any future videos. These days, just adding a CPU, a stick of RAM, a storage device, and a power supply to a mini ITX motherboard will give you a small and fully functional computer in a matter of minutes. And this is possible because of how many different functions the average motherboard combines into one little slab of like fiberglass, metal, and silicon. But it wasn't always like this. In fact, early electronics didn't have anything resembling the lovely green boards with black integrated circuits that we're used to today. Instead, it was common to see individual full-sized wires linking every capacitor, resistor, and other component necessary to make up a full computer system. Unsurprisingly, this approach took up tons of space, added a bunch of weight, and was relatively fragile, meaning that the printed circuit board took off in popularity pretty quickly, starting in the 1950s. It should be noted, however, that these early PCBs were still a far cry from the RGB motherboard that you might have sitting in your computer right now. While back then, a simple device like a radio might have gotten away with using just one PCB, full-fledged computers needed many circuit boards to handle different functions, connected by a backplane that you might consider to be a forerunner of the modern motherboard. Unlike true motherboards, though, these backplanes tended to be dumb connections with no actual logic that consisted of little more than a bunch of slots lined up in a row so that other expansion cards could be plugged in. For example, the Altair 8800 used one slot to insert a processor, another for memory, and so on. It wasn't until 1981 that we got a big upgrade. The planar board in the original IBM PC featured an Intel 8088 CPU, built-in memory, and actual external I/O. So it was far more than just a glorified bundle of wires like smushed together. All you could connect directly to it was a keyboard and a cassette drive, but it also included a handful of expansion slots that didn't look too different from what we're used to today. And those slots were important because motherboards were still so simple that they didn't have features that we consider basic now, like drive headers, for example. So if you wanted to load up your copy of Flight Simulator 1.0, you would need a standalone disk interface card. And we didn't see modern memory modules that fit into RAM slots until the mid-1980s either. By the late 80s, though, engineers had fully embraced the goal of integrating more and more functions onto the motherboard. And so little ICs called Super I/O chips were becoming more common. These functioned like rudimentary versions of a modern chipset. They provided drive controllers, ports for printers, mice, keyboards, and other devices, and the system's BIOS. Now, that all doesn't sound like a huge deal today, but Super I/O chips took up less space and they were much more cost-effective than expansion cards, setting the stage for full-featured modern motherboards. Around the same time, in 1987 specifically, we got the first ever integrated VGA graphics chips when IBM released Model 50 of their almost famous Personal System 2. Unlike modern integrated GPUs, though, this was a chip that was affixed to the motherboard instead of being built into the CPU itself, a paradigm that we saw again starting in the mid-1990s as 3D GPUs like the S3 Trio and the ATI Rage series appeared on motherboards, obviating the need for a separate card for basic use. Though, GPUs that were soldered onto motherboards began to disappear in favor of ones built into CPUs by the mid-2010s. Speaking of CPUs, let's jump back again to 1989, when the first CPU socket with a vaguely modern look, Socket 1, appeared alongside Intel's wildly popular 486 processor. While earlier designs involved soldering the CPU directly to the board or significant force on the part of the user to insert or remove them, Socket 1 had a simple mechanism based around a pin grid array, very similar to modern AMD sockets, though with a mere 169 pins. But it wasn't just CPU sockets that were getting a facelift. Expansion slots were also changing at that time. And it was about time, as the ancient ISA standard had been used since the days of the original IBM PC. In 1994, PCI started becoming popular in consumer PCs, followed by the short-lived AGP for graphics cards in 1997, and PCI Express, which is still with us today, in 2004. But what about onboard networking and audio? Well, in the mid-1980s, there were a number of proprietary networking protocols, but since the now familiar Ethernet was a relatively simple standard with easy physical construction, it became the go-to for networking in the late 80s, and, again, its simplicity meant that it quickly spread to PC motherboards in the early 1990s. And although sound cards also started appearing on the market in the late 80s and early 90s, and we had little internal speakers that could emit bleeps and bloops for a while, we didn't see true, fully functional onboard digital sound hit the mainstream until 1999, when Intel included the AC97 standard in its 810 chipset, which, incidentally, was also the first Intel chipset to include integrated graphics, meaning it was no longer necessary to have a separate chip for video processing, be it on the motherboard or on an adapter card. So now that all of these innovations had a clear home on the PC motherboard, the stage was set for refinements made possible by decreasing costs and the continued miniaturization of components. Not to mention an increase in processing capacity to handle lots of different features. Meaning that these days, even small form factor motherboards feature RGB headers, premium power delivery, and Wi-Fi. And of course, by the early 2010s, manufacturers also realized that all those bells and whistles are meaningless without some vaguely threatening heat sinks to show all comers that you mean business.
Ngayon nakita nyo na yung history ng motherboard, kung paano siya nagsimula at kung bakit naging ganun yung itsura niya. Ngayon, papakita ko naman sa inyo yung video, yung pinakalumang motherboard hanggang sa pinakabagong motherboard nitong 2019. Hanggang 2019 lang kasi yun yung nakita kong video. So, panurin natin.
Evolution of motherboard. Subscribe my channel if you see evolution videos. The first motherboard, originally called the planar, was used in the IBM personal computer. The AT, or fullet, motherboard form factor was introduced by IBM in August 1984. IBM introduced the BabyAT motherboard form factor in 1985. The LPX motherboard form factor was developed by Western Digital in 1987. Intel released the first version of the ATX specification for motherboards in July 1995. Intel, in a joint effort with DEC and IBM, developed the NLX form factor in March 1997. The first motherboards with AGP support are released in August 1997 by Intel and November 1997 by FIC. The Micro ATX motherboard and specification was introduced by Intel in December 1997. Intel introduced the WTX motherboard form factor in September 1998. Intel introduced the Flexor TX motherboard form factor in 1999. Contron introduced the ETX motherboard specification in early 2000. The Mini ITX form factor was developed and introduced to the market by VIA Technologies in November 2001. The PCI Express standard is introduced in 2003 by the PCI SIG. Motherboards with a PCI Express slot were released later the same year. NVIDIA introduced their SLI technology in 2004, allowing the ability to link two video cards together on a motherboard. The PICMG, a group of over 150 companies, introduced the COM Express form factor in 2005. Using two video cards with a micro ATX motherboard became possible in 2006 for computer gamers. Supermicro released the SWTX motherboard form factor in 2006. AMD developed the DTX form factor in January 2007. AMD also developed and released the Mini DTX form factor in 2007. EVGA released the HPTX motherboard form factor in 2010. DDR4 RAM motherboard 2014. 2019 RGB lighting gaming motherboard. Please subscribe.
Napanood nyo na yung mga history ng motherboard or computer motherboards, pati yung mga pinagmulan nila at tsura nila dati. Ngayon, idadagdag ko naman ng mga latest motherboards ngayong 2021 or tatlong latest motherboard ngayong 2021. Isa dyan si Asus ROG Maximus 12 Hero, si MSI MEG Z490 Godlike, pangalan pa lang, pang malakasan na motherboard, di ba? Tsaka si Gigabyte Z490 Gaming X. Sila yung mga isa mga latest motherboards ngayong 2021. Karamihan ng mga motherboard ngayong 2021 is puro pang gaming motherboard. So wala na kayong makikita ngayon na pang mahinaan na motherboard. Makakabili na lang kayo ng mga ganun, siguro sa mga surplus na lang ng mga store or sa mga maliliit na store na lang na nagtitinda ng mga lumang variety ng mga motherboards. Pero ngayon, makikita nating motherboards is puro about sa gaming motherboards na. Wala nang motherboard na hindi pang gaming. Kailangan ngayon pang gaming na. Kasi yung gaming na motherboard, mataas ang specs niya kumpara mo sa mga dating na computer motherboards. Kasi nga, pang gaming siya, pang mataasan siya, pang malakasan siya. Hindi mo pwede gamitin yung mga lumang motherboard ngayon na dati sa panahon natin ngayon. Kasi nga, hindi na kakayanin, hindi na kaya i-support yung mga applications, hindi na kaya i-run yung mga ginagamit natin na software dun sa motherboard. So, meron tayong 80 motherboards. Ito yung pinakaunang motherboard. So, hindi pala siya pinakauna kasi yung dating motherboard is yung 1930s, mid-1930s or 1930s. Ang motherboard is chunk na mga malalaking parts nila, resistor, capacitor, tapos iba pang components ng computer, tapos malalaking wire na konektado para lang mapagana isang computer. Ganun yung parts niya. Pero nung 1956, nakilala na si PCB or si printed circuit board. Siya na yung ginagamit ngayon. Yung makikita nyo na, itong nakikita nyo sa picture, ganyan si printed circuit board. Siya yung ginagamit natin hanggang ngayon sa kasalukuyan, si printed circuit board. Tsaka ang dati ring mga computer, hindi sila gagana kapag iisa lang ang kanilang PCB. Kailangan maraming PCB. Pero nabago lahat yan nung meron ng 80 motherboard. Kasi ng 80 motherboard, meron na siyang bukod na chunk ng memory, napakaraming memory sa gilid. Tapos meron na rin siya nasa kanya na lahat ng parts na kailangan para mabigay yung komanda kailangan ng isang device. So when we say 80 motherboard, this motherboard were used in older 286, 386 or 486 machines. The earliest of the main motherboard, siya yung sa pinakauna na main motherboard na nagawa. The 80 motherboards are equipped with 2 6-power connectors each. In the early 80s at 80 motherboards were available. So, next naman is the ATX motherboard. The ATX motherboard started in 90s and are still available hanggang today. Available pa rin siya. The ATX connector on the motherboard consists of a single connector. These boards are used for P2, P3, or P4 processor. So, sa ATX ay mas advanced na siya kaysa kay 80 processor. So, tingnan natin tong chart natin dito ng difference ng dalawa na to, ng 80 motherboard and ATX motherboard. So when we say, sa 80 motherboard naman, yung full form niya is 80 motherboard stands for Advanced Technology Motherboard. ATX motherboard naman stands for Advanced Technology Extended Motherboard. Extended, ibig sabihin mas advanced na siya, mas maganda na siya. So si 80 motherboard is walang sleep mode, yung pinapabayaan lang natin sa computer na nakastate tapos dark screen siya, papatay niya muna yung sarili niya para magtipid ng battery or ng energy consumption. Wala si 80 nun, pero si ATX meron siyang sleep mode. Yan, ang maganda kay ATX kasi nga mas advanced siya. Meron siyang sleep mode. Casing, it only can fit in 80 casing. It cannot fit in ATX casing. So, syempre, ganun din si ATX. Di siya mag-fit kay 80 casing. Kasi para lang din siya kay ATX casing. Power drain. It has more power drain to not having sleep mode. O, yun sinasabi ko kanina, si 80 motherboard, mas malakas yung energy consumption niya. Kasi nga, wala siyang sleep mode. Kapag iniwan mo siya nakabukas lang siya. Hindi katulad ni ATX. Kapag pinabayaan mo muna siya nakastay sa isang screen, mag-sleep mode siya para makapagtipid siya ng energy. Power connectors. 12-pin plugs are used to connect 80 motherboards to power supply. 20 to 24 plugs used to connect ATX motherboard to power supply. So power supply, pareho sila sa power supply naman, pareho silang need ng power supply. Pareho sila si 80 at si ATX motherboard, pareho sila nang nangangailangan ng power supply. Syempre, di naman gagana yung ating computer kung walang power supply. Produced by, si IBM ang gumawa nito and ngayon si Intel. Marami na rin gumagawa ngayon ng motherboard, katulad nila Asus, sila Gigabyte. Sino pa ba? Basta maraming gumagawa ngayon ng motherboard. Na halos pare-pareho lang sila pero iba-iba ng brand. So next, types of motherboard pa rin. BB80 motherboard. So ito yung smaller version ni 80 motherboard. Nintroduce siya noong 1987. May haba siya na ang original na haba ni 80 motherboard is 12 inches, pero ngayon 8.5 inches na rin siya. Same din sila ng gamit, same din sila ng performance, pero mas maliit lang siya. Mas portable kung baga. So, the next type of motherboard is XT motherboard o extended technology. When referring to a computer, and is the name of the IBM 5160 computer launched on March 8, 1983. The XT was the first hard drive IBM computer. 10 MB or 20 MB. Isipin nyo, hard drive tapos 10 MB to 20 MB lang. Ganon siya kahina. Ganon kahina dati yung computer kung kukumpara sa computer natin ngayon o sa motherboard natin ngayon. It also had a 5 1/4 inch floppy disk. Floppy disk pa yung gamit niya. A memory of up to 640 KB. An Intel 8088 CPU. An 8-bit ISA slot and a serial port. Isipin nyo kung gaano kaluma na to. Makikita rin natin kung tingnan nyo sa right side sa ibaba, sa corner right side sa pinakababa. Ayan yung mga memory niya, chunk of memory yan. Napakarami niya. Napakarami niya memory. Kumpara mo sa mga ano natin ngayon, sa mga motherboard natin ngayon, mas madali intindihin yung motherboard natin ngayon, mas portable. So, meron tayong Micro ATX. ATX Micro, it's an ATX Evolution. The measurement is 9.6 by 9.6 inches. Up to 4 expansion slots that can freely combine with ISA, PCI, shared PCI, and ISA and AGP are supported by the Micro ATX. Mounted holes have changed because the dimension is different. Syempre may iba na yung dimension ni Micro ATX kasi nga naiba na siya kumpara kay standard ATX natin. But they are consistent with most ATX cabinets. So sa performance, pareho pa rin sila. Pareho pa rin sila ni standard na ATX kasi same pa rin naman sila pero naiba lang yung dimension nila kasi nga mas maliit si Micro ATX. So Mini ATX. The Mini ATX is a 6.7 by 6.7 inch low power consumption motherboard format. So low power consumption siya, ibig sabihin mas matipid to. Mas maganda to, mas maganda siguro kung kumpara natin sa standard ATX natin kasi mas lower yung power consumption niya. The most characteristic factors of this form factory category is its proportions. Since the Mini ATX was launched, thanks to their open standard factors, they have grown into all kinds of application. Mini ATX is the basic format for all types of machines, such as embedded computer for automobiles and industrial application. So ginagamit daw siya sa mga sasakyan, sa mga industrial application, siguro sa mga factory, ganun, ginagamit siya. And sa ibang other types of machines. Nano ITX, another kind of motherboard form factor with measure of 4.7 by 4.7 inches. In the Nano ITX boards are fully assembled boards designed for very low power consumption. Very low naman siya, mas low pa kay Mini ITX. Mas low pa yung power consumption niya. Gaano kaya kalakas talaga kinukuha nito kuryente. In many uses, this type of motherboard can be used. But in development, especially for smart entertainment such as PVRs, media centers, smart TVs, in vehicle computers, and more. So ginagamit din siya sa mga computer sa ano natin sa kotse, like sa mga sa Tesla, kung yung may monitor yung sasakyan, doon siya nakalagay. Sa smart TVs natin, yung mga TV ngayon na pwede mo na connect ng cellphone, yun, doon siya ginagamit, para doon pala si Nano ITX. Pico ITX. Pico ITX is the smallest category of form factor for motherboards in this list. Siya yung pinakamaliit. Pico. Siya yung pinakamaliit na form factor ng motherboard ngayon dito sa ating list. The proportion is 3.9 by 2.8 inches, and the Mini ITX in 75%, and the Mini ITX is 75% smaller. For embedded system applications such as industrial automation, in vehicle computers, digital signage, and more. The Pico ITX with an x86 based architecture and low power consumption board is a great option. So magandang pamilian daw tong si Pico ITX kasi nga mas portable na siya, low pa yung power consumption niya, tsaka mas marami pa siyang mapagagamitan kasi nga dahil sa maliit na dimension na proportion niya. Sobrang liit niya, 3.9 by 2.8 inches. Tapos pwede mo siyang gamitin sa vehicle computers, digital signage. Ibig sabihin, mas maganda, mas reliable gamitin to si Pico ITX kung ilalagay mo siya sa mas maliliit na devices. So, ito yung comparison sa sizes ng mga sinabi natin na ATX, Micro, Mini, Nano, Pico motherboards. Standard ATX, mas dihamak na mas malaki siya. Si Micro, si Mini, si Nano, at saka si Pico. Tingnan nyo kung gaano kaliit si Pico ITX. Ganyan na lang siya kaliit. Isipin nyo, kumpara nyo sa mga dati na motherboard, yung mga dating motherboard, chunk, napakalalaking parts ng computer, na components ng computer, ilalagay mo dun, pagko-connect-connectahin mo para lang mapagana mo yung sa computer, tapos ngayon, ganyan na lang siya kaliit. So, that is my presentation for the motherboard. So, pakinggan naman natin yung sasabihin ni Clark Ian Panganiban para sa components of motherboard, sa parts ng motherboard. Thank you.
Hi everyone, my name is Clark Ian Manzanares Panganiban. I am BSIT student, 1C section, and for today's video, I'm going to let you know what are the different components of motherboard, and at the same time, I'm going to share with you some of the ideas, especially on the topic that is motherboard. I believe that if we use internet on some useful purposes, we could achieve and we could actually have a better knowledge and understanding on different kind of things that we are about to learn. So after discussing by Mr. Andre Palasique about the information or more knowledge about the motherboard, I know that motherboard is very wide and very popular because motherboard is one of the important thing or one of the important tool or useful thing to actually develop or to run a computer. So as we all know that motherboard connects all the parts on the computer, or as we all knew that it is one of the components of a computer. Computer motherboard is a platform to connect all the parts of the computer. Hence, it is considered as the backbone of the computer as well. In the world, there is a lot of popular manufacturers of different motherboard, and I remember some of them. Actually, it is Intel, MSI, Asus, Biostar, Gigabytes. But yun lang po yung mga naaalala ko sa aking isipan na mga popular na mga manufacturers of the motherboard in the world. And alam ko naman po na familiar din po yun sa inyo, especially Asus, because that is one of the brand of the technology that we are using as of today. So, apakadami pong components ng motherboard, and alam ko naman po na yung iba sa inyo is alam na ito, but gusto ko lang po i-extract yung mga ideas pa na meron yung motherboard, especially yung mga hindi kakilala-kilala, yung especially yung hindi po masyadong kilala na mga parts or components ng motherboard. So, nag-iiba-iba or nadadagdagan yung mga components ng motherboard because we have a new genre and we have old genre. As time passed by, mas nadadagdagan and mas nai-improve yung mga qualities and yung mga purpose or yung mga kung paano nag-work yung mga motherboards natin. So, unang-una, meron syempre tayong mouse and keyboard. So, yung iba, hindi alam na may mga connectors ang mouse and keyboards and that is connectors. May mga connectors po ang ating mga mouses and keyboards as well. Yung type na tinatawag natin doon is yung PS/2 and the second one is called USB. That is very popular. And also, the next one is parallel port na kung saan kadalasan ginagamit po ito sa mga printers na pang-connect sa ating mga computers as well. Kilala po ang parallel port sa tawag na Centronic port, if I'm not mistaken. Siyempre, ginagamit natin yung mga connectors to actually send and receive datas na kailangan natin through the use of those connectors. Also, the next one is CPU chip. Medyo hindi po ako familiar sa CPU chip, but sa aking research and knowledge about this CPU chip, it is Central Processing Unit based on my research, and it is also known as microprocessor. Alam naman po natin na yung CPU is the brain of the computer na kung saan siya yung may alam or siya yung talagang nagko-kontra or nag-extract ng mga kailangan gawin ng computer, especially kung tayo gagamit ng computer. Syempre, doon pa rin siya manggagaling bago mapunta mismo or bago magawa ng computer as well. The next one po is yung CPU socket. It is one of the important part of a motherboard. Why? Because ang purpose po nito is to actually install various process on the motherboard. So, napakahalaga po nun kasi pag wala pong CPU socket, paano natin siya malalagay yung mga USB port or yung mga connectors natin on that socket na kailangan po natin to develop something. So, we have different kind of sockets and ayan, makikita nyo naman po sa screen. We have socket 7, socket 370, socket 775, also socket 1156, and also socket 1366, na kung saan may mga different support or mga latest features as yung mga sockets na yan. Especially, nasabi ko nga po kanina na as time pass by and as time goes by, nag-iiba-iba and nagde-develop or nadadagdagan yung mga features nila. So, ayun, nag-upgrade po sila. Also, the next one is yung RAM slot. Yung RAM slot naman po is used to connect RAM. Yung RAM po is may nature capabilities po siya to actually measure in bytes. So, yung RAM po is meron pong use. Actually, meron siyang dalawang gamit na kung tatawagin po natin is yung single inline memory module and at the same time is yung double inline memory module. Also, the next one po is yung floppy controller na siya nagko-control po ng ating mga floppy devices or yung floppy drive po. Papasok din po dyan yung IDE controller na kung saan ang ibig po sabihin ng IDE is Integrated Drive Electronics. So, sa pagpapaikli po ng discussion na ito, napakadami pong components ng ating motherboard na kung saan yung iba po is familiar naman tayo. Hindi lang tayo sanay sa tawag na ganon. Keyboards and mouse na kung saan tawag sa component na iyon is PS/2 connector or processing connectors like that. Na kung saan hindi natin alam na ganon pala yung tawag sa kanila. Pero na iba lang yung tawag pero same purpose sila and same na pangalan. So, apakadami po nating mga types. Papasok din po dyan si cabinet front buttons or components po pala. PCI slot, ISA slot, na kung tawagin po natin is yung industry standard architecture. CMOS battery na complementary metal oxide semiconductor. Yung mga conductor po na yan is very evident sa mga motherboard kasi po sila yung mga nag-extract or yung kumbaga backup ng data. Sila yung nagsisave ng mga data, information, parang dun na i-store. At the same time is yung AGP slot, CPU slot, power supply plug in, and at the same time yung mga connectors po natin such as AT connector and ATX connector na may mga different pong connectors such as 6-pin and 22 or 24-pin connectors. At the same time po is yung mga switches and jumpers na kung saan may mga different types din po. Other components po is yung mga heatsink, coil, capacitor, and RAID. Na ang goal po ng coil is to actually eliminate to up the power spike and power dips. Also yung heatsink po is to mapabawas yung init or ma-cool down yung init po ng computer or yung processor natin. Naman po tayo dito yung mga different sizes of motherboard based on my research on different kind of sizes of a motherboard. Nung ang size po dati, siguro if I'm mistaken, 2 to 3 years ago is we have 3 different sizes, but as time goes by, sanabi ko nga po sa inyo, based on nadadagdagan ng ating years, nade-develop ang technology, at the same time is nade-develop ang mga processor natin, may nadagdag po sa kanila, and based on my research, this is the official standard or yung mga bago na pong sizes na meron tayo. Based on my research, meron po akong na-search na 7 pong sizes nila, and hindi ko po siya masyadong naaral, but we have 7 devices or 7 sizes on this research. So I have mini ITX, micro ATX, ATX, eATX, SSI EEB, XL, XTX, and at last po is yung HPTX. So they have different kind of width and height, and they have different also that official standard based on their use. For example po, yung ATX board often features around 5 total PCI Express and PCI slot. So, yung ATX board po natin is makakapag-support daw po ng 5 slot. So, yun lang po yung discussion ko for today. I hope you learned something on my discussion, especially on the topic that we are assigned to discuss to everyone. Thank you so much for watching, and God bless as well. Bye!
Good morning, BSIT 1C. My name is Micaela Bondag, and I am one of your reporters for today. So the topic that we're going to discuss today is all about memory. Let's start with the basic question. What is memory? Let's use the metaphor of the human body. In our body, we still need this element in order to decide on things, and that is your memory. For example, when you see a fire burning, you don't need any calculations to know that you should keep your hands out of it. It's simply stored in your brain that fire is hot and you should keep out of it. So it is also the same in computer. In a similar way, a computer also needs a memory to store information. Let's now proceed to the definition of memory. What is memory? Memory is referred to a generic term for all the different types of data storage technology that a computer may use. It is any physical device that is capable of storing information temporarily like RAM or permanently like ROM. Okay, so RAM and ROM, they are different, and we're going to discuss it later. Memory devices utilize integrated circuits that is used by operating system, software, and of course, hardware. You may be wondering, what does a memory look like? So, just like what I said earlier, it is an integrated circuit. So, all of us naman ay nakakita na ng IC. We use IC sa live line detector, and that is kind of similar. The structure, with RAM and ROM. So that is what a memory look like. It is an IC, integrated circuit. Next is volatile and non-volatile memory. So there are two types of memory. One is volatile memory. By definition, it is a type of memory that loses its contents when the hardware device loses power. RAM is an example of volatile memory. So remember that RAM is an example of volatile memory, meaning mawawala siya once the computer is turned off or it loses its power. Next one is the non-volatile memory. By definition, non-volatile memory is also known as non-volatile RAM or NVRAM. It is a type of memory that keeps its contents even if the power is lost. ROM, ROM, is an example of non-volatile memory. Just like what I said, ROM is an example of non-volatile memory, meaning pag naka-off yung computer mo, it's still storing your data, unlike RAM na nawawala siya when the power is off. So there is what we call primary memory and secondary memory. So what are the difference between the two? Primary memory is also known as the main memory of your computer. It is the memory unit that communicate directly with the central processing unit, or what we all know as the CPU. And primary memory includes the following: ROM and its types, which is the PROM, EPROM, and EEPROM. And then the RAM, which has two types, the SRAM and the DRAM, and other types of RAM that is available on the market, which is the DDR, DDR3, DDR2, DDR4, and many other types, and we're going to discuss it later. Next is secondary memory. Secondary memory is also known as auxiliary memory. It is the memory unit which provide backup storage. To have a deeper understanding about memory and what is memory as a part of a computer system, let's watch this video.
Computer memory. Computer memory. When you give input to the computer, it goes into the computer's memory. The memory of a computer is divided into two categories: primary memory, secondary memory. Primary memory. Primary memory is known as the main memory of the computer. It stores programs and data which are required by the CPU. It is fixed on the motherboard inside the CPU cabinet. There are two types of primary memory: read-only memory, ROM, random access memory, RAM. ROM. Read-only memory keeps the data permanently. This memory is non-volatile in nature. Its data remains as it is even when the computer is switched off. Various types of ROM are: PROM, programmable read-only memory. It is a version of ROM that cannot be changed during normal operation but can be programmed under special conditions. The user stores permanent programs, data, or any other kind of information in PROM. EPROM, erasable programmable read-only memory. It is another type of ROM. It stored data in EPROMs can be erased by exposing it to high ultraviolet light. EPROMs are cheap and reliable. RAM, random access memory or RAM, is also called read or write memory. It is a volatile memory. The information stored in it is retained as long as the power supply is on. As you switch off power, its contents get erased. How can you know about your PC RAM? To know the RAM of your computer, right-click on the computer icon and select the properties. Some more. Robert Dennard invented one-transistor dynamic random access memory or DRAM. Secondary memory. Secondary memory is a permanent storage memory. It allows to change, print, copy, move or delete data whenever required. You can also carry data from one place to another using secondary memory. Hard disk, compact disk, DVD and pen drive are some storage devices of a computer. Hard disk. A hard disk is also called a fixed disk. It is made up of metal plates fixed on a spindle. These plates are coated with magnetic material. A hard disk can store very large amounts of data and fixed inside the CPU box. Hard disks are generally available in 80 GB, 120 GB and 1 TB capacities. Hard disk has a larger storage capacity as compared to other storage devices. CD-ROM. It stands for Compact Disc Read-Only Memory. It is very thin in width and is circular in shape. It can store approximately 700 MB of data. CD-ROM is inserted into a CD drive. There are two kinds of CD. CD-R. It stands for Compact Disc Readable. In this type of CD, data once written cannot be changed or deleted. CD-RW. It stands for Compact Disc Rewritable. Data in this CD can be erased or rewritten. DVD. The full form of DVD is Digital Versatile Disc or Digital Video Disc. It is very similar to a CD but can store much more data, approximately 17 to 21 GB. A single DVD can store many cartoon movies. A DVD is inserted into a DVD drive. Pen drive. It is a pen-like device. This device is attached outside the computer at a place called the USB port. USB pen or flash drives come in handy if you have to transfer data between different computers on a regular basis. Additionally, a USB flash drive is fast, portable, durable and reliable. It can store large amounts of data ranging between 1 GB, 2 GB or more. It is the most convenient device to carry data from one place to another as we can put it inside our pockets. A computer system is made up of hardware and software, which is further divided into various subunits as shown.
So like what I've mentioned, there are types of memory, which is the ROM or read-only memory, RAM or random access memory, and storage devices. I believe storage devices will be discussed by other groups, but to have a glimpse of it, storage devices has 4 categories. There are magnetic storage, optical storage, flash storage, and online cloud system. Let's first focus on ROM or read-only memory. So it is a non-volatile memory, just like what I've said earlier, and a storage medium. So data inside the ROM may only be read but not overwritten or deleted during normal operation. So as the name suggests, read-only memory, so it can only be read, pero there are types of ROM that is available now that can be reprogrammed by using special processes, and that is going to be discussed later on this presentation. Let's proceed with the ROM structure. As like what you're seeing right now, ROM looks like an IC because it is an IC or integrated circuits. It is composed of decoders and programmable OR gates. Decoders are composed of AND gates, and these gates are fixed gates plus programmable OR gates. We have 4 different types of ROM, namely PROM, EPROM, EEPROM or EEPROM, and mask ROM. Each type of ROM is different from the other. So we have here the table. So we can see the difference between all of these types of ROM. Programmable ROM, it is initially empty, can be programmed once, and data cannot be erased. So, meaning, pag bumili ka ng PROM, wala siyang laman. So, ikaw yung po-program and isang beses mo lang siyang pwedeng gawin. You cannot erase it after programming it. Next is erasable PROM. Erasable PROM can be erased by UV rays. Next is erasable PROM. Erasable PROM, mabubura siya through using UV rays. So, pwede mo siyang ma-reprogram and pwede mo din siyang ma-erase. Unlike sa PROM. Next is the EEPROM or double EPROM. So, unlike PROM, ma-erase mo naman yung double EPROM using electricity. So, it can be erased electrically. And it can be reprogrammed and also you can erase the data. But remember that the efficiency of the memory will be affected once you erase it again and again. Next type of ROM is called mask ROM. It is programmed by chief manufacturer, can be programmed once, data cannot be erased. So it is basically like PROM. Pero ang difference lang niya is that pag binili mo yung chip, it is already programmed by the manufacturer of that chip. And you cannot erase it or reprogram it. Just like PROM, pero yung PROM nga, you initially buy that without anything inside. Empty siya. Pero yung mask ROM, pag binili mo siya, meron na siyang program sa loob. So, remember the sequence. First na na-develop is mask ROM. Next is PROM. Then EPROM. And then double EPROM. Every generation is different from the other. Most of the computers today, ang ginagamit na nila is yung EPROM or yung EEPROM or double EPROM. Because mahirap ngang gamitin kasi yung PROM and then yung mask ROM kasi they cannot be reprogrammed. So this picture, this is what ROM look like. Nakita tayo ng ganito when we're doing live line detector. Same lang siya, pero different siya in a way na this is used for memory and it has more pins than yung ginamit natin na 10 decoder lang. So this is different, but it looks the same. So let's see the position of ROM inside the motherboard. Take note that this motherboard is an old type of motherboard. So here we can see the ROM. Let's zoom it in. So this is medyo malabo, but this is what a ROM look like. Yan. Next, in a modern motherboard, location ng ROM is here. It's number 14. As you can see, this is a modern motherboard. So now we are on the next type of memory, which is the random access memory. It is a volatile memory and a temporary storage medium. All active programs and data that is currently being worked on is stored on its random access memory or RAM. I believe we are all familiar with RAM because when we're looking for cell phones or kaya laptop, tumitingin tayo lagi sa specs and laging kasama doon yung RAM. So usually for laptop, recommendable is 8GB. Pero there are laptops that comes with 4GB. Pero I guess for normal use and for today, 2021, 8GB is recommendable. 16GB naman, you can use that for your PC and it's very recommendable for gamers. And then yung 32GB, you can also use that for gaming, pero it is more recommendable for professionals like filmmakers and architects, scientists, archaeologists, and other professionals that really needs a faster RAM. So I'm going to play this video so that we can understand what is the difference between SRAM and DRAM.
I mentioned in my video on computer components what RAM is and the role that it plays. In this video, I will be going a bit more in depth into this component, explaining precisely what, why, and how it does what it does by going into the two main subcategories of RAM, dynamic RAM and static RAM. To give a brief refresher, RAM is a bit of a middle ground. Hard drives are very slow but store a ton of data, while processors are extremely fast but store hardly any data. Random access memory is a mixture of the two, a place for large, bulky data and machine code to be temporarily stored so your CPU can grab it and use it faster than the hard drive would be able to provide for it. So let's take a look at the two types of RAM, static RAM and dynamic RAM, often referred to as SRAM and DRAM respectively. Every stick of RAM that you buy is going to have a little bit of both, as they're intended to work synergistically. Here are the main differences between the two from a functional perspective. Static RAM stores less data, while dynamic RAM stores more. Static RAM can be accessed much faster, and dynamic RAM can be changed much faster. Dynamic RAM costs less, and dynamic RAM uses more power. Now let's talk about how each of these work, and then I'll get into the types of things each one is used for. Dynamic RAM stores binary data by using one transistor and one capacitor for each bit. As I mentioned in my video on binary, this code of ones and zeros is what all data and instructions come down to. In dynamic RAM, if a capacitor is holding a charge, it's a 1, and if not, it's a 0. The transistor connected to this capacitor lets the rest of your computer know if the capacitor is charged or not, and it also allows it to be changed as requested. Think of the transistor as what controls what is stored, while the capacitor is where it is stored. The advantages of this are that the transistor and capacitor put together are incredibly small, allowing for millions of them to be present in an area the size of your finger. The problem with microcapacitors is that they lose their charge very quickly. They can only store it for a few milliseconds, and this means that in order to remain charged, the capacitor must constantly be refreshed with tiny bits of electrical current. This results in memory that can't be accessed quite as fast as it could if it were in a constant state. But because this type of memory is constantly refreshed anyways, it makes it easier to make changes in its state from on to off. Now let's take a look at how static memory works. Instead of using capacitors, static memory uses only transistors. But it requires 4 or sometimes 6 of them in order to represent one single digit of binary, and therefore 1 bit of data. Static RAM accomplishes this by using something called the Boolean method, which is too complex to get into now, but I'll make a video on it in the future. In short, because static RAM requires more transistors to represent a single bit of information, it obviously requires more physical space on your RAM chips in order to do so. This results in less storage space. The advantages of this method is that unlike capacitors, static memory is constantly in the state that it's in. Whether it's representing a 1 or a 0, it remains that way and can be read that way until it's told to change. And this means that it can be accessed much faster than dynamic RAM, which sometimes has to wait for a refresh before it can be read. So we have a high capacity, easy to change, but somewhat slow system of memory, and a low capacity, harder to change but instantly readable system of memory. Why are both necessary, and when is one used rather than the other? As you may have guessed, static RAM is used to store data or instructions that aren't particularly large but need to be accessed frequently and quickly, such as a cache. Meanwhile, dynamic RAM is used for everything else. Things that aren't needed quite as urgently or frequently, but take up more space. In a way, static RAM does for your RAM what RAM does for your computer as a whole. Low storage, but fast and reliable access. Meanwhile, dynamic RAM does for your RAM what a hard drive does for your computer. It's not as quickly accessible, but it has far more storage. It's hard to give specific examples of when one is used rather than the other because the difference is determined by very, very low-level operations, things that a typical user isn't really going to have any experience with. Just keep in mind that both are very important for your computer's functionality. That's the general overview of how these two systems of memory work. If you have any questions, don't hesitate to leave a comment, and as always, I encourage you to look more into the specifics. Liking, sharing, and subscribing are always a huge help, and thanks for watching.
So after knowing what is the difference between SRAM and DRAM, let's proceed with the other types of RAM, which is the ETHERAM, SDRAM, DDR-RAM, DDR2-RAM, DDR3-RAM, and DDR4-RAM. So there are different generations from oldest to latest. Oldest being the ETHERAM and the latest is the DDR4-RAM. Remember again, each generation is better than the other. So ngayon, DDR3 and DDR4 RAM ang ginagamit na natin for PC and for laptop. So let's play this video to understand the different types of RAM.
Hello everyone. In this video, we're going to talk about one of the most important parts of a computer. And we're going to be talking about primary memory or temporary storage. And this is called RAM. RAM stands for Random Access Memory. RAM is stored on the motherboard in modules that are called DIMMs. DIMM stands for Dual Inline Memory Module. A DIMM is a dual inline module because it has two independent rows of these pins, one on each side. A DIMM memory module has either 168, 184, 240, or 288 pins. And then the DIMM is installed on the motherboard in the memory slots. A motherboard can have a various number of memory slots. The average motherboard will have between 2 and 4 of them. In order for data or a program to run on a computer, it needs to be loaded into RAM first. So the data or program is first stored on the hard drive. Then from the hard drive, it's loaded into RAM. And once it's loaded into RAM, the CPU can now access the data or run the program. Now, a lot of times, if the memory is too low, it might not be able to hold all the data that the CPU needs. And when this happens, then some of the data has to be kept on the slower hard drive to compensate for the low memory. So instead of the data going from RAM to the CPU, it has to do extra work by going back to the hard drive. And when this happens, it slows down the computer. So to solve this problem, all you need to do is increase the amount of RAM on a computer, and by increasing the memory, more data can be loaded into the faster RAM without the need of constantly accessing the slower hard drive. And the result is a faster performing computer. So this is why a computer with more RAM performs faster than a computer with less RAM. RAM requires constant electrical power to store data, and if the power is turned off, then the data is erased. RAM also comes in different types, such as dynamic RAM or DRAM. DRAM is memory that contains capacitors. A capacitor is like a small bucket that stores electricity, and it's in these capacitors that holds the bit of information, such as a 1 or a 0, because that's how computers read data, which is ones or zeros. And because DRAM has capacitors, they have to be refreshed with electricity constantly, because capacitors do not hold a charge for very long. They constantly leak. And this refreshing is where we get the name dynamic. The capacitors have to be dynamically refreshed often, otherwise they will forget the information that they're holding. Another type of memory is called SDRAM, which stands for synchronous DRAM. And this type of memory is what is used today in RAM DIMMs. SDRAM also has capacitors like DRAM, but the difference between SDRAM and DRAM is basically speed. The older DRAM technology operates asynchronously with the system clock, which basically means that it runs slower than the system clock because its signals are not coordinated with it. But SDRAM runs in sync with the system clock, which is why it is faster than DRAM. All the signals are tied to the system clock for a better controlled timing. So as stated before, RAM is stored on the motherboard in modules that are called DIMMs, and these DIMMs come in different memory sizes. Today they range anywhere from 128 megabytes to 32 gigabytes per DIMM. SDRAM is also rated at different speeds, but before we talk about the speed of RAM, we need to define some things first. Now the term 64 or 32-bit data path refers to the number of bits of data that are transferred at a time or in one clock cycle. The more bits that are transferred in one clock cycle, then the faster the computer will be. Now DIMMs have a 64-bit data path, which means that they can transfer 64 bits of data at a time. Now prior to DIMMs, there was an older RAM module called a SIMM, and SIMMs had a 32-bit data path, which means they can transfer data 32 bits at a time. So that's why DIMMs are faster than SIMMs, because they can transfer twice the amount of data per clock cycle. Because DIMMs transfer 64 bits of data at a time compared to SIMMs, which transfer 32 bits of data at a time. Now, a single bit, or 1 bit of data, is the smallest form of data that the computer reads. Because in the computing world, a computer only understands ones and zeros, which is represented by a single bit of data. Now, there is also the term byte, and 8 bits is equal to 1 byte. So if a memory DIMM is rated to have a 64-bit data path, then that means that it has an 8-byte wide data path, or bus, because 64 divided by 8 equals 8. SDRAM is rated at different speeds. For example, a stick of old SDRAM way back in the late 1990s could be labeled PC100. The 100 equals the maximum speed at which it operates, which is 100 megahertz. And since SDRAM only comes in 64-bit modules, as we discussed earlier, it has an 8-byte wide bus, because 64 divided by 8 equals 8. So to figure out the total bandwidth of PC100, you multiply 100 megahertz times 8 bytes, which equals 800 megabytes per second. So the total bandwidth of PC100 equals 800 megabytes per second. So in other words, PC100 RAM can transfer data at a maximum rate of 800 megabytes per second. So an SDRAM module labeled PC133, you multiply 133 by 8, which equals 1066. So the total bandwidth for PC133 equals 1066 megabytes per second. Now technically 133 times 8 actually equals 1064, but 1066 is accurate because the actual clock speed is 133.3333 times 8, which is rounded off to 1066. Another type of memory was called RDRAM, which was developed by Rambus Inc. And they developed the RIM, which stands for Rambus Inline Memory Module. RIMs have 184 pins and look similar to DIMMs, with the exception that the bottom notches are located in the center of the module. In 1999, RIMs were a breakthrough in the speed of memory, but has quickly fallen behind due to the advancement of technology in DIMMs. When RDRAM debuted in 1999, it ran at 800 MHz, which was considerably faster than SDRAM, which ran at 133 MHz at that time. But even though it was a lot faster than SDRAM, RDRAM only had a 2-byte wide bus, compared to SDRAM, which had an 8-byte wide bus. So if you multiply the speed of RDRAM, which was 800 MHz, times the bus width, which was 2 bytes, you will get a total bandwidth of 1600 megabytes per second. As technology increased and processor and bus speeds have gotten faster, a new RAM technology was developed to keep up with the faster speeds of computers. This newer technology was called DDR, which stands for double data rate. And that's basically what DDR does. It sends double the amount of data in each clock cycle compared to non-DDR. Non-DDR, or single data rate RAM, uses only the rising edge of the clock signal to transfer data. But DDR uses both the rising and falling edges of the clock signal to send data, which gives DDR the ability to send twice the amount of data. So here is another illustration comparing the difference between DDR and non-DDR. So even though the system clock is pulsating at the same speed for both RAM modules, the DDR RAM module can send twice the amount of data since it takes advantage of both the rising and falling edges of the clock signal. So even if we speed the clock up and make it go faster, the DDR RAM will still send twice the amount of data compared to the non-DDR RAM. DDR is also labeled differently than non-DDR RAM. DDR RAM may include both the clock speed and the total bandwidth in its name. So instead of just including the clock speed in its name, like PC133, where 133 equals the clock speed, DDR includes the total bandwidth also. So for example, a DDR DIMM labeled DDR333 PC2700, the 333 is the clock speed, and the 2700 is the actual total bandwidth. So 333 megahertz times 8 bytes equals 2700 megabytes per second, which is where we get the name PC2700. A new technology that has succeeded DDR is DDR2. DDR2 is faster than DDR because it allows for higher bus speeds and effectively sends twice the amount of data than DDR. And it also uses less power than DDR. A DDR2 DIMM has 240 pins compared to DDR, which has 184 pins. DDR2 is labeled just like DDR, but with a small difference. For example, a DDR2 DIMM could be labeled DDR2 800 PC2 6400. And the difference is the 2 right after the DDR and the 2 right after the PC. So this is how you can identify DDR2 memory by using its label. And right after DDR2 is DDR3. DDR3 is twice as fast as DDR2, and it also uses less power than DDR2. And just like DDR2, DDR3 also has 240 pins, but the notches in the DIMMs are in different places. So you can't put a DDR3 DIMM in a RAM slot made for a DDR2. In fact, motherboards are made to support a certain type of memory. So you can't mix DDR1, 2, 3, or 4 on the same motherboard. An example of DDR3 would be DDR3 1600 PC3 12800. And the fourth generation of DDR SDRAM is DDR4. DDR4 DIMMs have 288 pins, and like its predecessors, it also uses less power than the previous generation of DDR. DDR4 also offers a higher range of speed than DDR3, such as DDR4 4266 PC4 34100, which has an incredible maximum bandwidth of 34,100 megabytes per second. Now, sometimes there are circumstances where memory data corruption cannot be tolerated. For example, in servers. Servers are meant to be up and running at all times, and some servers cannot afford being offline for any reason, such as servers that control financial data, emergency medical data, or government data. These servers cannot go down for any reason, and that's why some RAM modules have ECC, which stands for Error Correcting Code. And what ECC does is that it detects if the data was correctly processed by the memory module and makes a correction if it needs to. You can tell if a RAM module has ECC by counting the number of memory chips on the module. In a standard non-ECC DIMM, it will have 8 memory chips. But in an ECC memory module, it will have 9 memory chips. Now, most RAM modules today are non-ECC, and this is because of the advance in technology that has minimized memory errors and has made non-ECC RAM more stable. But as stated before, ECC memory is mostly used in servers, because servers need to be up and running at all times, and using ECC memory is just an extra precaution to guard against any memory errors.
After knowing the different types of RAM, let's now proceed with the placement of RAM on your motherboard. So what you are looking right now is an old type of motherboard. So as you can see here, this is the RAM slot, and since it's old, SIM yung gamit niya. And then this one naman is an example of a new motherboard. And then this is the RAM slot, and DIMM yung pinapasok sa slot na yan because this is a new type nga of motherboard. Remember that compatibility is very important when it comes to storing the RAM into your motherboard. Always consider compatibility. Now you may be wondering, how much RAM or what type of RAM do I need for my computer or for my laptop? So I'm going to play this video to know all the things that we need to consider when we're choosing RAM for our computers.
There's a quote often attributed to Bill Gates that goes something like, "No one would ever need more than 640 kilobytes of memory in their computer." Well, turns out he never actually said that, but it got us wondering, how much RAM do you actually need in modern times? Well, let's start with the kind of RAM that most of us are familiar with, the main system memory living inside your desktop or laptop PC. It's quickly becoming common for budget computers to come with 4 gigabytes of RAM, while mid-range machines often have 8. On the higher end, 16 gigs or even 32 gigs of memory is easy to find, but is it worth paying a premium for that? Here's the deal. Unless you're seriously cash-strapped, it's worth getting at least 8 gigabytes, even if you're not planning to do anything with your computer beyond basic productivity, web browsing, and watching fine YouTube videos like this one. Many common tasks are quickly becoming memory hogs. Even Google Chrome can eat into your memory very quickly and take up a few gigs if you've got a lot of tabs open. And while the browser does use a technique called tab discarding, which removes unused tabs from memory and then reloads them when you access them, you'll still get a noticeably smoother experience for everyday tasks if you don't skimp too hard on your RAM. But what if you're gaming? Well, the answer becomes a little more complicated. You see, many big budget titles these days recommend 16 gigs of memory. But the thing to keep in mind is that system requirements for games often are not validated well, which you can learn more about right up here. It turns out that many games that ask you to use a system with 16 gigs of RAM can actually get by just fine on 8 with only a very marginal performance drop, if any. However, as games get more complex, this may not be the case in the near future, especially as some games actively do make use of more than 8 gigs of system memory, and only having 8 gigs can also hinder your ability to do anything else while you're playing a game, such as streaming. So we'd recommend 16 gigs as a sweet spot for gamers and especially streamers, unless you're playing less resource-heavy titles. Of course, many motherboards have 4 RAM slots, which makes upgrading to 32 gigs a cinch if you've got the money. But investing in this much is probably only worth it if you're working with lots of data at once, such as large photo sets or editing high-resolution video, and especially if you're multitasking, creating high-resolution video with, edited photos in it. Furthermore, with how long it takes certain kinds of media files to render, you'll probably want to use your rig for other things while your content renders in the background. And this is where having 32 gigs of memory, or more if you're into that whole 8K thing, can really come in handy. As for 3D modelers, animators, or scientists, well, their memory requirements are basically limited only by the size of the scenes or the data sets that they're working with. Sounds expensive. But what if you're trying to figure out how much graphics memory, or VRAM, you need on your graphics card? Even if 2 cards have the same graphics processing unit, or GPU, they can actually have different amounts of VRAM, and benchmarks often focus more on the GPU itself than on how it performs across its various memory configurations. So remember that the primary purpose of VRAM is to hold the graphics information that the GPU acts upon, meaning that higher resolution gaming and higher resolution textures will require more VRAM. This is also the case if you're using certain types of anti-aliasing that involve rendering at effectively higher resolutions, such as supersampling anti-aliasing. Many mid-range cards come with 4 GB of VRAM, which, as a general rule, should do you fine for 1080p gaming as of filming this video. But you'll want at least 6 for 1440p and about 8 or more for 4K. Just be sure to read reviews for the titles you want to play, because some particularly demanding games, or especially third-party mods like high-resolution texture packs, might mean that a card with slightly more VRAM would be a great investment if you want to play at high quality. Running out of VRAM can render, no pun intended, certain games completely unplayable if you try to bump the resolution up too much, meaning that 4K monitor you just shelled out a bunch of money for won't be living up to its full potential. Kind of like that gym membership that you only use twice per year. Or not at all right now. Ooh. Hand sanitizer, quick. Thank you. We didn't even stage that. He just had hand sanitizer on hand. Speaking of having things on hand, my segue to our sponsor.
Thank you for watching and keeping up with my video. I hope you understand all the important key points of this topic.
Yon. Magandang umaga sa inyo, kapwa ko BSIT. At sa inyo po, Sir Louie Kanding. Ako po si AC De La Cruz na itatalakay sa inyo kung ano ba ang processor, ano ba ang nagagawa nito, at ano ba yung kahalagahan ng isang processor sa isang system unit. At talakayin na nga natin. Bago muna yun, may katanungan muna ako sa bawat isa. Sa tingin nyo ba ang mga electric fan, ceiling fan na nakikita natin sa ating mga bahay ay merong processor? Kung sagot mo ay hindi, na walang processor, ay tama ka. Dahil hindi naman sila nagpe-perform ng processing. Gumagawa lamang sila ng switch on and off. Ganun lang ang pinoperform nila, switch on and off. Kaya wala silang processor, walang processing. Italakay na natin ang processor. Ang processor or microprocessor ay isang chips na part ng isang system unit. Na kung ibabase natin to sa katawan natin, at ito'y masasabi kong utak. Bakit utak? Dahil dito nagpe-perform ng mga information. Pumapasok sa input devices at mapupunta sa memory unit at lalabas na output devices. Lalabas yan na nagpe-perform ng mga audio, speaker, kaya makikita natin sa ating screen.
According to Techopedia, a processor is an integrated electronic circuit that performs the calculation that run a computer. A processor performs arithmetical, logical, input-output, and other basic instruction that are passed from an operating system. Most other processes are dependent on the operations of a processor.
Tatlong functions ang isang processor. At ito'y fetching, decoding, at executing. Sunod-sunod yan. Cycle, ulit-ulit, hanggang sa maubos ang instructions. Meron namang dalawang parts ang isang processor. Kung kanina function, ngayon naman parts nito. At dalawa yun. At ito yung ALU, Arithmetic Logic Unit. Siya yung bahala sa mga mathematical operations katulad ng addition, subtraction, multiplication, division at iba pa. At ang isa naman parts ng processor ay ang CU na ang ibig sabihin ay control unit. Siya naman yung nagko-control ng ating mga information. Para ba siyang traffic enforcer na inaayos kung saan ba ilalagay yung mga information na pinapasok natin sa isang processor. Ay ibabahagi ko sa inyo kung ano ba yung CPU at ang GPU. Kahit sila'y parehong microprocessor pero may pagkakaiba sila kung ano ba yung ginagawa nila sa isang device. Kung ano ba yung ginagawa nila sa isang mga device na nakikita natin like computer, cellphone, tablet, or laptop. Lahat yan may CPU at GPU. Pero kung ano ba yung pagkakaiba na ginagawa nila? Simple lang. Ganito kasi yan. Sa isang part ng isang system, meron siyang ginagawa na hindi kayang gawin ng isa. At ang isa naman may ginagawa na hindi kaya na gawin ng isang part. Ang CPU, ang ginagawa niyan, siya yung process ng mga information na nakukuha natin. Siya yung kumukuha nito. Siya rin yung naglalabas nito. Kumbaga, siya yung nagbabalance ng mga information din na nakukuha ng isang device. Like, kahit marami, nababalance niya. Siya yung bahala ron, ang CPU. Ang GPU naman, siya naman yung bahala sa graphics ng isang device. Isa lang ang purpose nito. Pero malaki yung bagay ang nagagawa nito. At ayun yung magpaganda ng graphics. Halimbawa na lang, naglalaro ka, isa kang gamer. At ito, yung unang tinitingnan nila, yung graphics, yung GPU. Kung mataas ba to o hindi. At kung mataas ang GPU nito, ayun ang karamihan binibili nila. Kasi mas maganda maglaro sa isang malaking device na malaki ang GPU. Na mas mapapaganda yung paglalaro mo, mas mapapaganda yung pagnonood mo ng mga videos like movies, vlogs. Ayan ang nagagawa ng GPU. Ngayon ay nalaman nyo na kung ano ba yung CPU at ang GPU. Alam nyo ba ang processor ay merong siyam na factors. Factors na kailangan nating alamin bago tayo bumili ng isang device na merong processor. Alamin na natin ang architecture. Dito mo malalaman kung ano lang ba yung kakayahan ng isang microprocessor. At dito natin makikita ang 64-bit at 32-bit. Naririnig natin yan sa mga device. At kung ang device mo na may 32-bit, ito lang yung maximum na kakayanin ng isang device. 32-bit lang ang kayang i-handle ng iyong device. Kung dito mo titingnan sa architecture, ito ang makikita mo, yung mga kakayahan ng isang microprocessor. Ang pangalawa naman ay ang core. Kung ang isang processor ay binabase natin sa utak ng tao, ang processor rin naman ay meron ding utak. At ito yung core. Siya yung nagko-compute ng mga information data na pumapasok sa isang machine, sa isang device. Na halimbawa lang, merong tao na maraming bunganga. Kunwari lang na merong tao na maraming mga 3 bunganga na marami kang makakain, marami kang papasukan na mga kakainin mo. Ganun ang isang core. Ganun ang isang processor. Na kung marami ang core sa isang processor, ay ganun din kabilis yung mga information na papasok. Ganun din karami yung mapaprocess na isang information sa isang processor. Kaya kung pipili ka ng isang processor, tingnan mo yung core. At ito yung nakikita natin na dual core, quad core. At ito yun, yung core na binabahagi ko sa inyo. Naman ay ang clocking speed. Tiyak narinig na natin yung salitang gigahertz. Yung 1 gigahertz, 2 gigahertz, 3 gigahertz processor. Ang salitang giga ay binase sa salitang billion. At ang hertz naman ay per second. At ito yung bilis na pinaprocess ng isang processor. Yung gigahertz. Kung ang gigahertz mo ay 2 gigahertz, ang ipaprocess nito, ang isa cycle nito ay billion per second. 2 billion per second ang ipaprocess nito. At ganun yun kabilis. At ito yung nire-recommend ko sa inyo na tingnan nyo bago kayo bumili ng isang processor. 4 naman na factors ng iyong processor ay ang CPU cache. Ang CPU cache, isa ito sa memory na makikita sa iyong device, sa iyong processor. Di katulad ng RAM, ang RAM nakikita ito sa iyong system unit. Dito mo ito matatagpuan sa mismong iyong computer, sa mismong device na meron ka. Ang CPU cache naman, matatagpuan ito sa iyong processor. Ito mismo sa processor, ang CPU cache, ito mismo yung memory na meron ang iyong processor. Ang ginagawa nito, ito yung nag-iimbak ng mga impormasyon na pumapasok sa iyong processor. Kasi merong ang RAM na hindi kayang gawin ng CPU cache. Ang RAM, mas malaki ang storage nito kaysa sa CPU cache. Kumbaga ba, tinutuloy lang ng CPU cache ang ginagawa ng iyong RAM. Kaya kung merong hindi kaya ang iyong RAM, ang CPU cache na ang bahala dito. Ang panglima sa factors ng iyong processor ay ang lithograph. Ang lithograph, guys, ay scale ng iyong processor. Ito yung mga numbers na nakikita natin sa isang processor. At ang tawag sa iyong lithograph ay tinatawag ding nanometer o NM na nakikita natin sa isang processor. Kung gaano kababa ang iyong nanometer, ay ganun din yung kaganda na yung nagagawa ng iyong processor. Kasi kung titingnan natin, ang isang nanometer, isang salita niyan, ang katumbas na word niyan ay ang 1,000,000 beses. Ganun kaliit ang salitang nanometer. Kaya kung nasa 14 nanometer or nasa 7, 5 ata ang latest 5 nanometer, ganun kaganda yung ang iyong processor. Ano ba yung nagagawa ng nanometer sa iyong processor? Simple lang, nagagawa nitong malis yung consume ng iyong energy o ng computer. ng iyong kuryente sa bahay. Mababawasan nito yung pag-consume ng iyong kuryente, yung consumption. At ang less ng init ng iyong system unit. Mababawasan yung init ng iyong computer. Kaya mas cooler yung iyong processor kapag mas mababa ang iyong nanometer. Pang-anim naman sa ating factors ay ang TDP o Thermal Design Power. Ang Thermal Design Power, dito pinapakita ang average ng iyong kuryente o ng power ng watts. At kung mababa ang TDP, mababa din ang power na makukuha natin. At hindi lang yun, mababa din ang makukuha nating heat sa ating system unit. At ito rin ay nagpapakita na mas magiging cooler ang iyong processor. At less na magiging maganda ang iyong system unit. At may iwasan nito ang overheating. Pero iba ito sa lithograph. Ang lithograph, bumabase ito sa transistor na meron siya. Ang TDP naman ay bumabase ito sa watts na kukuha nito. Ito naman po ay ang support your memory or yung RAM. Katulad na sinabi ko sa architecture, ang architecture ay dito mo malalaman kung ano lang yung kakayahan ng iyong processor. At sa RAM naman, support your memory, ay kumbaga susuportahan mo lang ang iyong RAM. Kung ano lang ba yung kaya ng iyong RAM, ng iyong architecture, ganun lang din dapat, ibase lang natin sa RAM na meron tayo. At suggest ko lang sa inyo, sa mga gustong pumili ng RAM, ay sasuggest ko sa inyo yung 8 gig RAM lang. Bakit ko sinasuggest yung ganito? Kasi kung di ka naman nagmo-multitasking, kung wala ka namang maraming ginagawa, 8 gig RAM lang ang piliin natin. Kasi ang 8 gig RAM ay mas fit na sa yung computer system, sa yung system unit. At kaya na nitong gampanan ang kanyang magagawa sa yung system unit. Kaya na nitong mas pagandahin ang takbo ng iyong computer para mas matipid din ang mga gastusin na meron tayo. Kasi kung mas pipiliin natin na bumili tayo ng mas mataas na RAM, ay nasa sa'yo yun. Kasi kung ikaw naman ay isang editor, isang vlogger, o mga streamer, ganun, ay mas maganda bumili ka ng mas mataas na RAM sa 8 gig. Mas mataas na sa RAM na 8 gig. Ayun lamang. Ang pangwalo sa ating factors ay ang overclocking. Ang overclocking ay hindi naman masyadong recommended para sa pagbili ng iyong processor. Kasi ang overclocking ay delikado sa ating system unit, sa ating computer. Bakit ko nasabing delikado? Kasi ito ay nagpapabilis nga ng iyong computer pero may kapalit. Ito ay may consumption ng power mas mataas, mas malaki yung nakukuhang power nito, at mas mapapainit nito ang iyong system unit o mag-overheat ang iyong system unit. Kaya ang pag-overclocking ay di masyadong recommended. At mas maganda pa na unahin natin ang kaligtasan natin bago yung kasiyahan natin. Kaya ang overclocking ay sinasabi kong iwasan natin. Kasi ang overclocking ay ginagawa lamang ito ng mga gamers. Kumbaga ba, mas maganda, mas pinapaganda nila ang paglalaro nila. Mas pinapabilis nila yung FPS nila o yung pagtakbo ng games nila. Kaya sila nag-overclock. Pero ang may kapalit naman may kapalit na delikado. Kaya hindi recommended ito para sa ating mga gustong pumili ng isang processor. Ang panghuli naman ay ang hyperthreading. Itong hyperthreading inimbento para mas mapabilis pa ang iyong processor. At ito'y bumabase sa course na meron ang isang processor. Kung ang processor mo ay meron 2 cores, ay imumultiply ito sa 2. Kung ang 2 cores mo ay magiging 4. Magiging 4 yung bilis na meron ng isang processor. Ganon ang ginagawa ng hyperthreading. Halimbawa na lang, meron kang 2 cores. At ito ay ibase natin sa halimbawa may alila ka, 2 alila, 2 kasambahay. At meron kang pinapagawa na linisin ang bahay mo, linisin ng mga gamit, linisin ng mga kumbaga ba ay inuutusan mo sila na maglinis sa iyong bahay. At dadalawa lamang sila. At yung isa mong katulong ay ginagawa ay naglalaba at nagluluto. Halimbawa lamang. At yung isa naman ay gumagawa ng nagsasampay at nagpapakain ng mga iyong mga anak, ng iyong mga kasama sa pamilya. Ganun ang hyperthreading. Kung ang isa mong course ay kung meron kang isang course, idodoble nito yung gagawin ng iyong course. Yung hyperthreading, ito yung magdodoble ng gagawin ng iyong course. Ganun ang hyperthreading. Ayun ang siyam na factors ng ating processor. Sa mga nabanggit ko naman ay ito'y para sa ikagaganda, sa ikabubuti ng iyong system unit, ng iyong computer. At sana napaganda ko yung pagtingin nyo sa isang processor. At sana mas maging veteran tayo sa pagpili ng ating processor. Wag bang maging bahala na sa pagpili ng processor. Maging mabusisi tayo sa ating pagpili kasi ito'y para naman sa kaligtasan ng sarili natin at sa iyong system unit. Ayun lamang ang aking mababahagi sa ating factors ng ating processor. At sa susunod naman na ating tatalakayin ay merong 5 types ang isang processor. At ito ay ating tatalakayin na. Ang 5 types ng ating processor ay ang microprocessor, microcontroller, embedded processor, digital signal processor or DSP, at media processor. Ang microprocessor ay mas higit pa sa processor at sa iba pang klase ng processor. At ito'y walang RAM, ROM, and other peripherals on the chip. Microprocessor adds on application na kung saan ang task ay unspecific like developing software, games, photo editing, websites, creating document, at iba pa. Microprocessor ay bahala sa mga BIOS at mga circuits bilang karagdagan sa paggawa ng lahat ng pag-andar ng ating CPU. Microcontroller ay binuo noong pagkatapos ng microprocessor, na kung saan siya ang gumaganap sa mga hindi kaya ng microprocessor. Ang chip nito ay sinama gamit ang CPU, RAM at ROM. Hindi tulad ng microprocessor, ang controller ay hindi nakasalalay sa iba pang mga unit ng hardware. Naglalaman ito ng mahalagang blocks para sa magandang paggana. Ito ay napakahalaga kaysa sa microprocessor sa larangan ng mga embed na system dahil mas mabisa ito at madaling magamit. Ito ay nagsasagawa ng mga gawain na itinutukoy ng gumagamit, na kung saan pinangangasiwaan nito ang mga parehong gawain para sa buong ikot ng system. Embedded processor ay ginawa para i-control ang electrical and mechanical functions. Simple lang ang design nito, limitado sa computational power at sa I/O capabilities, at merong itong minimal power requirements. Digital signal processor ay dinisenyo para sa signals katulad ng voice, audio, video, temperature, pressure, at mathematical functions. Media processor ay dinisenyo para sa creation at distribution ng digital media. Ito ay ginagamit para bumuo ng multimedia subsystem, na kung saan pinaprocess nito ang iba't ibang combination ng audio, video, graphics, at modern operation. Ngayon naman ay mag-focus tayo sa microprocessor. Ang microprocessor ay unang inimbento noong late 1970s. Ito ay nagtatagal na ng 51 years. At sa tagal nito, marami nang naimbentong klase ng microprocessor. At ang unang nag-imbento ng microprocessor ay ang Intel Corporation, na siya ang nag-lead sa mga ibang kumpanya para gumawa ng microprocessor. At nagtagal ay ang Intel lang naunguna sa mga paggawa ng microprocessor. Ngayon ay may papanoorin tayong video na kung saan ang nilalaman nito ay ang evolution ng microprocessor na ginawa ng Intel Corporation.
Intel Core are Central Processing Unit or CPUs offered by Intel Corporation, standardized medium-range customers, workstations, and enthusiasts. There was a mistake, often offered for server and workstation markets, are similar or more capable models of core processors as Xeon processors.
Napansin natin doon sa video na ang microprocessor na unang mga ginawa ay mahina at mabagal pa. At habang tumatagal, nag-upgrade ito at bumibilis ang kapasidad nito sa isang computer. At kung ano man yung ginagamit mo ngayon na sa panonood nito, kung nanonood ka sa computer, sa laptop, at sa mga cellphone, ito yung mga mabibilis na microprocessor na nagagamit natin ngayon. At ayun lamang po ang aking maibabahagi sa inyo. Salamat po sa pakikinig. At ang susunod sa aking magtatalakay ay si Carl James. Siya ang magpapaliwanag sa AMD processors. Yung iba't ibang uri ng AMD processors.
When we talk about processors, two big companies came first to our mind, right? It is the Intel and the AMD. Intel is the most popularly known because Intel became the #1 supplier of the microprocessors. But now, let's talk about the main competitor of Intel when it comes to microprocessors, the Advanced Micro Devices or AMD. Advanced Micro Devices Incorporation, AMD, is a Santa Clara, California-based American multinational semiconductor corporation designing computer processors and related technologies for enterprise and consumer markets. AMD was formerly incorporated by Walter Jeremiah Sanders III and his 7 colleague in Fairchild Semiconductor in May 1, 1969. AMD products mainly focus on microprocessor, but they also build motherboard chipset, graphics processors, and mobile processors for supercomputer, workstation, personal computer, and etc. The evolution of AMD processors. AMD has focused on manufacturing microprocessors and related computer components since its inception in 1969. Initially, processor designs from other companies including Fairchild Semiconductor were merely approved. Now, let's watch this video of evolution of AMD CPUs and tackle about it. The first ever AMD CPU was built in 1975. It is the AM9080. AMD entered the microprocessor market with the AM9080. It is a reverse engineered clone of the Intel 8080 made by taking features of the Intel 8080 die using a microscope. So this CPU was an unlicensed clone of AMD to the Intel product or the Intel 8080. But way back 1982, when the 10-year agreement or technology exchange agreement of AMD to Intel, AMD became the second manufacturer of Intel 8080, which is the AM9080. With that, this CPU was composed of 2 to 4 MHz clock speed, 8-bit and a single core processor type, composed of 4,500 transistor count and a 6,000 nanometer fabrication process. Nanometer is about the size of the transistor. That makes sense when it comes to the speed of a CPU. Later on, I will explain why the smallest nanometer or the smallest transistor size are better in nowadays, like the latest Ryzen 9 or the Zen 2 core architecture that has a 7 nanometer. The next in the line is the AM8086 in 1982. AMD signed a contract with Intel, so that is what I stated before, that AMD and Intel did a technology exchange agreement as AMD become the second second manufacturer or second source manufacturer of Intel. So it is a licensed clone of the Intel 8086. Intel was actually forced by IBM to license its technology to AMD because IBM wanted to at least 2 CPU suppliers for its PC. And this CPU is composed, it's built with 5 to 10 megahertz clock speed, a 16-bit single-core processor type, a 29,000 transistor count, and a 3,000 nanometer fabrication process. In 1984, AM286 was built by AMD, and it is a clone of Intel 80-286, manufactured under license but with a AMD logo on it. It had one big advantage over its Intel counterpart. It has higher clock speed. So aside po, siyempre hindi naman kailangan na whenever you are licensed as a second source manufacturer, hindi naman kailangan na lahat ay ika-copycat mo. So with this, AMD make an advantage move with the Intel product, or the clone of the source of the cloning of the AM286, which is the Intel 80-286. And the advantage that AMD gave to this is the higher clock speed. So with this, it has a composed of 6 megahertz and 220 megahertz clock speed, and a 16-bit but a single core also processor type, 134,000 transistor count, and a 1,500 nanometer fabrication process. The AM386 in 1991 is an unlicensed clone of the Intel 8386. It took AMD around 18 months to reverse engineer the Intel 8386. So, in this year, Intel and AMD agreement was expired, and AMD start from being a copycat again to Intel products. But this processor, or the Intel 8386, took AMD 18 months to clone or reverse engineer it. The M386 had better performance, ran cooler, used less power than its Intel counterpart, and paved the way for making PCs more affordable. So aside from so siguro hindi na rin hindi talaga nag-i-stay sa being copycat yung AMD, but they want to angatan yung Intel sa kanilang mga produkto, like this AM386 that has had better performance and a better cooling system, run cooler because it less power consumption, and most importantly, it is cheaper than Intel product or Intel 8386. So this CPU has 20 MHz to 40 MHz clock speed, a 32-bit single core processor type. So in this CPU, papasok tayo sa 32-bit processor processor type ng isang microprocessor, and also this has a transistor count of 275,000 and a fabrication process of 1,500 to 800 nanometer. Two years later, in 1993, AM486 is also an unlicensed clone of the Intel 8486, but offered better performance for cheaper prices. In fact, AMD's higher clock 486 chips provided superior performance to many of the early Pentium chips, which helped AMD capture 40% market share by 1995. So, sa mga taon na to, nakikilala na yung AMD sa pamamagitan ng nakikilala sila bilang a major competitor of Intel that has or that nagpapatong ng cheaper price than the Intel product. So it is siguro business what to call that, strategy of the AMD para makasabay sa production ng AMD. But yes, it is also unlicensed clone, it's still an unlicensed clone of Intel products. So this CPU has 33 MHz to 120 MHz clock speed, a 32-bit single-core processor type, 1.2 million transistor count on it, and a 700 to 350 nanometer fabrication process. In 1995, AM5x86 was born. Contrary to its namesake, the 5x86 was not based on Intel's 5th Gen x86 architecture, but instead was an enhanced version only of the AM486 chip. AMD still named this 4th Gen chip with the 5th Gen naming scheme because people were more likely to buy a chip with 5th versus 4th. So sa mga panahon na yon, ang inahanap ng tao is yung innovation. So Intel produces the 5th Gen processor. So AMD adopt the business idea of naming their latest microprocessor as a 5th Gen, but still it only a 4th Gen chip. So with this CPU, it has 133 MHz to 150 MHz clock speed, a 32-bit single-core processor type, 1.6 million transistor count, and a 350 nanometer fabrication process. After being copycat for Intel and after the 5x86, in 1996, AMD K5 was the first x86 processor to be developed entirely in-house by AMD. It competed against the Intel Pentium microprocessor range. The K in K5 stands for Kryptonite, indirectly hinting AMD is the kryptonite to their competitor Intel. So, pagkatapos ng ilang taon or isang dekada of being a copycat to Intel, AMD decided to make their own processor and conventionally naming it as Kryptonite, indirectly patama to the Intel na sila yung magiging matindi nilang kalaban. So with this CPU, it has 75 MHz to 133 MHz clock speed, a 32-bit and a single-core processor type, 4.3 million transistor count, with a fabrication process of 500 to 350 nanometer. A year after, in 1997, K6 was born by AMD and competed against the Intel Pentium 2 processor. It provided better performance than Pentium 2, but at a significantly lower price. The K6 helped drive PC prices below the 1,000 mark for the first time and gain wide acceptance in the PC market. So, AMD needs na makasabay sa Intel by giving the siguro pagkakakilanlan na AMD processor was made to become the cheaper price than the Intel. And aside from being a cheaper prices, it can outperform the Intel product. So with this, AMD CPU of K6 is composed of 166 MHz to 300 MHz clock speed, a processor type of 32-bit, and a single core 8.8 million transistor count with a fabrication process of 350 to 250 nanometer. The AMD K62 in 1998 was essentially an enhanced version of the K6 with a faster bus, higher clock speed, and a 3D Now technology. So, pagdating sa processor na to, ito only an enhanced version, but it composed of a faster bus. Bus will later discussed by my co-group mates and tackle the deeper part of it. And this K62 has integrated 3D Now technology. So AMD innovate more with this CPU. The K62 processor were highly successful with some models continued to be manufactured well past K63 and K7 introduction. 166 MHz 5v3 MHz clock speed is in this CPU, a 32-bit single-core processor type with a 9.3 million transistor count and a 250 to 180 nanometer fabrication process. In 1999, K63 was an enhanced version of the K62 with a 256 KB L2 cache integrated on the same die. The K63 was very fast but also very costly to produce and was quickly replaced by the Athlon. This AMD CPU has 350 MHz to 550 MHz clock speed, 32-bit single-core processor type, 21.3 million transistor count, and a 250 to 180 nanometer fabrication. As K63 didn't pass or hindi nagtagal sa market because of the high cost of producing it, AMD quickly replaced it with the AMD Athlon in 1999. Athlon was the first desktop processor to break the 1 GHz CPU clock speed barrier. Athlon was also the first processor to utilize copper fabrication, which made it the fastest x86 processor in the world. So, AMD now start to build history of their microprocessor and start with this Athlon that break the 1 GHz CPU clock speed, and it also the first processor to utilize copper fabrication. With it made the fastest x86 processor. So with this, the clock speed of AMD Athlon is ranging from 500 to 2.33 GHz, and a 32-bit single-core processor type, 37.2 to 54.3 million transistor count, and 250 to 130 nanometer fabrication process. Don't mind the misspelling of the AMD Duran, but it is AMD Duran in 2000 and introduced as a way for AMD to aggressively compete against Intel Celeron in the ultra-cheap PC segment. The Ron models were cheaper and had superior performance over their Celeron counterparts. So, pagtapak ng 2000 ng 90s on the 19th century or the early 2000th century, 20th centuries, AMD still want to outperform the Intel by doing this AMD Duran with ultra cheap PC segment to compete the Intel Celeron. This AMD processor outperformed the Celeron counterparts because it has 600 MHz to 1.8 GHz clock speed, a 32-bit single-core processor type, 37.2 million transistor count, and a 180 to 130 nanometer fabrication process. In 2003, AMD Opteron was the world's first x86-based 64-bit processor. The Opteron processors are designed for workstation and servers and are a direct competition to Intel Xeon processor. Intel Xeon processor was used by the Mac, Mac computer way back 2000, 2002, 2003. But this is Intel Xeon was used by the Macintosh. So this AMD CPU has 1.4 GHz to 3.5 GHz clock speed, a 64-bit 1 to 16 cores processor type. So nandito na tayo sa mga processor that has multi-cores or can do a multitasking. So it also has 114 to 904 million transistor count and a 130 to 28 nanometer fabrication process. So this nanometer, masyado tayong lumada na tayo sa bumababa na tayo sa mga 2-digit nanometer fabrication process. This is the Athlon 64 in 2003. The Athlon 64 was the first x86-based 64-bit desktop processor. It competed against the Intel Pentium 4 processors. In 2005, AMD released the Athlon 64 X2. The naming convention is most likely the same with the Windows OS. It is the Windows XP. Or X2 or XP, right? Yes, but it is based on that this was made AMD's first dual-core desktop processor series. It has a 1 GHz to 3.2 GHz clock speed, 64-bit 1 or 2 cores processor type. So this AMD Athlon 64 only a dual-core processor type, composed of 105.9 to 234 million transistor count and a 130 to 65 nanometer fabrication process. And this is the rise of the Athlon CPUs. In 2004, Sempron replaced the Duron as AMD's new budget desktop processor. The Sempron competed against Intel's Celeron series and did fairly well. It has 1 GHz to 2.9 GHz clock speed, 32 or 64-bit, 1, 2, or 4 cores thread, 4 cores, oh, no, it's not thread, 1, 2, or 4 cores processor type, 37.2 to 103.1 million transistor count, 130 to 28 nanometer fabrication process. The Turion processors in 2005 were designed for low power consumption mobile processor segment. The Turion processor competed against Intel mobile processor, initially the Pentium M and later the Intel Core and Intel Core 2 processors. It has 1.6 GHz to 2.7 GHz clock speed, 64-bit, 1 or dual cores processor type, 114 to 153.8 million transistor count, 90 to 45 nanometer fabrication process. The AMD Phenom in 2007 is the Phenom series is targeted at budget desktop processor market and competed against Intel's Core 2 series. It came in two versions, triple core version called Phenom X3 and quad-core version called Phenom X4. It has 1.8 GHz, 2.6 GHz clock speed, 64-bit, triple core and quad-core processor type, 450 million transistors count, and 65 nanometer fabrication process. The Phenom 2 in 2009 resolved many issues that the original Phenom had and had good overclocking potential. So, overclocking was making your base clock speed to its limit and going it higher. Example, if you have 2.4 GHz clock speed with a maximum of 3.7 GHz clock speed, basically your 2.4 GHz base clock speed, you're going to overclock it until it gets the maximum, or it can also be yung lagpas or lagpas from its maximum gigahertz. But overclocking nowadays needs an overclockable motherboard, like the B450 series, the X series, and so on. So in 2009, AMD broke the world record for the fastest quad-core processor by hitting a speed of 6.93 GHz on a Phenom 2 X4 processor. So with this, we only have 3.7 GHz in this clock speed, which pertaining as the base clock speed. And you can see that the AMD broke the world record of gaining a 6.93 GHz on a Phenom 2 X4 processors. 2.4 GHz, 3.7 GHz clock speed, 64-bit, dual, triple, quadruple, and 6-core processor type, 78 million transistor count, and 45 nanometer fabrication process. The FX series in 2011 by AMD is targeted at the desktop processor market and competed against Intel Core series. In 2011, AMD broke the Guinness World Record for the fastest processor by hitting a speed of 8.429 GHz on the FX processor. So sa mga taon na to, AMD really start to outperform Intel's performance and start to break a multiple world record when it comes to the processing speed. It has a 2.8 to 5 GHz clock speed, 64-bit, 4, 6, or 8 cores processor type, 1.6 billion transistor count, 32 to 28 nanometer fabrication process. The AMD Fusion A and G series in 2011 combined the CPU with a GPU on a single die. The A series is targeted at the desktop market and the G series at the embedded market. The Sony PlayStation 4, Microsoft Xbox One, and Nintendo Wii U use semi-custom AMD Fusion processors. So, speaking of G series, 'di ba? Marami tayong sa ngayon sa mga processors natin ngayon. May mga processors tayo na pagkatapos ng kuhari AMD Ryzen 3, may mga number pa, then may letter pa sa dulo. So, when you see an CPU with a G in the last serial number of it, G in letter on, it is an integrated. It has integrated GPU. It's like the Ryzen 3 3200G with the Ryzen with the integrated Radeon Vega 8 graphics. Yes. And this CPU has 2.1 GHz to 3.9 GHz clock speed, 64-bit 2 or 4 cores processor type, 1.2 to 4.95 billion transistor count, and a 32 to 14 nanometer fabrication process. And here's come the Zen architecture legacy. It is the Ryzen 3 by AMD in 2007. It is an AMD new entry-level processor line for both desktop and laptops. The Ryzen 3 is positioned against the Intel Core i3 processor, offering the competitive performance at lower prices. But nowadays, Intel Core i3 is way cheaper than the Ryzen 3 due to the supply and demand on the market. Ryzen 3 now is ranging for about 5 to 7,000 pesos. However, the Core i3 is ranging now from 3 to 5,000 pesos. It has 3.1 GHz to 3.7 GHz clock speed, 64-bit 2 or 4 cores processor type, 4.95 billion transistor count, and has a fabrication process of 4 to 12 nanometer. This is the Ryzen 5 by AMD in 2007. It is targeted at the mainstream desktop and laptop users. The Ryzen 5 is positioned against the Intel Core i5 processors, offering competitive performance at lower prices. Mostly, Ryzen 5 uses to entry to mid-range processor. It is now commonly used by gamers because games nowadays needs a higher CPU to perform its best, and Ryzen 5 can do it more. But also Ryzen 3 can do a light gaming as intended to entry level position only, unlike the Ryzen 5 which can be in the which is in the mid-range processor. It has a 3.1 GHz to 3.8 GHz clock speed, a 64-bit 4 or 6 cores processor type, 5.99 billion transistor count, and 14 to 7 nanometer fabrication process. This nanometer is now in the Zen 2 architecture of Ryzen 5. So, but Ryzen 3 is not part of the Zen 2 Zen 2 architecture. It is part of the Zen 1 that still can Intel i3 outperform. But in terms of gaming, Ryzen can outperform Intel Core i3. And the Ryzen 7 into 2017 are targeted at the high-end performance desktop and laptop user. The Ryzen 7 is positioned against Intel's Core i7 processors, offering competitive performance at lower prices. Ryzen 7 is widely used for making a multiple tasks at the same time, like a video editor, and a video creator or content creator, or any apps that uses a high end CPU, and this Ryzen 7 can make it. And Ryzen 7 AMD CPUs has 2.8 GHz to 3.9 GHz clock speed, 64-bit and quad octa-core processor type, 5.99 billion transistor count, and 14 to 7 nanometer fabrication process, still in the Zen 2 architecture. The AMD EPYC. The EPYC line of processors are targeted towards the server and the embedded system markets. EPYC replaced AMD's Opteron family of server processor. This AMD EPYC is used from bigger the supercomputers like servers and embedded system markets. It has 2 GHz to 3.2 GHz clock speed, a 64-bit octa-core to 64 cores processor type, 39.54 billion transistor count, and a 14 to 7 nanometer fabrication process. The Ryzen Threadripper. The Threadripper line in 2017 is geared towards prosumers who rely on heavily threaded application and multitasking. The Threadripper processors have the highest core and thread count of any current consumer-grade processors. It has 3 GHz to 3.8 GHz clock speed, 64-bit octa-core to 32 cores processor type, 23.54 billion transistor count, and a 14 to 7 nanometer fabrication process. And now the latest AMD Ryzen 9 processor of AMD in 2019 are marketed towards the high-end enthusiast desktop market, providing the highest level of performance. The Ryzen 9 is positioned against Intel's Core i9 processors, offering competitive performance at similar prices. 3.1 GHz, 3.8 GHz clock speed is in this CPU with a processor type of 64-bit, 12 to 16 cores, and at 9.89 billion transistor count, and a 7 nanometer fabrication process peaks. And that's the AMD processors. Before going to the Mac CPUs or the Macintosh CPUs, I just want to add why smaller nanometers are better, are vital to a CPU. These transistor size are vital because the smallest nanometer can provide a faster speed to the CPU. So the smallest your transistor size, it's the better, and it's way faster than that. So because of that, AMD outperformed the Intel nowadays, as Intel become the second fastest CPU and AMD top of it, because Intel really stuck at the 14 nanometer architecture. But now I think the Intel Core i9 10th generation can kaya may pagsabayan sa Ryzen 9 na 5th gen nowadays, because I think binago na ng Intel yung kanilang architecture in the Intel 9 Core i9 10th gen. Disclaimer, what I'm saying here is this came from the different article that I read in the internet, and based on the article, AMD now outperformed the Intel when it comes to the processing speed. And now let's go to the Macintosh processors. The Mac processor. Now let's talk about history of Mac Apple computer processor. Diba, so sa natin sa Intel and AMD, lagi natin naisip na ito ay para lamang sa mga Windows computers, di ba? Sa mga desktop, Windows desktop. But napapaisip ba tayo na what is inside the Mac computers? So here it is. In 1984 to 1995, the Motorola 68K series is the first processor of Mac. The first Apple Macintosh processor was the Motorola 6800. It had 32-bit CPU registers, a 24-bit address bus, and a 64-bit data pad. It was called a 16 to 32-bit microprocessor by Motorola. Diba? Di natin napansin na aside from Intel and aside from AMD, there are other companies like Motorola, like Qualcomm, and other more processor company. In 1994 to 2005, Apple announces it switched to the PowerPC processor. The PowerPC 601 was the first Mac processor to support the architecture of 32-bit PowerPC instruction set. It is built by Motorola and IBM, integrated by IBM and Motorola. In 2006 to 2020, Intel was the processor of the Macintosh in laptops and in desktop. Apple announced that its transition to Intel chips at WWDC in 2005, and the first Intel Macs were announced in early 2006. This included an iMac and a MacBook Pro, which were almost 4 times more powerful than their predecessors. And this an example of the Intel CPU that Mac uses is the Intel Xeon processor. And the latest one, in the late 2020, way back December 2020, Apple announced it shift to their own microprocessor. It is the ARM-based architecture of Apple Silicon. In the dramatic shift, Apple's giving up Intel chips. Instead, future Macs will run Apple Silicon processor, engineered by Apple based on ARM design. In this Apple processor, it gives the whopping 5 nanometer transistor size of the microprocessor. And now let's move to the mobile phones processor. Aside from desktops or desktop CPUs, we also have the mobile phones processors. We have 5 mobile phones processor, and number 1 of it is the Qualcomm Snapdragon processor. The Qualcomm Snapdragon processor, which was developed in 2007, is the reason for being the most common processor is hidden in its efficiency, where it comes when it provides a multitude of sensors, high performance GPU, and smooth performance, known for its high-tech performance SoC chip, processor, and LET modems. Number 2, what we all know is the Apple processor. The first iPhone generation released on June 29, 2007 is considered the most creative and high-tech performance system in the 21st century, beginning from the garage and now the world's most successful smartphone company. The MediaTek processor, established in 1997 with the goal of providing mid-range smartphones with premium technology. If you don't know, MediaTek is a Chinese semiconductor company that supplies high-performance computer chips at cheap price. Now, MediaTek is a major successful chipset company that offers mobile new high-tech processor. MediaTek and Qualcomm Snapdragon are mainly the main rival when it comes to the Android processor. But we can say that Qualcomm Snapdragon is the Intel of mobile phones because of its stability and stability and more what we call it quality made processor, while MediaTek processor suffer different issues in their MediaTek P series processors, but they resolve it in their MediaTek G series. The other two is the Exynos processor and Kirin processor series. Exynos processor is manufactured by Samsung, which is used in the smartphones of Samsung, which is an octal core chipset and use the graphics processor of ARM Mali. No doubt, Exynos processor also provides high-tech smartphone performance and leads the most common device in the world to Samsung. The Kirin processor series. If you have Huawei or Honor smartphone in your pocket, then you may already know about Kirin processor, produced by HiSilicon, a HiSilicon company that supplies the market with new high-tech chipset. Kirin processor also comes with many variations that stand out with the crowd. So this Kirin processor are widely visible on all Huawei phones, and this sum of all the AMD processors, the Mac processors, and the mobile phone processor. Thank you for the attention.
Computer is one of the best technological inventions that we have. It can feed your mind with millions of words, satisfy your eyes with pictures and videos, as well as entertain you with music and sound. But have you ever wondered how computer processes them all? Let's talk about it. Good day, I'm Daisy Omproc of BSIT 1C, and today we're going to talk about data representation. So without further ado, let's get started. Ang mga data at information na nakikita natin sa computer ay pinrocess gamit ang dalawang numbers, which is 0 and 1. Ang 0 at 1 ay tinatawag na binary number or binary form na ginagamit ng computer para makapag-process ng information. Ano nga ba ang data representation? Ang data representation ay ito yung form kung saan ang data, which is the text, the image, or the sound that we hear, ay naiproseso para makita at maintindihan natin into human language. Ang computer ay gumagamit ng binary form which comprises of zeros and ones, yes or no, true or false, or switches on and off para makapag-process at makapag-store ng information. Dahil hindi naiintindihan ni computer ang human language, gumagamit siya ng binary form which is comprises of zeros and ones para makapag-process siya ng text or information. Dahil kapag hindi siya gumamit ng binary form, hindi siya makakapag-process ng information na maiintindihan naman natin into human language.
Marahil gaya ko ay nagtatanong ka kung bakit binary number lang ang naiintindihan ng computer at bakit ito ang kanyang ginagamit. Alamin natin ang sagot sa panonood ng bidyong ito.
And in this video, we are going to discuss why computer use binary number system. In other words, why computer can understand the language of only zeros and one. The computer system use binary number system due to computer system architecture, and the microarchitecture of the microprocessor chip. In order to understand the technical reasons why computer understands only binary 0 and 1, we need to first study the computer system architecture. The microprocessor effectively functions as the brain of the computer system. The processor chip is designed to implement the microarchitecture, which defines the set of binary operations supported by the processor. Further, the computer programs are also required to be converted to binary machine code instructions that computer processor can directly interpret and execute. Let us now discuss each of these topics in detail to understand why computer use binary number system at the hardware level. The computer system is an electronic device that can be programmed to perform various user-specified operations. However, the computer system needs to be directed by using a set of instructions called program instructions in binary code. Let us now discuss what is binary number system. In mathematics, a binary number is used to represent any number using only two numerical numbers, that is 0 and 1. And therefore, the binary number system is said to be a base 2 number system. The binary number system is extensively used in the field of digital electronics, mainly due to the ease of its straightforward implementation. The computer system is also a digital electronic device which consists of a number of electronic components. In digital electronics, it becomes very easy to define the two states, that is on state and off state, using the binary equivalent. In order to understand the reasons why computer use only binary code, we need to first understand the computer system architecture and also the microarchitecture of the central processing unit. It is the microprocessor that provides the processing power to the computer system and executes the program to perform any task. The microprocessor is the brain of the computer system, which controls all the components, CPU operations, and the program execution. The software consists of set of program instructions executed by the microprocessor, which directs the CPU to perform the desired operations. The computer programs are written by using a human-friendly, high-level programming language, such as C language, C++, Java, Python, and there are many such languages. However, since the microprocessor executes only binary commands, the higher-level computer program also needs to be first converted to machine code instructions in binary. So, it doesn't really matter which high-level programming language you choose to write the program code, because eventually, all high-level programs are required to be converted to binary code. This conversion is done by using a special program called compiler. This conversion process is called the program compilation. During the program compilation, the high-level programs are converted by the compiler into machine code instructions in binary that can be directly executed by the computer processor. The microprocessor chip internally consists of millions of integrated circuits packed in the microprocessor chip. This technology is referred as very large-scale integration, used in the processor chip. Each integrated circuit inside the processor chip consists of millions of tiny components called the transistors. The transistor is a fundamental building block for all microprocessor chips. The transistors are used as micro-switch inside the processor chip. And therefore, the microprocessor understands only binary language of 0 and 1. The transistor is made up of silicon, which is a semiconductor material. The transistors inside the CPU function as a micro-switch that can be programmed to be in either switched on or switched off state. When the transistor is in on state, it represents the binary number 1. And when the transistor is in off state, it represents the binary number 0. And for this reason, the microprocessor within the computer system can be programmed to execute only program instructions in binary. Another important factor that makes the binary suitable for computer system is the microarchitecture of the processor chip itself. Each microprocessor chip implements a microarchitecture called instruction set architecture. The instruction set architecture defines the set of commands in binary which processor chip supports. The processor manufacturing companies design the processor chip based on the specific instruction set architecture. During the microprocessor manufacturing process, the instruction set architecture is implemented by embedding these set of binary commands right into the processor chip. The microprocessor can decode the program instructions as per the corresponding operation code, called opcode, and operate on the data, called operand, to perform the desired operation. And therefore, due to this architectural constraints, the processor, inside the computer, can interpret and execute only binary commands. Now, let us summarize the conclusion. The computer uses binary number system because the processor inside the computer can execute only binary commands. The microprocessor chip implements a microarchitecture in terms of instruction set architecture. The instruction set architecture is a set of binary commands that processor chip supports, and these commands are hardwired into the processor chip. The microprocessor is the main component in a computer system that executes the program and performs the desired operations as per the instruction set architecture. And for this reason, the computer uses binary number system.
Ngayon naman ay pag-usapan natin ng bits, bytes, nibbles, and words. Ano nga ba ang bit? Bits stand for binary digit. It is the basic unit for data and information. Katulad sa sinabi ko kanina, it consists of zeros and ones. 1 bit, pwedeng maging 0 or 1. 2 bits, ibig sabihin, dalawang number. Pwedeng 00, 01, 10, at 11. Sa 3 bits naman, ay merong binubuo ng tatlong number. Pwedeng maging 000, 0001, 010, at 111. Sa 4 bits, ay binubuo ng 4 na number. Pwedeng maging 0000, 0001, so on and so forth. Nibbles is composed of 4 bits. Pwedeng 0000, ayon ay isang nibble. Pag 2 nibbles naman, pwedeng 0000, 0001. Byte. It is the basic computer memory size measurement unit. Byte is a group of 8 bits or a group of 2 nibbles. Ibig sabihin, sa isang bytes, mayroong 8 numbers. Pwedeng 0000, 1111. That is composed of 8 bits. Word. Word size may differ from processor to processor. Halimbawa, word size for Intel 8085 is 8 bits. Word size for Intel 8086 is 16 bits, while word size for Intel Pentium is 64 bits.
Paano nga ba nagre-represent ng information or data si computer?
You may have heard that computers work on ones and zeros. Or you may have seen scary-looking visuals like this. But almost nobody today actually deals directly with these ones and zeros. But ones and zeros do play a big role in how computers work on the inside.
Inside a computer are electric wires and circuits that carry all the information in a computer. How do you store or represent information using electricity?
Well, if you have a single wire with electricity flowing through it, the signal can either be on or off. That's not a lot of choices, but it's a really important start. With one wire, we can represent a yes or a no, true or false, a 1 or a 0, or anything else with only 2 options. This on-off state of a single wire is called a bit, and it's the smallest piece of information a computer can store. If you use more wires, you get more bits. More ones and zeros, with more bits, you can represent more complex information. But to understand that, we need to learn about something called the binary number system.
In the decimal number system, we have 10 digits from 0 to 9, and that's how we've all learned to count. In the binary number system, we only have 2 digits, 0 and 1. With these 2 digits, we can count up to any number. Here's how this works. In the decimal number system we're all used to, each position in a number has a different value. There's the 1 position, the 10 position, the 100 position, and so on. For example, a 9 in the 100 position is a 900. In binary, each position also carries a value, but instead of multiplying by 10 each time, we multiply by 2. So there's the 1's position, the 2's position, 4's position, the 8th position, and so on. For example, the number 9 in binary is 1001. To calculate the value, we add 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. Almost nobody does this math because computers do it for us. What's important is that any number can be represented with only ones and zeros, or by a bunch of wires that are on or off. The more wires you use, the larger the numbers you can store.
With 8 wires, you can store numbers between 0 and 255. That's 8 ones. With just 32 wires, you can store all the way from 0 to over 4 billion. Using the binary number system, you can represent any number you like. But what about other types of information, like text, images, or sound? It turns out that all these things can also be represented with numbers. Think of all the letters in the alphabet. You could assign a number to each letter. A could be 1, B could be 2, and so on. You can then represent any word or paragraph as a sequence of numbers. And as we saw, these numbers can be stored as on or off electrical signals. Every word you see on every web page or your phone is represented using a system like this. Now, let's consider photos, videos, and all the graphics you see on a screen. All of these images are made out of teeny dots called pixels, and each pixel has a color. Each of the colors can be represented with numbers. When you consider that a typical image has millions of these pixels, and a typical video shows 30 images per second, now we're talking about a lot of data here.
Every sound is basically a series of vibrations in the air. Vibrations can be represented graphically as a waveform. Any point on this waveform can be represented by a number. And this way, any sound can be broken down into a series of numbers. If you want higher quality sound, you would pick 32-bit audio over 8-bit audio. More bits means a higher range of numbers.
When you use a computer to write code or make your own app, you're not dealing directly with these ones and zeros, but you will be dealing with images or sound or video. So if you want to understand how computers work on the inside, it all comes down to these simple ones and zeros and the electrical signals in the circuits behind them. They are the backbone of how all computers input, store, process, and output information.
Number system or numeral system. Ito ang nag-i-explain kung paanong ang number ay nagre-represent sa isang symbol or character. Mayroong iba't ibang paraan para makapag-represent ng character gamit ang iba't ibang number system. Mayroong dalawang number system at ito ang non-positional number system at positional number system. For further information, let's watch this video.
So what is number system? Number system is the system of naming and representing numbers. Number systems are representation of the numbers. In digital computer, data and instructions can be stored in computer memory using binary code. Binary code means it is machine readable code. It is a machine code represented by binary digits called 1 and 0. It is called as bits. So data and instructions is converted into machine readable code, that is in the form of binary codes called 1 and 0, that is called as bits. And the number system uses well-defined symbols called digits. So in number system we have to use some symbols and only the digits. So number system is a representation of numbers. And in number system we have two types of number system, that is non-positional number system and positional number system. So first type is non-positional number system and positional number system. 3 marks question, what is number system and what are the types of number system? So first type is non-positional number system. Non-positional number systems are, in olden days, the people use of this number system for performing arithmetic operations called addition and subtraction. This non-position number system represent different symbols that are used to represent numbers. And the best examples for non-positional number system is Roman number system. Hope you know about the Roman number system, right? So what is Roman number system? Examples. This is the Roman number of 1 and B is the Roman number of 5 and X is the Roman number for 10 and L is the Roman number for 50. So it is very difficult to implement the arithmetic operations. So Roman number system is very difficult to perform all the arithmetic operations. To overcome these difficulties of Roman number system, they have introduced one positional number system. So non-positional number system cannot be used effectively to perform arithmetic operations. To overcome this problem, they have introduced one positional number system. Positional number system and value of the digits is represented by base value. Positional number system and their placements or value of digits is represented by base value. In positional number system, we have 4 different types, that is decimal number system, binary number system, octal number system and hexadecimal number system. Very important question, what are the types of positional number system? Decimal, binary, octal and hexadecimal. And in positional number system, digits present in any number system is called as base or radix. Base value is also known as radix and subscript value. And every number is represented by a base or radix which represents x digits. In every number system, we have to use the base value or radix value for representing the x digits. And the base is written after the numbers as subscript. The base is written after the numbers as subscript, such as example, I am using 360 to the base 10. This is called as base value or subscript or index value. 360, this is called digits. For this digits, we have one base value called radix value. It is a decimal number as its base is 10. Here we have one decimal value 360 to the base 10. Base 10 means we can represent it as decimal number system. Next I will explain the types of number system. So first type is decimal number system. What is decimal number system? It is the most widely used number system. The decimal number system consists of 10 digits from 0 to 9. 0 to 9 we can call it as decimal number system. It has 10 digits and hence its base radix is 10. It has 10 digits from 0 to 9, so the base value should be 10. Base value is also called as radix value. And these digits can be used to represent any numeric value. We can consider any numeric value, but we have to mention the base value. Example, I will take 140 to the base 10. Now I can call it as a decimal number system. And 555, I can call this as decimal number system. Why? Because base value is 10. And 3200 and base value is 10 means we can call it as decimal number system. Generally, 4 and 6 I can call this is also a decimal number, but without representing the base value, generally we can call this is decimal value. So decimal number means we have to represent the base value called 10. Clear? This is decimal number system. Decimal number system consists of 10 digits from 0 to 9. The base value is 10. Example, these are the examples for decimal number system. Binary number system. What is the meaning of bi? Bi means two values. Two values means only zeros and ones. Binary number system consists of two digits from 0 to 1. It consists of only 0 and 1. Computer can only understand the machine code called binary digits, that is 0 and 1. And binary number system consists of digits 0, that is called as low voltage, and 1 called as high voltage. And we can elaborate this. 0 means it is condition is off and 1 means condition is on. This is low voltage and this is high voltage. So binary number system consists of two digits called 0 and 1. Its base or radix is 2. In decimal number system, base value is 10. In binary number system, base value is 2. And each digit or bit in binary number system can be 0 or 1. Binary digit means only it represents 0 or 1. And the positional values are expressed in power of 2. That is 2 power n. The positional value of binary digits is expressed in terms of 2 power n. Example for binary number system, it represents only the digits 0 and 1. Example 1011 to the base 2. Now we can call this is one binary number. 111 to the base 2. We can call this is binary number system. And 100001, this is binary number system. Octal number system. So what is octal number system? Octal means 8. The octal number system consists of 8 digits, that is from 0 to 7. Octal number system consists of 8 digits from 0 to 7. The base or radix of this system is 8. So octal number system consists of 8 digits, that is from 0 to 7, but the base value is 8. And the positional values are expressed in power of 8. The positional value you need to express it in power of 8. For decimal, power of 10. For binary, power of 2. And for octal, power of 8. And any digit in this system is always less than 8. That is from 0 to 7 only. Example for octal number system. 222 to the base 8. Now we can call it as octal number system. And 450 to the base 8. This is octal number system. And 700 to the base 8. This is octal number system. These are the examples for octal number system. But keep in mind the number 6418 is not a valid. Why it is not a valid number? Because the octal number consists of only 0 to 7 digits. But here 8 is not a valid digit. 8 is not a valid digit because octal number consists of only 0 to 7 digits. This is called octal number system. The base value or radix value is 8. Hexadecimal number system. The hexadecimal number system consists of 16 digits. Hexa means it is 16 digits values. It consists of 16 digits from 0 to 9 numbers and A to F letters. Why this A to F is a letter? You can't express it in 10, 11, 12, 13, 14, 15. Hexadecimal means 0 to 16, but it consists of only 0 to 9 numbers and remaining A to F is a letters. So the letters A to F represent decimal numbers from 10 to 15. So what is A represents? A represents 10. B 11, C 12, D 13, E 14 and F 15. This is called hexadecimal numbers. It consists of 16 digits from 0 to 9 numbers and A to F letters. Very simple. The base or radix of this number system is 16. The base of the hexadecimal number system is 16. Example, A3. What does A stands for? A represents 10. So in place of 10, directly I can write it is A. A3 to the base 16. Now we can call it as hexadecimal number system. And 2BC. B stands for 11, C stands for 12. 2BC to the base 16. This is one hexadecimal number. And FACE. F stands for 15, A stands for 10, C stands for 12 and E stands for 14. FACE to the base 16. This is hexadecimal number. And E stands for 14 to the base 16. This is called hexadecimal number system. Binary is called as base 2, digits is 0 and 1. And octal means base is 8, digits from 0 to 7. And decimal means base value is 10, digits is 0 to 9. And hexadecimal means base value is 16, digits is 0 to 9 numbers and A to F letters. A stands for 10, B is 11, C 12, D 13, E 14, F 15. This is called as positional number system. Binary arithmetic. So what is an arithmetic? Arithmetic means it performs all the basic operations called addition, subtraction, multiplication and division operations. In number system, we can perform all the arithmetic operations using zeros and ones. Why we have to use zeros and ones? Because computer can only understand zeros and ones. It is machine code. So easily you can perform all the arithmetic operations using zeros and ones. And when binary arithmetic operations are performed on binary numbers, the results are also in zeros and ones only. So in binary arithmetic, we can perform addition, subtraction, multiplication and division operations. Let us understand one by one. So first one is binary addition. The addition of two binary numbers is performed in same manner as the addition of decimal. Addition of decimal means addition of binary number is same as the addition of decimal number. So like that we will get the same value from decimal number. It adds only 2 bits and gives sum and carry. Same method will follow in binary addition also. If a carry is generated, it should be carried over to the addition of next 2 bits. Same thing we have done in decimal number. We need to follow the same method in binary addition also. Here we have one table. You need to follow these steps for binary addition. Add and 1, add and number 1, add and 2, sum and carry. So first number, adding the first number and second number, you will get sum and carry, right? So 0 plus 0, you will get 0 and carry also 0. 0 plus 1, you will get sum is 1, but no carry. Carry is 0. 0 plus 0 is 0. 0 plus 1 is, sum is 1, carry is 0. 1 plus 0, sum is 1, carry is 0. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. No carries. And 1 plus 1, 0. Carry is 1. It is wrong, right? 1 plus 1 is 2. How come it is 0? Yes, in computer binary arithmetic, we have 1 plus 1 is equal to 0. 1 is carry. 1 plus 1 is 0. 1 carry to the next digit. Keep in mind 0, 0, that means 0 plus 0, sum is 0, carry also 0. 0 plus 1, sum also 1, carries 0. 1 plus 0, sum 1 carry 0. 1 plus 1 is sum is 0, carry is 1. Keep in mind these rules you need to follow in binary arithmetic. So this is a table, this is the rules for performing binary addition. Subtraction. So what is binary subtraction? Binary subtraction means subtraction between two binary numbers are called as binary subtraction. Subtraction between two binary numbers, not decimal values. We should use only the binary values. This topic is also under the binary arithmetic. So using zeros and ones we can perform binary subtraction also. But we have to use some rules for this binary subtraction. This operation is same as the one performed in decimal subtraction. Hope you know about decimal subtraction, right? Same as we are doing in binary subtraction also. So what are the steps we have to use in binary subtraction? Determine whether it is necessary for us to borrow. Here there is no sum and carry value. Here we need to find the difference and borrow value. First you need to check whether it is necessary for us to borrow from the left digit. I will show you with an example. In binary addition we have seen addend 1, addend 2, sum and carry, right? But here there is no addend 1 and 2 and sum and carry values. But here we will get minuend and subtrahend and difference and borrow. Minuend, subtrahend and difference and borrow. 0 minus 0 is equal to difference is also 0. There is no borrow. And 0 minus 1. This is subtrahend. If your subtrahend value is larger than the minuend value, so it is necessary to borrow from the left digit. I will show you with an example. And 1 minus 0 is equal to 1 and there is no borrow. And 1 minus 1 is equal to 0 and borrow is 0. Please remember this table. Easily you can perform binary subtraction. Representation of signed integers. So what is signed integer? How to representing the signed integers value? Computer handle both positive and negative integers. We have seen unsigned numbers and their representations, right? So we can use decimal, binary, octal and hexadecimal, everything. But generally we prefer binary representation because the computer has designed such a way that it can understand only the binary representation. But the problem is we have not seen how to represent the negative sign integers. But the problem is we have not seen negative integers. That's what we have to talk about signed integers. A signed integers is an integers. It can perform both positive and negative values. And a positive number has a sign bit 0. A positive number has a sign bit 0 while the negative number has a sign bit 1. Remember this, a positive number has a sign bit 0 and the negative number has a sign bit 1. A signed integers is an integers that perform both positive and negative values. A signed integers is also called as fixed point representation and it can perform both positive and negative, right? So a negative sign integers have the following types, that is sign and magnitude method, 1's complement method and 2's complement method. A signed representation having 3 types in the form of negative values, that is sign and magnitude method, 1's complement and 2's complement method. So first one we have sign and magnitude method. What is sign magnitude method? An integer containing a sign bit. I will give an example. An integer, you can take the integer values. An integer containing a sign bit followed by magnitude bits. So I will represent this is sign bit and followed by magnitude bit. An integer containing a sign bit followed by magnitude bit is called as sign magnitude integer. I will show you with an example. In this method, first bit is called as MSB. First bit is called as MSB, is considered as the sign bit. First bit is called as the MSB, is considered as sign bit, and remaining bits stands for magnitude bit, and the remaining bits is called as the magnitude bits. Here positive number starts with 0 and negative number starts with 1. This is called as sign magnitude method, ones complement representation. So what is ones complement representation? This is the simplest method of representing negative binary number. Simplest method of representing negative binary number. The ones complement of a binary number is obtained by changing each 0 to 1 and each 1 to 0. That's it. Each 0 to 1 and each 1 to 0. This is called ones complement. In other words, change each bit in the number to its complement. Complement means opposite. So 1 changes to 0, 0 changes to 1. This is called as ones complement method. Example. Find the ones complement of 1 0 1 0 0. 1 0 1 0 0. How to change this value into ones complement? So 1 changes to 0, 0 changes to 1. 1 to 0, 0 to 1, 0 to 1, 0 to 1. This is your ones complement. Very simple. 1 changes to 0, 0 changes to 1. This is called as ones complement method. Method is 2's complement representation. 2 apostrophe yes, 2's complement representation. The 2's complement of a binary number is obtained by taking 1's complement of the number and adding 1 to the LSB. First you need to convert it into 1's complement and you need to add 1 to the least significant bit. So 2's complement is equal to 1's complement plus 1. Very simple concept. 2's complement means first you need to convert it into 1's complement and add 1 to the least significant bit. Example. Find the 2's complement of 1 0 1 0 0. First you need to convert this into 1's complement. Convert this 1 0 1 0 0 into 1's complement. 1 changes to 0, 0 to 1, 1 to 0, 0 to 1, 0 to 1, 0 to 1. And for converting the 2's complement, add 1 to LSB. LSB means least significant bit. This is most significant bit and this is least significant bit. After converting to 1's complement, for this 1's complement, add 1 to least significant bit. You will get 2's complement values. So 1 plus 1 is 0, 1 carry. 1 plus 1 is 0. Again you can use binary addition. 1 plus 1 is 0, 1 carry. 1 plus 1 is 0, 1 carry. 1 plus 1 is 0, 1 carry. 1 plus 0 is 1, 1 plus 0, 0 plus 0 is 0. This is your 2's complement method. Subtraction of binary number using complement method. Subtraction of binary numbers using complement method. Using complement method, we can subtract two binary values. So how to subtract two binary values using complement method? Already I have discussed 1's complement and 2's complement, right? Using that 1's complement and 2's complement, we can subtract two binary values. In the binary subtraction, we can perform subtraction operation using two methods of complements. They are subtraction using 1's complement and subtraction using 2's complement. So what is subtraction using 1's complement? Subtraction using 1's complement. So what are the steps we have to follow? Case 1. We have two cases, case 1 and case 2. So which are the case 1? Subtracting a smaller number from a larger number. Subtracting a smaller number from a larger number. That is, minus end is greater than subtrahend. Minus end is greater than subtrahend means how to perform the binary subtraction using 1's complement method. First you have to find the 1's complement of the subtrahend. First you need to check which is the subtrahend and which is a minus end. That is very important. First check the subtrahend value and minuend value. Step 1 is find the ones complement of subtrahend. Find the ones complement of subtrahend and add this ones complement of subtrahend to the minuend. Add ones complement of subtrahend to the minuend. I will explain with an example. Carry is generated means that carry is called as end around carry. Carry is generated, this carry is called as end around carry. After adding the ones complement of subtrahend to minuend, you will get carry. If your carry is generated means that carry is called as end around carry. In case 1, you will get end around carry. Add that end around carry back to the least significant bit to get the final difference. After getting the end around carry, you need to add that end around carry to the least significant bit. Example, here we have two values, decimal values, that is 15 and 23. Subtract 15 from 23. So which case we are performing? That is case 1. Case 1 means minuend is greater than subtrahend. So greater value is 23. This is called as minuend. Minuend is 23 and subtrahend is 15. First you need to check this. 15 from 23. From 23 means this is your minuend value and this is your subtrahend value. Got it? So 23 minus 15 we have to check. So what is the binary value of 23? Using 16, 8, 4, 2, 1. 8, 4, 2, 1 code means you can extend. So here using this code we have to find the value of 23. So 23 means which all are the numbers you need to add. So 16 plus 4, it is 20, and 22 and plus 1, that is 23. And 15. 15 means 8 plus 4 plus 2 plus 1 is 15. So this is your binary value of 23 and 15. First you need to find the binary value. After that, what is the second step? So first find ones complement of subtrahend. So what is ones complement of subtrahend? After finding the binary values, you need to find the ones complement of subtrahend, not for minuend. So you need to find the ones complement of subtrahend. Ones complement of subtrahend is 0 changes to 1, 1 changes to 0, 1 to 0, 1 to 0 and 1 to 0. This is your ones complement of subtrahend. Ones complement of subtrahend. And next, add this ones complement of subtrahend to the minuend. So your minuend is 10111 and plus ones complement of subtrahend. So 1 plus 0 is 1, 1 plus 0 1, 1 plus 0 1, 0 plus 0 0, 1 plus 1 is 0 and 1 carry is generated. So add this properly, you will get this answer 100111. After adding these two binary values, you will get this 100111. So here carry is generated. This carry is called as end around carry. So again add this end around carry to the least significant bit. So you will get the final difference. So 1 plus 1 is 0, 1 carry, 1 plus 1 is 0, 1 carry, 1 plus 1 is 0, 1 carry, 1 plus 0 is 1, 0 and end around carry already have added to the least significant bit. So this is your final answer. This is your difference. So what is the final answer for 23 minus 15? It is 8, right? So here we got 1000. So you can check the answer. 1000 means 8. This is your final answer. Very simple, right? So using this method, we can subtract two binary values using ones complement method. This is case 1. Case 1 means if your minuend is larger than the subtrahend, so you can use this method. If your minuend is larger than subtrahend means you will get end around carry. End around carry means again add this end around carry to the least significant bit. So you will get the final difference. This is case 1. Case 2, that is minuend is less than subtrahend. If minuend is less than subtrahend means what we have to do? Find the ones complement of subtrahend. Again, same step we have to use. Add this to the minuend. Same method. First you need to find the ones complement of subtrahend and add this to the minuend. There will be no carry. If you get any carry means you just add that carry to the least significant bit, you will get the difference. In case 2, there will be no carry. Recomplement the answer. Recomplement the answer and put negative symbol in front of the answer. Example. Here subtrahend is larger than the minuend. So subtrahend is 52 and minuend is 25. So 25 minus 52. So what is the first step? Find the binary value of this 25. You can use two methods for finding the binary value. Divide this binary value by 2, or you can use 8421 code. 168421 code also you can use for finding the binary value, or else you can divide this decimal value by 2. You will get the value of binary number. Find the ones complement of this subtrahend. What is the ones complement of this subtrahend? Ones complement of this subtrahend is 1 changes to 0, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 0 to 1. After finding the ones complement of this subtrahend, add this ones complement of subtrahend to the minuend. Add these two values. So 1 plus 1 is 0, 1 carry, 1 plus 1 is 0, 1 carry, 1 plus 0 is 1, 1 plus 1 is 0, 1 carry, 1 plus 1 is 0, 1 carry, 1 plus 0 is 1. If there is no carry generated means again you recomplement this answer, you will get the final difference and put negative symbol in front of the answer. Again you recomplement means again take ones complement, that is 0 to 1, 0 to 1, 1 to 0, 0 to 1, 0 to 1, 1 to 0. This is your recomplement final value. For this final value, put negative symbol. This is your final difference. So minus 011, 011, this is your final answer. That is minus 27. So what is the answer? 25 minus 52 means minus 27. This is your case 2. If your subtrahend is larger than minuend means there will be no carry. No carry means recomplement the answer, you will get the final value and put negative symbol in front of the value. This is case 1 and case 2. Subtraction using ones complement method. Subtraction using twos complement method. Using twos complement method, how to subtract two binary numbers. So here case 1, subtracting a smaller number from a larger number, that is minuend is greater than subtrahend. So what we should do is find the twos complement of the subtrahend. In ones complement we have to perform ones complement of the subtrahend. In twos complement method we have to use twos complement of this subtrahend. After finding the twos complement of the subtrahend, add this to the minuend and carry is generated. Carry is generated means discard the carry. End around carry is generated means discard the carry and the remaining bits give the difference. In twos complement method, if you are getting end around carry, please discard the carry and the remaining bits give the difference. But in your ones complement method, carry is generated means you need to add that carry to the least significant bit. So how to perform this twos complement method? Here you have two numbers, that is 0, 9 and 17. So minuend is larger than subtrahend. I am doing the case 1. Minuend is larger than the subtrahend. 0, 9 from 17. So minuend is 17, subtrahend is 9. So 17 minus 9. First find the binary value of 17, that is 10001, and subtrahend value is 01001. So here first you need to find the twos complement of the subtrahend. So twos complement means what? Ones complement plus 1. First find the twos complement of the subtrahend. So first you should find the ones complement, that is 0 changes to 1, 1 to 0, 0 to 1, 0 to 1, 1 to 0. And after finding the ones complement, add 1 to the least significant bit, you will get twos complement. 0 plus 1 is 1. 1 plus 0, 1. 1 plus 0, 1. 0 plus 0, 0. 1 plus 0 is 1. So this is your 2's complement of subtrahend. Add this 2's complement to the minuend value. So minuend is 1 0 0 1. Add this 2's complement of subtrahend, that is 1 0 1 1 1. 1 plus 1 is 0, 1 carry. 1 plus 1 is 0, 1 carry. 1 plus 1 is 0, 1 carry. 1 plus 0 is 1, 1 plus 1 is 0 and 1 carry. So here you will get end around carry. If you get any end around carry, discard this carry and you will get the final answer called 1 0 0. This is your final answer. So what is the value of 17 minus 9? It is 8. So 8 means 1 0 0. This is your 2's complement method. Subtraction using 2's complement method, case 1. And second we have case 2. Minuend is less than subtrahend. Minuend is less than the subtrahend. So what is the first step? Find, again you have to find the 2's complement of the subtrahend and add it to the minuend. Add this to the minuend, there will be no carry. There will be no carry, hence take the 2's complement. Again you have to recomplement the answer and put negative sign in front of the answer. We will see the example problem. So here we have two numbers 47 from 26. So minuend is less than the subtrahend. This is case 2. First find the binary value of 26 and the binary value of 47. After that, this is your subtrahend, this is your minuend. Find the 2's complement of the subtrahend. 2's complement of the subtrahend means first you need to find for 1's complement, then add 1 to the least significant bit, you will get 2's complement. So 1's complement is 1 to 0, 1 changes to 0, 1 changes to 0, 1 to 0, 0 to 1, 1 to 0. And add 1 to the least significant bit, 0 plus 1, 1, 0, 0, 0, 1 and 0. This is your 2's complement of subtrahend. And add this to the minuend. Add this 2's complement value to the minuend, so you will get the final answer. So your minuend is 0 1 1 0 1 0 and subtrahend is 0 1 0 0 1. Add these two values, 0 plus 1, 1 plus 0, 0 0, 1 plus 0 is 1, 1 plus 1 is 0, 1 carry, 1 plus 0 is 1. There is no carry is generated. No carry means again you recomplement this answer. Recomplement means this is 2's complement operation we are doing. So you need to find the 2's complement this answer. 2's complement means first you need to find the 1's complement, then add 1 to the LSB. So 2's complement, first you need to find 1's complement. 1 changes to 0, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0. And again add 1 to the least significant bit, 0 plus 1, 1, 0, 1, 0, 1, 0. There is no carry. So this is your final answer. There is no carry generated means again you recomplement the answer. So you will get 1 0 1 0 1. Put negative sign in front of the answer. This is your final answer for 2's complement method. Case 2. So minuend is less than the subtrahend means again you have to use the same steps, but there is no carry is generated. Again recomplement the answer and put negative symbol in front of the answer. This is your final value.
So what is computer codes? Computer codes help us represent the characters in the computer's memory in an encoded form. Such codes represent particular formats used for the recording of data. Some of the computer codes which are widely used are binary coded decimal or BCD, extended binary coded decimal interchange code or EBCDIC, American Standard Code for Information Interchange or ASCII, and XS3 code.
BCD code or weighted code is binary coded decimal. It is also called as weighted BCD code or 8421 code. BCD code is one of the early computer codes and the bits are given from left to right. XS3 BCD code or XS3 code. It is a non-weighted code used to represent a decimal number. The name XS3 code derived from BCD plus 3 or 0011 in binary form. EBC, DIC, or Extended Binary Coded Decimal Interchange. It is used for IBM or International Business Measures. EBC DIC is an 8-bit code generally used for large computers, which is mainframe computers for representing characters. ASCII, or American Standard Code for Information Interchange, is a 7-bit code. It can represent up to 128 characters. ASCII is used by mini computers or microcomputers or pwede ring mainframe. ASCII assigns letters, numbers, characters, and its 8-bit code can represent 256 characters. Unicode. Unicode is pronounced as Unicode, uses 16 bits and offers 65,000 characters or code. UTF-8 is a variable length encoding system that uses 7 bits per common ASCII characters but if necessary, uses 16-bit Unicode. Unicode po ang ginagamit para makapag-present si computer ng multi-language alphabets, which is the characters ng Korean, Chinese, etc.
Expansion slot or adapter card.
Ang expansion card ay ating talakayin kung ano nga ba ito sa motherboard at sa PC. Expansion card, it is identified as an adapter board, expansion card, or accessory card. It allows the machine to be extended and function added. It is a printed circuit board that can be placed on computer system unit functionality. Ang mga card ng adapter ay may iba't ibang mga layunin sa bawat computer o motherboard dito sa computer. Ngunit ang pangunahing bagay na dapat tandaan ay ang paggamit o pag-mount ng card na dapat ay magkasya sa modelo ng motherboard kung saan ito naka-install.
The kinds of expansion cards. Let's talk about it.
इस वीडियो में आज हम पढ़ेंगे एक्सपेंशन कार्ड्स की कितनी टाइप्स होती हैं और पहले ये हम जानते हैं कि एक्सपेंशन कार्ड किसे कहते हैं। एक्सपेंशन कार्ड दरअसल हमारे पास एक ऐसा हार्डवेयर है जो कि इस्तेमाल होता है कंप्यूटर के फंक्शंस को मज़ीद बेहतर बनाने के लिए या कंप्यूटर में एडिशनल कैपेबिलिटीज़ डालने के लिए। मिसाल के तौर पे जैसे कि अगर एक कंप्यूटर का जो ऑपरेशंस हैं जिसके अंदर वो वीडियो डिस्प्ले कर रहा है तो वीडियो डिस्प्ले जो है वो अपने एक नॉर्मल ऑपरेशन जो है उसको परफॉर्म कर रहा है, लेकिन अगर हम इसको इम्प्रूव करना चाहते हैं यानी अपने मॉनिटर की जो डिस्प्ले है उसको हम अच्छा बनाना चाहते हैं, ज़्यादा बेहतर बनाना चाहते हैं, तो हम क्या करते हैं कि एक एक्सटर्नल हार्डवेयर डिवाइस कनेक्ट करते हैं अपने मदरबोर्ड से जो कि एक्सपेंशन कार्ड कहलाता है। ये जो एक्सपेंशन कार्ड है ये दरअसल हमारे पास एक पीसीबी होता है, एक प्रिंटेड सर्किट बोर्ड होता है जो कि हम अपने मदरबोर्ड को इसके साथ कनेक्ट करते हैं। अब ये जो पीसीबी है ये आमतौर पे जो हमारा मेन मदरबोर्ड है वो भी दरअसल प्रिंटेड सर्किट बोर्ड ही है जो कि काफ़ी साइज़ में बड़ा होता है, लेकिन ये जो होते हैं कार्ड जो होते हैं स्मॉल पीसीबीज होते हैं जो कि कंप्यूटर की फंक्शनैलिटी को, उसकी परफॉर्मेंस को बढ़ाते हैं। इसकी मुख्तलिफ टाइप्स हैं, जो इसकी 3 कॉमन टाइप्स हैं उसको हम डिस्कस करेंगे आज। एक जिसे हम कहते हैं ग्राफिक्स कार्ड, साउंड कार्ड और एक है नेटवर्क इंटरफेस कार्ड। बारी बारी जानेंगे कि ये कार्ड जो है वो किस तरह से कंप्यूटर की परफॉर्मेंस को बढ़ाते हैं। तो सबसे पहले हम ये जानते हैं कि जो एक्सपेंशन कार्ड है ये हमारे मदरबोर्ड पे हम इसे किस तरह से इंसर्ट करते हैं। अगर हम कंप्यूटर को ओपन करें तो हमें उसके अंदर मेन मदरबोर्ड नज़र आएगा। या आप देख सकते हैं कि ये हमारे पास एक एक्सपेंशन कार्ड है। इस एक्सपेंशन कार्ड को हम क्या करते हैं कि यहाँ पे हमारे पास वाइट कलर में जो आपको स्लॉट्स नज़र आ रही हैं इन्हें एक्सपेंशन स्लॉट्स कहा जाता है। इन एक्सपेंशन स्लॉट्स पे हम क्या करते हैं कि इसको हम कनेक्ट कर देते हैं, इस कार्ड को हम कनेक्ट कर देते हैं और यहाँ पे जो ये एरिया आपको नज़र आ रहा है इसे हम पोर्ट कहते हैं। यहाँ पे हम अपनी इनपुट आउटपुट डिवाइस कनेक्ट करते हैं जो कि इस एक्सपेंशन कार्ड से कनेक्ट होती है और फिर यहाँ से इनपुट आउटपुट का ऑपरेशन परफॉर्म होता है। तो अब आपको ये पता चल गया कि एक्सपेंशन कार्ड है क्या, इसे हम किस तरह से मदरबोर्ड में इंसर्ट करते हैं। अब हम इसकी टाइप्स जानते हैं। तो सबसे पहली टाइप इसके अंदर है वो है ग्राफिक्स कार्ड या जिसको वीडियो कार्ड कहते हैं। ग्राफिक्स कार्ड या वीडियो कार्ड आपने देखा होगा कि अक्सर गेम्स जो हैं वो हमारे पास नॉर्मल जो उस की जो ग्राफिक्स कैपेबिलिटी है मदरबोर्ड की, वो गेम्स जो हैं उनको रन करने में रन नहीं होते, क्योंकि उन गेम्स को ज़्यादा मेमोरी चाहिए होती है, उनकी पिक्सल क्वालिटी ज़्यादा अच्छी होती है, इसके लिए उनको ज़्यादा मेमोरी चाहिए होती है ऑपरेशंस के लिए। तो उसके लिए हम क्या करते हैं कि एक्सटर्नल ग्राफिक्स कार्ड अपने कंप्यूटर में इंसर्ट करते हैं, जिसकी अपनी एक मेमोरी होती है और अपना एक प्रोसेसर होता है। और ये क्या करता है कि हमारे पास जितना भी हमारा जो एक्चुअल डाटा है जिसको प्रोसेस करना है, वो हमारे पास चूंकि प्रोसेसर में 3D इमेज जो होता है वो ये क्या करता है कि उसको पहले कन्वर्ट करता है, ये कार्ड्स को कन्वर्ट करता है 2D में, और 2D में कन्वर्ट करने के बाद उसके हर पिक्सल के ऊपर ज्योमेट्रिक कन्वर्जन एल्गोरिथम्स अप्लाई करता है। जैसा कि मैंने कहा कि इस कार्ड का अपना एक प्रोसेसर होता है, तो इस प्रोसेसर में कुछ एल्गोरिथम्स होते हैं जो उन पिक्सल के ऊपर अप्लाई होते हैं, जिससे उन पिक्सल की क्वालिटी जो है वो काफ़ी बेहतर हो जाती है। हर पिक्सल की जो है वो एक RGB वैल्यू होती है। RGB का क्या मतलब है? हर पिक्सल बनता है 3 कलर से, रेड, ग्रीन एंड ब्लू। तो इन तीनों की वैल्यू से मिलकर एक पिक्सल क्रिएट होता है। इस पिक्सल को ये ग्राफिक्स कार्ड क्या करता है कि इस पिक्सल को इस RGB वैल्यू को कन्वर्ट करता है एनालॉग में। एनालॉग मतलब वेव फॉर्म में इसको कन्वर्ट करता है, और उसको कन्वर्ट करने के बाद इसको सेंड कर दिया जाता है आउटपुट डिवाइस के पास, यानी हमारी जो आउटपुट स्क्रीन है उसमें वो पिक्सल जो है वो रिप्रेजेंट होता है। जिससे आपने देखा होगा कि जब भी हम ग्राफिक्स कार्ड का इस्तेमाल करते हैं तो हमारे मॉनिटर की जो कैपेबिलिटी है वो ज़्यादा बेहतर हो सकती है। जैसे कि आप देख सकते हैं कि ये गेम है जो कि ग्राफिक्स कार्ड इसको रन करने में अहम रोल प्ले कर रहा है। अब हम ग्राफिक्स कार्ड को जो है वो इन डिटेल समझते हैं। अगर आप ग्राफिक्स कार्ड बाजार से, मार्केट से खरीदते हैं तो इस तरह का एक ग्राफिक्स कार्ड आपको नजर आएगा। इसके अंदर आप देख सकते हैं कि यहाँ पे जो इसकी ये चिप है, ये दरअसल यहाँ पे इसकी वीडियो मेमोरी है, और इसके अंदर जो है GPU जो है ग्राफिक्स प्रोसेसिंग यूनिट जो है, इसके अंदर इसका प्रोसेसर होता है जो कि प्रोसेस करता है, जो कि पिक्सल वैल्यूज को प्रोसेस करता है। और यहाँ पे जो है हमारे पास एक्सेलरेटेड ग्राफिक्स पोर्ट होती है जो कि हमारे उसके साथ कनेक्ट होती है मदरबोर्ड के साथ। यहाँ पे हमारे पास 3 कनेक्टर्स होते हैं। वीडियो ग्राफिक्स अरे जो कि नॉर्मल मॉनिटर के लिए इस्तेमाल होता है। इसके अलावा जो बाकी हैं जैसे डिजिटल विजुअल इनपुट या S वीडियो, ये डिफरेंट गेमिंग के लिए और दूसरी डिवाइस के लिए इस्तेमाल होते हैं। तो ये दरअसल एक ग्राफिक्स कार्ड है। जब भी आपने परचेज करना हो तो आप इसको परचेज करते हैं। इसकी मेमोरी जो है बहुत अहम होती है। जितनी ज़्यादा मेमोरी होगी उतना ज़्यादा इसकी प्रोसेसिंग पावर इंक्रीज करेगी, क्योंकि हमारे पास नंबर ऑफ पिक्सल जो हैं वो इतने ज़्यादा होते हैं, उससे हमारी रेजोल्यूशन इंक्रीज कर जाती है, जिससे हमें ज़्यादा मेमोरी की ज़रूरत पड़ती है उसको इम्प्रूव करने के लिए, उसको प्रोसेस करने के लिए। तो नॉर्मली 1 GB का जो कार्ड होता है वो हमारे नॉर्मल गेम्स जो हैं उसमें रन हो जाते हैं। इसके अलावा ज़्यादा मेमोरी का भी कार्ड होता है, लेकिन वो थोड़ा एक्सपेंसिव होता है। तो ये हमने जान लिया इसके बारे में। अब चलते हैं नेक्स्ट टाइप की तरफ, जो कि है साउंड कार्ड। साउंड कार्ड इस्तेमाल होता है साउंड वेव्स इनपुट आउटपुट के लिए। ये एक कार्ड है, जब भी आपने परचेज करना हो तो इस तरह का एक कार्ड होगा। इसको आप इंसर्ट कर देंगे मदरबोर्ड पे, आपको एक स्लॉट नजर आएगी जिसको हम कहते हैं पेरिफेरल कंपोनेंट इंटरकनेक्ट स्लॉट। ये स्लॉट जो है ये मदरबोर्ड पे मौजूद होती है, PC1 स्लॉट कहते हैं। वहाँ पे आपने क्या करना है कि साउंड कार्ड को वहाँ पे इंसर्ट कर देना है। इसके अंदर 2 जो है मेन ऑप्शंस हैं। एक इसका जो है वो माइक्रोफोन का है और एक इसका जो है स्पीकर का है, जो कि इस्तेमाल होते हैं नॉर्मल हमारे यूजेज में। बाकी जो ऑप्शंस हैं वो टेप रिकॉर्डर और हेडफोन्स के लिए इस्तेमाल होते हैं। और इसके साथ एक गेमिंग कंट्रोलर पोर्ट भी होता है जो कि जॉयस्टिक को कनेक्ट करता है, जो कि गेम्स खेलने के लिए हम इसका इस्तेमाल करते हैं। तो ये करता क्या है, दरअसल ये हमारी एनालॉग वेव फॉर्म को, जैसे अगर हम माइक्रोफोन का इस्तेमाल करके अपनी आवाज़ रिकॉर्ड कर रहे हैं तो एनालॉग वेव फॉर्म को कन्वर्ट करता है डिजिटल सिग्नल में, और डिजिटल सिग्नल सेंड कर दिया जाता है हमारे प्रोसेसर को, और प्रोसेसर उसको प्रोसेस करता है। और अगर हम उसको सेव कर लें तो हमारी आवाज़ जो है हमारी हार्ड डिस्क में सेव हो जाती है। तो इस तरह से ये साउंड कार्ड जो है वो काम करता है। तो ये हमारे पास एक्सपेंशन कार्ड की एक एग्जांपल है। अब चलते हैं इसकी नेक्स्ट टाइप की तरफ। नेक्स्ट टाइप हमारे पास है नेटवर्क इंटरफेस कार्ड। जैसे कि आप इस वक्त देख सकते हैं, नेटवर्क इंटरफेस कार्ड हमें मदद देता है इंटरनेट से कनेक्ट होने के लिए, या किसी भी कंप्यूटर नेटवर्क से अपनी डिवाइस को कनेक्ट करने के लिए हमें इस कार्ड की जरूरत पड़ती है। इस कार्ड को हम इंसर्ट करते हैं अपने मदरबोर्ड पे। अब इसकी 2 मेन टाइप्स हैं, एक जिसे हम मॉडेम कहते हैं और और एक जिसको हम ईथरनेट कार्ड कहते हैं। मॉडेम जो था वो पुराना जो हमारे पास कंप्यूटर्स थे जहाँ पे हम डायरेक्ट टेलीफोन लाइन को कनेक्ट करते थे, यानी टेलीफोन लाइन जब इस्तेमाल होती थी इंटरनेट के लिए, तब हम ये मॉडेम जो थे वो डायरेक्टली हमारे मदरबोर्ड में इंस्टॉल होते थे और हम डायरेक्ट फोन वायर कनेक्ट कर दिया करते थे। लेकिन अब जो है वो मॉडेम जो है वो एक अलग से डिवाइस आती है और उसके साथ एक न्यू टेक्नोलॉजी आई है जिसके अंदर हम ईथरनेट केबल का इस्तेमाल करते हैं। तो ईथरनेट की वायर कनेक्ट करने के लिए हमें एक और जो है वो कार्ड की जरूरत पड़ती है, जिसको हम ईथरनेट कार्ड कहते हैं। ईथरनेट कार्ड इस वक्त आप देख सकते हैं यहाँ पे, ये जो इसकी पोर्ट है, इस पोर्ट पे हमारी जो ईथरनेट वायर है वो यहाँ पे कनेक्ट होती है और हमारे जो जितना भी हमारा जो नेटवर्क सिग्नल्स हैं वो यहाँ से ट्रांसफर होते हैं। उसके बाद यही ईथरनेट कार्ड जो है इन सिग्नल्स को प्रोसेस करके हमारे मेन प्रोसेसर तक पहुंचाता है। इस वीडियो में आज हमने सीखा कि एक्सपेंशन कार्ड्स होते क्या हैं और उनकी कौन कौन सी मेन टाइप्स होती हैं।
Pag-usapan naman natin ang mga common types ng expansion slots. Ano-ano nga ba ito at ano nga ba ang mga meaning nito sa computer? The first common type of expansion slot. First, Peripheral Component Interconnect or PCI. It introduced in 1992. It is an adding internal components to desktop computer. Also, it is attaches device to the motherboard. O Peripheral Component Interconnect ay isang pinagsamang puwang ng computer na nagbibigay daan sa iba't ibang hardware ng computer, tulad ng mga network card, modem, sound card, video card, disk control at iba pa, upang maiugnay ito sa motherboard. PCIe o Peripheral Component Interconnect Express na kilala ring PCI, ito ay pinakamahusay na form ng extension slot na mayroon sa PC. Maaaring dalhin ng mas matatandang PC ang lawak nito, ngunit ang PCI Express na ginagamit ay pinakamahusay na sa mga video card. Peripheral Component Interconnect Express or PCIe was first came PCI, then PCIX, then PCI Express. It is used as serial communication. The second type is Industry Standard Architecture or ISA. This slot may be used to add video card, network card, or extra serial port. Industry Standard Architecture ports was beginning to replace by faster in PCI or Peripheral Component Interconnect and AGP or Accelerated Graphics Port. Ito ay ang pinakalumang form ng expansion slot sa motherboard. The third type is Video Electronic Standard Association or VESA. It is an older local bus architecture popular in 1993 and 1994. It is a type of slot that faster processing and faster access. Nagpapagana na mas mabilis na daloy ng data sa computer.
Okay, so we're gonna go over motherboards. Okay, you already know that the motherboard, everything connects to the motherboard directly or through some kind of cable, okay? Because everything connects to the motherboard, it's known as the heart of the computer, and most motherboards have, a lot of built-in components. So those are the components we're gonna go over today. There's different form factors for motherboards. Form factors, again, is talking about the size, the orientation of devices, and you have to make sure you have the correct form factors to make sure things are compatible. So your case have got to be compatible with whether a motherboard, because your motherboards have little holes on them where you screw it in onto the case. So if they're not the same form factor, then those holes are not going to align with the little, I guess you can call them the little standoffs on the case itself. So you want to make sure you have the correct form factor. We're going to cover this a little bit more later. Right now, ATX and micro ATX are your more common form factors for motherboards. Micro ATX is just a little shorter than the regular ATX, so it will have less expansion slots. Okay, our focus for today is our motherboard components. Okay, on your assignment, you have the motherboard, with numbers 1 through 12. On the lower portion, you have 1 through 12. So you have to identify on the left-hand side what is that motherboard components. As you're paying attention, fill it in when you see it. On the right-hand side, you are telling me what connects into that component on the motherboard or what's it for. Okay, so if you can't plug something into it, then you're going to tell me what's the purpose of that component. Okay, this one here is talking about the CPU slot or socket. On the left-hand side, this here is a CPU slot. This is for older motherboards. I'm not sure if you can see. This here is an old CPU, an old processor. So you notice all the golds on the bottom? That's where it would go into the slot of the motherboard. Okay, so the CPU slot accepts your CPU. Your newer motherboards, because your CPUs are now in square shaped like this, they go onto that socket. Okay, so if you, on your assignment, just so I can show you how you're going to be doing this. Right here, number 4 is pointing to the CPU socket. So you would put here, number 4, you would put CPU socket, and then right across from it, you would say placeholder for the CPU. Okay, because that is where your CPU will be. Okay, so that's what you're doing on your assignment. Okay, going back to the presentation so I can continue. Let me clear this off and hit done. Okay, next we have what is called the chipset. The chipset, pretty much what it does, it helps the CPU handle all its tasks or all its functions. Now, some motherboards will only have one chipset. Majority of them will have 2. That's when they get these different names, okay? But I will accept chipset for your answer, or if you want to get more specific, it's up to you. But if it's close to the CPU, that's the north bridge. The one that's a little bit further apart, like this one over here, this is called your south bridge. Now, there's duties that are separated amongst the chipsets when it's 2 of them. The north bridge will help the CPU as it communicates with the memory, as it communicates with your video card. The south bridge will help the CPU as it communicates with any other card connected onto the motherboard, or as it communicates with the different devices, such as where you would plug in your hard drive and your optical drives. Okay, so that's, again, the chipset helps the CPU handle all its tasks. I'm gonna go ahead and clear this out. My next slide has the memory slots. Okay, memory slots are just placeholders for your memory modules. Now, because we've already gone over memory, you should be able to know that by looking at this, that this motherboard supports dual channeling when it comes to memory. So if you were to have memory modules, 2 of them, you would either use both of the yellow slots or both of the black slots, okay, to take advantage of that feature. So again, memory slots are placeholders for your RAM. This here is your BIOS chip. The BIOS chip is soldered directly onto the motherboard, and this is the one that tests all the hardware as your computer starts up. If something's wrong with your computer, you'll start hearing beeping coming out of your computer indicating that something is wrong with one component of the, that's connected to the motherboard. Okay, so that is your BIOS chip, and it tests all hardware as the computer starts up. Next component is your AGP slot. Okay, this is where maybe a few of you might find this probably the hardest part of the components. Before, on the motherboard, all you had to know were expansion slots. Okay, anywhere you would plug a card in, those were expansion slots. Now you have to know the names of your expansion slots. This here, this brown one, is called an AGP slot. An AGP slot only accepts video cards. Okay, only accepts video cards. I'm going to clear that and go on to the next one. I'm not too big on this picture, but because it got stretched and I forgot to replace this picture, so I need to make a note of that to change it. But here you have more expansion slots. The ones on the bottom, these really long black ones, these are your ISA slots. These are the first expansion slots that got created. Okay, so these ISA slots will take any type of card. Okay, they're just, again, you can just put for the, you put in network cards or any type of card. They're called ISA slots. After the ISA slots, the PSI cards got introduced. Sorry, PSI slots. They're right here, these white ones. Those are your PCI slots. They will also take any type of card. except they do it faster as far, than ISA. They communicate faster. That's the only difference. Kind of like RAM, we have many types. They all serve the same purpose. They're just getting faster as a new edition comes out. That's what's going on here. These expansion slots all serve the same purpose, to let you add extra capabilities to the computer through the use of a card, okay? But some can transfer that data faster. Let me clear this and go to your next. Okay, this here, these smaller ones and this, again, these smaller ones here, or this blue one here, these are called PCI Express slots. Your PCI Express slots are your newest type or your newest technology when it comes to expansion slots. They will also take all types of cards. They have different speeds. They are indicated by this X. ×1, there's a ×2, a 4, an 8, and a 16. 16 is your fastest. This one usually is meant for video cards as well. You can put anything there, but a lot of times, ideally, people will put their video cards in there. Okay, so PCI Express is your latest type of expansion slots, and they take all types of cards as well. So remember, ISA slots, PCI, and PCI Express all take all kinds of cards. AGP slot only takes video cards. And then just kind of know, and for testing wise, the order they came out. ISA is the oldest, then PCI, and then PCI Express is the latest one. Let me clear that, move on. Okay, now you have your power connector, okay? On the motherboard, you have what looks like a, for me, it looks like an ice cube tray, okay? This right here. So that is your power connector. What do you plug into the power connector? Well, this cable here is gonna go connected to a power supply. Let me try to do my best drawing of a power supply here. And then this is where you would have your power cable that would plug into the wall. Okay, so you have a cable that plugs into the power supply, provides that, and then you have this DC connector that plugs into the motherboard and provides the power. Okay, so on your assignment, you would call this the power connector, and you would say where the power supply connects to. Let me clear this. We're almost done. Okay, we have a battery here. I know I've had students when they look and they're like, is that a huge watch battery? Okay, it kind of serves almost the same purpose. On your computers, you'll notice on the lower right-hand corner, your computers have the time. If you ever notice your time falling behind, and then you turn up your computer and you start it up again and it fell behind again, once you've already updated it, it's because you need to replace this battery. This battery will make sure that the time and date are current on your computer. Now, another purpose for this battery, I'm not sure if you guys have ever noticed when you turn on a computer, it says something like press F2 to go into setup. On some other brands, they'll say press delete to go into setup. When you go into setup, you're actually going into your BIOS settings. Some settings there you cannot change because they're just kind of showing you configurations, such as how much RAM you have, what kind of processor you have, you know, that kind of information. But there's some other settings on there that you can manipulate, such as disabling the onboard video or deciding that you want your computer to boot up to the optical drive as opposed to the hard drive. So those settings you can change. If your battery is bad, it won't save those changes that you make. Okay, so those are the two purposes of your battery. Okay, now we have our disk drive connectors. Okay, in other words, where we connect all our drives. Now, specifically, let me bring my little thing here. On your older motherboards, you'll have these two connectors that have all these little pins on them, and they're called IDE connectors. That's where you would plug in a hard drive or an optical drive. Your newer computers, they have your SATA connectors. See, they have that little L shape right there? That is where you plug in your optical drives and hard drives. But this is on a newer system. Okay, so both of them have the same function, except IDE connectors will be found on an older system, and SATA connectors will be found on a newer one. Now, on the older system, because again, they're old, There was another drive out there before that you all probably never used, and it was called a floppy drive. You have a connector that looks pretty much the same as the IDE connector, except it's shorter in size. And that was called your floppy connector, and it was meant for your floppy drive. Okay. At any point, guys, if you want to stop me, you can always unmute yourself and just ask away. Up to you.
Miss, for the IDE connector, what did you say that one helps for?
The IDE connector is where you would plug in a hard drive or an optical drive. Okay, so that's what you would plug in there. Same thing as for the SATA connectors, except we're just talking about two different times of technology. IDE connectors are going to be for older computers. SATA connectors are for newer computers. But they both are for you to plug in an optical drive or a hard drive.
Thank you.
And this here is our last slide. It's talking about the ports. Every motherboard obviously has ports on one side, and that is the only thing that's visible. If you look at a computer that's completely closed up, on the back you'll see the ports, and that's the only part of the motherboard we can see unless we open up the computer case. And your ports are just for you to connect your external devices or your peripheral devices, such as your keyboard, your mouse, a printer, you know, whatever it is.
Ang AMR o Audio Modem Riser ay isang maikling riser slot na nagpapalawak sa motherboard. Layunin nito na maisama ang espesyal na sound card at modem sa isang simple at mura na madaling paraan. And Accelerated Graphics Port or AGP. It is designed specifically for graphic cards. Was developed in 1996 as an alternative to PCI or Peripheral Interconnect Component.
The expansion slots and buses topic. There are so many expansion slots available, so many types of buses available, so I need about 2 to 3 sessions maximum for me to clearly explain what are all these types of slots. So we will go ahead with the fundamentals first, and then we can go to the types of the slots. What is an expansion slot? Very simple. In a motherboard you could see a lot of these kind of slots available. I am moving my pointer over here. I will probably make it look better. You can see here I am moving the pointer over the slots. These are all called the expansion slots. Right from the RAM, right from the graphics card, whatever you have to connect or plug it into the motherboard, you cannot do it directly. You need an expansion slot, and that's what exactly we have in front of you, and that is called expansion slot. And it is just an input-output pathway from the CPU to the peripheral devices and vice versa. I can connect to the CPU. I can talk to the CPU only when I connect my the cards, whatever VGA card or RAM or whatever, only to this slot, and then only it gets accessible, it gets used. So to be very precise and simple, these slots are nothing but the connectors. There will be series of slots available in the motherboard based on what component you are using, based on which component you are using. You will probably connect it into appropriate slots, and that is it. Why do we need expansion slots? Very simple. We need the expansion slots to enhance the capacity of the board. For example, I may earlier, while I purchased the computer, while I purchased the PC, maybe I would have avoided buying the graphics card. Now later on I want to include the graphics card. I cannot directly include it into the motherboard. Instead, I can connect the graphics card through the slots which are available. So any sort of expansion that you want to happen will happen only through this slots, including the RAM size. For example, you have got a 8 GB RAM already installed. You want another 8 GB RAM there. You need additional slot there, hopefully, to add that 8 GB RAM to make it easier. There are common type of slots available. One is ISA, which is nothing but Industry Standard Architecture. Second one is VESA, Video Electronic Standard Association. Third one is PCI, Peripheral Component Interconnect. Fourth one is AGP, Accelerated Graphics Port. Fifth one is PCIe, Peripheral Component Interconnect Express. These are all the slots that we are going to see in the session. First two slots we will understand in this session, and then we will go on with the rest of the slots in the next couple of sessions hopefully. Let us first understand about ISA. You are seeing the slot ISA in front of you. I am hovering over it. This is the slot that I am talking about. This is nothing but expanded as Industry Standard Architecture. This is Lego-sized. This is Lego-sized, and most important point is this is no more in use right now. This helps you to connect the peripherals to the PC, and this earlier versions were available with 8 bits capacity. Later on it supported about 16 bits. It was also called as AT bus. The operation speed was at 8 MHz, and some manufacturers even provided you at say about 10 MHz speed. This is no more in use, and all of these are almost overtaken by the further buses which came like PCI, PCI Express, etc. So what we have seen is called ISA bus, and the next bus we need to understand is VISA. VISA is nothing but Video Electronic Standard Association. Video Electronic Standard Association. People also call it VISA local bus. This is also called as VLB. VLB is nothing but VL bus. VISA local bus is nothing but the VL bus. This is an acronym for Video Electronic Standard Association, as I already referred, and this was very specifically used with 486 architecture, and this is a very old architecture. It was about 1993 and 94 we used it, and now completely they have been overtaken by PCI and AGP, and we do not use this VISA anymore. Mainly used during that time for video and disk controller interfaces. It is a 32-bit bus. You can see the difference there. Earlier it was 18 and maximum was 16 there in the ISA bus. Now it is 32, and the speed is 40 MHz maximum that can be offered. And quickly seeing the advantages, it is very fast compared to the previous version. We have direct access to the processor bus. 32-bit data transfer capacity is decent at that time. 128 Mbps to 132 Mbps as the maximum throughput that we have obtained, and this is available as a different physical slot, which means we will not have any trouble there we will not have any problem of it preventing a slower card being plugged in into the faster slot. This is a separate slot, so you will make sure that you are plugging it enables you that you are plugging it only in the right slot. The disadvantages are, couple of disadvantages are cited quickly when I refer to the literature. It is not plug and play support feature. Plug and play support features are not supported, and most importantly, this is suitable only for X486 architecture. This is not suitable for Pentium architectures, which has come later on, which is not the architectures that these guys are supporting, these particular interfaces supporting, is no more available right now, so we can call this as well as legacy.
Communication and Network Risers or CNR ay isa sa pagtutukoy na sumusuporta sa mga pangunahing interface ng audio. Noong February 7, 2000, ang technology slot ng CNR o Communication and Network Riser ay inilunsad ng Intel.
Okay, today's topic is port expansion slots and expansion cards. And my name is Sagib Rashid. As you can see, these are all the ports which is available in in all the computer systems, and it is marked as PS2 port, mouse port. It was used before there was PS2 port for mouse connection. Now the USB mouse is available. VGA connector, parallel port connector, COM connector, USB ports, Ethernet connectors, and audio jacks. Okay, now we can see what is a port. Port is an interface for connection various devices to the system unit. So whatever we have to connect via port. It is located on motherboard. All the ports are located on motherboard. Various types of ports for keyboard, mouse, monitors, microphone, etc. We can connect these devices. We can connect many other devices as well. Okay, in this slide we can see different types of port. USB stand for Universal Serial Bus. HDMI stand for High Definition Multimedia Interface. DVI stand for Digital Visual Interface. LAN stand for Local Area Network. In modern computer you will find these ports. The difference between HDMI and DVI and VGA is HDMI, if you connect your laptop to the TV via HDMI cable, the sound as well as the video will be transferred to the TV. And if you are connecting your laptop via DVI or VGA cable, only the video will be transferred from your laptop to TV. So if you have the HDMI connector, it's better to use that one. This is a picture of the motherboard, and there different things are marked like memory slots, connectors, small IC chips, slots for speakers, backup battery, sockets for microprocessor, heatsink. In the memory slot we have to install the memory like RAM, and in the PCI slots or the expansion slots we can add extra card. In this picture you can see the expansion slots. If you want to increase the graphic of your motherboard, you have to install the graphic card, which you can easily install on the expansion slots. Before there was no Ethernet port on the motherboard, so we have to install the LAN card to use the Ethernet connector. So the LAN card was normally installed on the expansion slots. Now we can see what is expansion slots. These are long narrow slots sockets on the motherboard used for installing expansion cards. The cards which we are able to install on the expansion slots are known as expansion cards. These cards can add new capabilities to computer. I gave you the example of graphic card. If you want to increase the graphic card of your motherboard to get the better graphics, you have to install the graphic card on the expansion slots, and the graphic card is known as expansion card. Commonly used cards are sound card, graphic card, modem card, and network card. Network card and modem card are now built in on the motherboard. Before we have to install this one to use the internet. In modern computers, these cards are built in on the motherboard.
Good morning everyone, this is Maricela Maydi or Macleed, and I'm going to discuss about the ports and connectors of a computer. So let's talk about the definition of ports and connectors, the importance of ports and connectors, brief history, and different types of ports and connectors. So let's begin. So, for a short definition of what is port has either holes or a slot that matches the plug or cord connected to the port. Port referring to a physical device, a hardware port or peripheral port is a hole or connection found on the front or back of computer. Next, what is a connector? Connector is referring to the cables. The connector is the end of the cable that connects into a port. For example, the end of a USB cable that has a connector that allows it to connect to a USB port. So later on, we were going to discuss the different types of ports and connectors. So for the brief history of ports, it is on the day 1969, the serial port, the oldest legacy port of computer, known in the trade as RS-232C. Next is the 1981 parallel port. It's a wide receptacle with 25 holes in 2 rows. So we will going to see the picture of the parallel port later. Another legacy device, it is part of the original IBM PC in 1981 and was designed for high-speed communication that was largely one-way. Next is the 1990 up to present Universal Serial Bus, or the Universal Serial Bus, or USB, was developed in the mid-1990s to replace legacy ports with an all-purpose connector for printers, scanners, keyboards, CD writers, digital cameras, monitors, speakers, network adapters, and other gadgets. In 1996, the USB 1.0, the first commercial version of USB, was released on January 1996 and it had data transfer rate of 12 Mbps. Next is the importance of ports. What is the importance of ports? Ports provide the input and output interfaces that device needs to communicate with peripherals and computer networks. The most important ports on computers are used for networking, for without them, the computer would be completely isolated and unable to communicate outside of itself. Next is the brief history of connectors. It was on 1987, the VGA, or the Video Graphics Array, was the first computer connector introduced during the analog era, When mainframe computers were still in vogue, VGAs have 3-row 15-pin TE connectors, and they are found in many computers manufactured before the year 2000. Next is the 1999, the DVI, or the Digital Video Interface, was developed by Display Working Group, the DDWG, to help computer users overcome the limitations of the VGA, which could not transmit digital data. Next is on 2002, the HDMI, or the High Definition Multimedia Interface, is a high proprietary video and audio interface connector used for transmitting uncompressed and compressed digital video and audio data from a source device that is HDMI compliant. The HDMI was introduced as a replacement for analog video standards. On 2005, Mini DisplayPort is a miniatured version of the HDMI version introduced by Apple on October 2005. Next, on 2006, the DisplayPort is a modern interface designed for the connecting of target display device to a video source. DisplayPort can be used to extract audio and video files from USB and other forms of data sources. Last is 2014, the USB-C, or the Universal Serial Bus Type-C USB connectors were introduced in 2014, and they come from 24-pin double-sided connectors for video file conversions into HDMI using an adapter, being the newest invention of all the computer series. So, what's the importance of connectors? Connectors, since the dawn of computers, connectors have always played an all-important role in transmitting data from data sources to a display monitor, and they continue to remain important today. Connectors are of many types, and they can be incorporated into different computer models for data transmission. So let's see the different types and usage of ports. Our first is the serial ports, are usually identified on IBM computers as COM or communication ports. For example, a mouse might connect to a COM1 and a modem to COM2. The picture shows a DB9 serial connector on a cable. So this is the picture of a serial port. Next is the parallel port, or the Centronics 36-pin port. Parallel port is an interface between computer and peripheral devices like printers with parallel communication. The Centronics port is a 36 port that was developed as an interface for the printers and scanners, and hence, a parallel port is called a Centronics port. So this is the picture of a parallel port or Centronics with 36-pin port. Next is the AT port, alternatively referred to as the Model F keyboard. The AT keyboard is a US standard keyboard introduced in 1986 by IBM. It has 5 pin. Next is the line printer terminal, or the LPT, is used by also IBM compatible computers as an identification for the parallel port, such as LPT1, LPT2, or LPT3. At one point, the LPT port was commonly required when installing a printer on an IBM compatible computers. Next is the PS2, or the Personal System 2 port, also referred as a mouse port or keyboard port. It is colored blue and green, and it was developed by IBM. It is used to connect a computer mouse or keyboard to an IBM also compatible computer. Next is the digital to analog port. Adapter is a 15-pin connector port first found on IBM computers in 1981. The game port is handled by the SIO and allows users to connect such devices as joysticks and gamepads. Next is the audio ports, used to connect speakers or other audio output devices with the computer. The audio signals can be either analog or digital, and depending on the port and its corresponding connector differ. So it has different colors: the blue, the orange, green, the brown, the white, and the pink. Next is Component video is an interface when the video signals are split into more than 2 channels and the quality of the video signal is better than composite video. Ports of the commonly found component video uses 3 connectors in the color coded as green, blue, and red. Next is the S-Video, or separate video connector is used for transmitting only video signals. The picture quality is better than the composite video, but has a lesser resolution than component video. S-Video port is generally black in color and is present in all TVs, and most computers S-Video ports looks like a PS2 port but only consists of only 4 pins. ESATA is an external serial AT attachment connector that is used in an interface for connecting external mass storage devices. Modern eSATA or eSATA connector are called eSATA-P and stands for Power eSATA ports. They are hybrid ports capable of supporting both eSATA and USB. Next one is the RJ11. It's a 4 or 6 wire connection for telephone and modern connectors in the US. The picture is an example image of what the RJ11 phone cable in its connection. Next one is the registered JOC 45 or the RJ45. It's a 8-pin connection used for Ethernet network adapters. This connector most commonly connects to the end of SCAT5 cable, which connects between a computer network card and a network device, such a network router. Next, the IEEE 1394 FireWire is a digital bus with a bandwidth of 400 to 800 Mbps and higher. It can handle up to 38 units on the same bus, is hot swappable, and it supports PNP plug-and-play devices. These are the specifications and versions of FireWire. FireWire 400, IEEE 1394A, FireWire 800, FireWire S800P, FireWire S1600, and S3200. Next is the DisplayPort. Has a 20-pin connector, which is a very less number when compared to a DVI port and offers better resolution. The input-out diagram of a DisplayPort is shown below. Next is the Mini DVI. It's developed by Apple as an alternative to Mini VGA port and is physically similar to one. It is smaller than the regular DVI port. Next is the Micro DVI port. As the name suggests, is physically smaller than Mini DVI and is capable of transmitting only digital signals. This port can be connected to external devices which DVI and VGA interfaces and respective adapters are required. Next is the VGA. The Video Graphics Adapter or Video Graphics Array is a popular display standard developed by IBM in 1987. VGA connector is used for display devices and is used to connect computer to a monitor, projector, or TV. High Definition Multimedia Interface, or the HDMI, is a connector and cable capable of transmitting high quality and high bandwidth streams of audio and video between devices. Single HDMI cable replaced the 3 composite audio-video cables, making it easier to connect 2 devices together for transmitting audio and video signals. Next is the Universal Serial Bus, or the USB. USB-connected devices cover a broad range, anything from keyboards to music players and flash drives, send power to certain devices, such as powering smartphones and tables and charging their batteries. There are 3 types of USB, the Type A, the Type B, and the Type-C. These are the pictures of the three types. The USB Type-A is a 4-pin connector. There are different versions of Type-A. The USB 1.0, 1.1, USB 2.0, and USB 3.0. Common standard and supports a data rate of 400 Mbps. Next is the Type-B. Mini USB, also known as Mini USB, is used for digital cameras and computers. Mini USB has largely been replaced by micro USB and USB-C cables in newer devices. So the latest USB is the Type-C. It is featured on most modern-day Android smartphones and other USB-connected devices, unlike other forms of USB connections. That is reversible, meaning they can plug in properly regardless of whether or not they are upside down. So let's watch the video that talk about the USB. That's the end of the video, and there are more different USB devices that connect to your computer. The list below contains a few of the most common: the digital camera, external device, iPod, keyboard, keypad, microphone, mouse, printer, joystick, jump drive, scanners, smartphone, tablet, and webcams, and many more. Next is the Bluetooth. Typically, there are two types of ports, incoming and outgoing. The incoming port enables the device to receive connections from Bluetooth devices, while the outgoing ports makes connections to Bluetooth devices. Bluetooth uses short-range radio frequencies to transmit information from fixed and mobile devices. These devices must be within the range of 32 feet or 10 meters for Bluetooth to effectively work. Next is the IRDA, stands for Infrared Data Association, a group of device manufacturers that develop the standard for transmitting data via infrared light waves. IRDA-enabled products include adapters, notebooks, PDAs, cell phones, handhelds, pagers, scanners, many more. Ports is not only physical but also on networks. The most common network ports are the following. We all know about the port 80, which was the Hypertext Transfer Protocol, or the HTTP. The port 20 and 21, the File Transfer Protocol, or FTP. And 143, the Internet Message Access Protocol, or IMAP4. And now let's talk about the types and usage of different connectors. First one is the VGA, or the VGA connector. This is the picture of a common VGA connector. It is color blue. The next one is the BVI connector. Next is the computer power cord, or the kettle plug. Connect power supply unit to computer monitor. Always turn off your power supply unit with the 1-0 switch at the back before connecting a power cord to it. Next, as you can see, the display port is best to use if you require a fast, high-resolution image. The cable has a better quality over HDMI and is the best option if you have this interface. Next is the RF connector, the radio frequency. Next is the S-video connector, the 4-pin mini DIN connector. Next is the FireWire connector, the SI connector, small computer system interface. Next is the HDMI connector, which we're all familiar with, the PS2 connector, the color green and the violet. Next is the RJ45 for router and R4 network switch. Next is the 4R phone connector. The 3.5mm jacks are often found on mobile phones. Next is the USB on the go, OTG, which what we call that, the USB 3.0 connectors, and the Thunderbolt for developed by Apple, and the USB-C that are currently gonna use. The USB computer cable connectors, the 2.0, the 3.0, the Type A, the Type B, and Type C. So it is for storage device. It can be used for storage device. It can be used as an input device and output device, a wireless adapter. And charging, data and charging. And these are my additional informations about the ports and connectors. It is how to identify ports in use on a computer, discover which input-output ports are in use. So in step 1, click Start, then Control Panel, navigate to Device Manager. In XP, you can click the System icon and then the Hardware tab. In step 2, select the View, drop-down menu, then select Resources by type. Then the step 3, click on Input-Output Devices to see a list of the ports in use. And how to identify network ports in use. Then step 1, open a command prompt by clicking Start and typing CMD in the run box. Step 2, type CD to get to your C drive. Step 3, type netstat on A to see a list of all active port connectors. If you wish to see more data or see the data displayed differently, typing nestat A will give you a menu of possible commands and can cause and use to the results. So if you are ever wondering what are the ports found in a smart TV, here it is. First one is the USB, a data link, also used for attaching a wireless dongle that can get your TV to the Wi-Fi network of your home. Once it's in effect, the TV will become a smart TV that can be accessed via internet content, the Netflix, the Facebook, Google Play, and many more, most likely through a frustrating and poorly built on-screen GUI. It is found on almost all smart TVs or all smart TVs. Next one is the optical audio, often known as Toslink. This standard transmits high-quality audio from the monitor to a soundbar, home theater device, or an amplifier using fiber optic cables. Next, number 3 is the HDMI. The high-definition video and audio link standard HDMI cables in one cable hold high-definition video and surround sound audio. The material is digitally distributed, so even after long distances, there's little or no signal loss. Next is the component with the color green, blue, and red. The only way to send high-definition video from a smartphone to a monitor before HDMI. The component cables are split into 3, the red, the green, and the blue connectors, each of which carries a portion of the video signal. The component cables are video only, so to hear something, you do need an audio link. HDMI replaced this norm easily. Next is the composite, color yellow. The most simple video connection in the lowest infidelity, good for connecting older devices that lack the newer, more capable requirements such as camcorders or game consoles. Next is the audio out, with the color white and red, also known as RCA jacks, to reflect the left and the right channels of a stereo signal. They have audio connectors that are low fidelity and they do not support surround sound. Consider optical audio or HDMI for high quality audio link. Next is the LAN, a connector that looks like a cable for a phone except it's a little thicker. The LAN jack is what you would use if you did not have Wi-Fi used to connect the wired local area networks. Next is the X-Link, used on certain Samsung TVs. The X-Link connection allows you to change the angle of some wall-mounted TVs using the remote control of your existing TV. Next is the antenna-ing. The threaded connection is used to attach an external antenna or occasionally a cable set-top box for a higher quality link between devices. Modern set-top boxes typically have HDMI or port connections, so this port is unlikely to be used, but it is still on the smart TVs. Next is the PC-in, often known as a VGA adapter. This is a way of attaching a television to a laptop or other personal device. This connection is only for sound, so you will need to set up an external audio connection to hear something coming from your device.
All peripherals need a way to connect to a computer, so let's take a look at the different types of ports and connectors. First is the most common of all, USB. USB stands for Universal Serial Bus, and it's a type of connector found not only on computer peripherals, but on gaming consoles, TVs, DVDs, and Blu-ray players, car audio systems. USB is nearly everywhere. When you see a port that looks like this on the back of a computer, regardless of the color, that's a USB port. It's worth mentioning that the USB port on the device that you want to connect to might look different from this. There are actually a number of different types of USB connectors. Here's a quick look at some of them. One of the bummers about all of these USB connectors is that if you try to plug them in upside down, they won't work. This is why the newest version of USB, called USB-C, is a very welcome change. It's reversible, so it doesn't matter which way you plug it in. Another significant port on the back of a computer is the Ethernet port. The Ethernet port allows you to plug in an Ethernet cable, which can connect your computer to a network and to the internet. Now, to connect your computer to a monitor, there are several possibilities. For many years, the 15-pin VGA port was the standard, and you'll still sometimes see it in use today on old computers and projectors. This type of connector, however, is limited in terms of the screen resolution and the quality that it can support, which is something we'll talk more about later. But for this reason, it's generally not found on new products anymore. Next is the DVI port, which comes in a few different variations, some of which suffer from the same limitations as the VGA connector. For this reason, this type of connector is also becoming less common. By far the most common connector for connecting a display, whether it's a computer monitor or a widescreen TV, is an HDMI port. HDMI is fully digital and it supports high-resolution displays and can also carry audio. You'll find HDMI ports on just about every new TV and computer monitor these days. HDMI cables and connectors come in a few different sizes in order to accommodate different size devices. The final video connector we'll look at is called DisplayPort. DisplayPort isn't as common as HDMI, but hopefully it will be because it's actually better in a couple of ways, supporting even higher resolutions and frame rates. DisplayPort comes in two sizes, and if you're a Mac user, you'll probably recognize the smaller of the two, called Mini DisplayPort. Speaking of Macs, it's worth noting that the Mini DisplayPort on newer Macs is also a Thunderbolt port, which is indicated by the little lightning bolt symbol. Thunderbolt is a type of connection created by Apple that is very high speed and allows you to connect many devices to just one port. Turning to audio, we've got our standard 3.5mm headphone jack and a 3.5mm audio input jack. It's worth noting that many audio devices are equipped with USB connectors, so these two aren't always necessary. Some computers, like this one, also have an integrated SD card reader, which can make it easier to copy photos from a digital camera to your computer. Some devices can be connected to your computer without having to use any sort of cable at all. The most common way to connect devices wirelessly to your computer is to use Bluetooth. A Bluetooth device uses radio waves instead of wires or cables, and there are many devices that support Bluetooth, including cell phones, headsets, keyboards, mice, portable speakers, car audio systems, and more. Bluetooth typically has a range of about 30 feet, so your devices have to be somewhat close together in order to stay connected. Finally, there's the wireless connection that you're probably already familiar with, Wi-Fi. You can think of Wi-Fi like a wireless version of an Ethernet cable. Its primary purpose is to connect computers, and some other devices like phones and tablets, to networks and to the internet. Unlike Bluetooth, which allows devices to connect directly to one another, Wi-Fi uses a wireless router that all of the different devices then connect to in order to communicate with one another. This results in greater wireless range, especially if you have more than one router, and much faster data transfer speeds. But it's all dependent on having the wireless router. For this reason, Wi-Fi and Bluetooth serve very different purposes. Wi-Fi is used to connect devices to networks and to the internet, and Bluetooth is used to connect devices directly to a variety of peripherals. This concludes our discussion of ports and connections. I hope you've enjoyed this video and that you have a better idea of the different ways that devices can connect to one another.
So that's it. Thank you and God bless.
Welcome to this edition of Professor Messer's free CompTIA A+ certification training course. I'm James Messer, and in this particular module, we're going to talk about bus architectures and what that really is. This comes directly from the CompTIA exam objectives 220-601 section 1.1, where we'll identify the names, purposes, and characteristics of motherboards and specifically the components of bus architectures that are on those motherboards. Now, the bus architecture itself is designed to be a communication path. And if you ever look at a motherboard and all of the different little lines of communication going between all of the devices, it's like a small city. You can see the taller buildings, you can see the paths, the roads that the electrons take to move from place to place. And that is a bus that we've built so that we can expand this internal personal computer that we have. Each one of those pathways is going to different places. And then internal PC growth allows us to add additional expansion to the system. We can introduce new capabilities. We can improve on existing capabilities with video and audio inside of the device. And it's this expansion bus that allows us to do that. Now, if we look at traditionally what an expansion bus architecture is, it's this very parallel path that we've set up. You'll often hear it referred to as a certain number of bits wide. It will be an 8-bit bus or a 16-bit wide bus. And that means that we've got a very wide road. It's multiple lanes with different cars and trucks moving across it. And this width is going to change based on the clock speed of the bus. We can send more traffic across the bus as the clock speed gets higher. You'll hear this clock speed referred to as megahertz. So 1 million cycles per second is the same as 1 megahertz. If you ever hear 1 gigahertz, that is 1,000 megahertz. And the faster the number of cycles per second, the faster the amount of information that we can push across those bus architectures. So if we take the width of the architecture, we multiply it by the clock speed, then we're going to have a theoretical throughput of exactly how much traffic we can move across that bus at one time. And I'll give you a picture of what that looks like in just a moment. And we're going to refer to this picture, one that you may have seen in an earlier video that we've done. This is a bus architecture inside of a system. Our CPU at the top, and every place you see a black line, that refers to a bus. Now, some of the buses are very wide and very big and very fast, can move a lot of traffic, and I've got those marked as a wider picture. This front side bus, for instance, you'll see is a very dark line, a very wide and dark line. And that's because the front side bus in a computer is generally the fastest bus there is. And when you look at purchasing a new computer, you'll see in the technical specifications, they'll not only talk about what type of processor is in the system, but they'll talk about the speed of that front side bus, the megahertz or the gigahertz of that front side bus speed. And that's exactly what they're referring to as how much traffic can we put across that front side bus? What speed is that running at? And if it's a 32-bit CPU, we have a 32-bit wide bus that is sending at a certain amount of megahertz. And that's what we're looking for speeds there on a system, because the faster that communication, the better it's going to be able to read and write to memory, and the better it's going to be able to read and write video out. And that's very often the most important things when thinking about the speed of a personal computer. Now, we also have these other buses that connect, for instance, between the North Bridge and the South Bridge. We have an internal bus, and there are buses for the PCI slots. There are buses for what we call a low pin count bus that goes to these slower systems like a serial port or a floppy drive or a keyboard or a mouse, you'll see a lot of different buses in a system. The one that we want to talk about in this case is, I'll give you an example of how the South Bridge communicates over an 8-bit bus. Let's say we have this expansion slot in our system. And the way this bus works is we have this traffic that all travels in parallel in both directions up and down that bus. And the faster the bus speed, the faster that traffic will traverse. But you'll notice that it can't go more, in the case of an 8-bit expansion slot, you can only send 8 bits at a time. You can't go any faster than that. So that's why we talk about that bus and the width and the speed being so very important. If it's a larger expansion bus, maybe we'll talk about 16-bit expansion cards. That means you can send 16 of the bits at the same time. And again, we've got this shared bus where the traffic's going back and forth to that, in this particular case, the South Bridge, and transferring that information back and forth. And that is how we get information back and forth out of those expansion slots into the South Bridge and ultimately up into memory and have the CPU work on them. Expansion bus architecture, we first saw this with the IBM PCXT, one of the very first personal computers from IBM. And this is a very standardized architecture, and it was one of the first times you ever saw in this particular industry where you could purchase third-party hardware to install into an IBM personal computer. That third-party hardware didn't have to be manufactured by IBM. And so it had to be a very standardized way to plug in additional cards. That first bus was 8 bits wide, ran at 7 megahertz, which means our theoretical throughput was just about 7 megabytes per second. You'll see MB is megabytes with a capital B as bytes. This was a lowercase b, it would be bits. So this is 7 megabytes per second as a theoretical throughput of that bus. Then the next version of the IBM PC came out. It was called the AT, and it expanded the size of the bus, this industry standard architecture bus, this ISA bus, by up to 16 bits wide. Still ran at 7 megahertz, but it essentially doubled our theoretical throughput up to 14 megabytes per second. And if you look at a motherboard, you'll sometimes see these older ISA bus slots in a system. That's what they look like. This particular motherboard not only had an ISA bus, it had a newer PCI bus right next to it. So you'll see the older ISA bus, even this PCI bus it's a very small, much smaller, but it had almost more information going back and forth there. Here's what you'd see when you had an ISA type architecture is you had a card that would connect. This ISA card would connect into an ISA bus. This happened to be an older network card. And you'll see that it fits very nicely into that slot. And then you're able to take use of it, make use of it. In this particular case, this was a card made by a third party. We just plugged it into that industry standard architecture bus. And then we were able to expand the capabilities of that system. When we start looking at bus architectures and the design of them, always keep in mind that these architecture types are very standardized and they're transferring information over those buses. We have that front side bus and the expansion bus we talked about. Very important buses when we talk about transferring information in and out of memory and expanding the capabilities of our personal computers. And also keep in mind when we talk about the size and widths of those architectures and we talk about the speeds of those buses, that we're talking about a total theoretical throughput we can put on there. Very important when thinking about the speeds of our personal computers. For more A+ certification videos, our message boards, and study guides, feel free to visit our website at freeaplus.com.
I'm Aurelian Espiritu and this is my report about BEI. Let's start. What is BEI? BEI an inspection. BEI is an open computer section used for expansion add to your computer such as hard drive and CD-ROM. What is computer case? A computer case, also known as computer cases, tower, system unit, or cabinet, is the enclosure that contains most of the components of a personal computer, usually including the display, keyboard, and mouse. Two types of BEIs: internal BEIs and external BEIs. Internal bays are where drives are mounted in the computer, while external bays are places to put drives that you can access from outside the case. 7 types of computer case. Number 1, full tower. Full tower cases are the biggest case available. Height of 24 or 60 cm or more. Number of internal bays 6 to 10 and 11 PCI. Number 2, mid tower. This provide the sweet spot between upgradability and size. Mid tower case are the most widely used computer case and are normally about 18 to 24 high, 45 cm to 60 cm, and they usually contain 2 to 4 internal drive bays for hard drive and 7 PCI. 3. Mini tower, 1 or more, sometimes 2 internal drive bays to add extra hard drives. Mini cases normally stand at height of 12 to 18 or 30 cm to 45 cm. Expandability a problem with these cases. A room can be limited. Entry PC. Desktop micro, simplified tower case, turn underside, but are slight slimmer so they could not fit a full-size graphic card GPU inside. And pwede siya hawakan on top para mabakante ng space kahit saan. And meron siyang 4 PCI slot. 5. Small form factor. Slightly smaller than desktop but serve the same purpose of saving space. 3 or 4 of the size. Easy access to the inside with a full handle on the side top. And 2 PCI slots. 6. Ultra small form factor. Minimize the spatial volume of desktop computer. Laptop size hard drives and memory. Difficult to upgrade because many peripherals have more restricted airflow, so can get quick warm. Number 7. Micro. Ito yung pinakamaliit. Then, used to attach to the back of monitor to save the most desk space. Laptop size and hard drives and memory lang din ito. Have a Wi-Fi. Upgraded expansion cards are very limited, and they don't have space for an optical drive. Of base. Ito, ginagamit itong base para sa computer peripherals and devices like hard drive, DVD drive, floppy drive, at marami pang iba. Base, ito yung mahalaga din siya kasi nagbibigay siya ng parang buhay sa isang computer, and critical din yung function niya. Parang tao lang din. More drive bays are fixed to the inside of a case, and pwede siyang remove, but nowadays yung ibang drive hindi pwedeng tanggalin kasi masisira na siya and hindi computer case is meron siyang simple and rectangular shape and were painted beige or white with detailed attention given to visual design. But nowadays, ang mga computer case is may mga LED stream, umiilaw, ganon. Yung mga computer case ngayon, may sarili ng pan, visible siya, hindi siya basta-basta makikita. Lahat ng drive, hard drive, floppy disk, kailangan install. Hindi siya pwedeng hindi install kasi hindi siya gagana or magiging kulang ang capacity ng base. Then sa computer case, kailangan meron siyang provided na airflow from case para hindi siya uminit, ganun. And kailangan yung lahat ng components niya ay malamig lang. Hindi siya kailangan uminit dahil posible siyang sumabog or masira. And that's all thing.
Before we start, I want to introduce myself. I'm Jamie Borlawan and I will discuss to you power supply. What is power supply? It is an electrical system used to supply electrical power to electrical loads. That power supply can be described. The primary purpose of this system is to alter the electrical current to the precise voltage, frequency, and the current to supply the load from a source. Itong power supply ay pwede rin tawaging electrical power converters dahil ito din yung device na nagko-convert ng isang voltage into the more convenient one. I have here a video clip for the basics of power supply.
Hi, I'm Alex Paul, Marketing Director for GlobeTech, your power partner. And this is the first of a series of modules on power supply basics. It's intended for laymen and business professionals who are interested or need to understand power electronics, but don't need a full technical background. Basically, you want to be able to nod in the right places and understand what's important in a conversation with an engineer or some other professional talking about power electronics. This module is specifically about power supplies, and it's very basic, so if you know what a power supply is, or what AC and DC power are, you can skip this and go to the second module, which explores the types of AC power supply, or the third module, which talks about DC power supplies and their variations, or farther up the chain where we talk about power architectures, we talk about alternate power sources, the needs for powering lighting systems and such. But this module is specifically a short introduction on what is a power supply and what's so important about them. Essentially, a power supply is a device that takes electrical energy and converts it from one form to another. In some cases, the power supply may actually provide power, as in the case of a battery or a solar cell or a generator. But in most senses, when people talk about a power supply, they're talking about the electronics that go into a system between either a battery and your device, or the wall and your device, or some other source of electrical energy and your device. Now, everything on this table is a power supply of one form or another. As I had mentioned, solar panels, batteries are more sources. In the case of this is actually an intelligent battery that has built-in charger and fuel gauge electronics. So this is actually a self-contained power supply and battery storage system. They're becoming very popular nowadays with the expansion of embedded intelligent systems and smart electronics and complicated motorized devices. You need power, you need smart power in order to run it. So that's what power supplies do. They provide the power to run the systems, because what comes out of the wall may not necessarily be what your device needs. Ditto for what comes out of the battery or what comes out of a solar cell. So a power supply can be what they call open frame. It can be enclosed. It could be a chip scale power supply. It could be a non-chip scale, but very, very small. Or it could be a demo power supply in this case, where it's actually laid out wide so you can see the components that were used, because in this case it was used for demonstration purposes. So every power supply has got some certain basic aspects to it. There's some type of conversion electronics that may involve transformers, inductors, or some other magnetic technology, and we'll cover that in a later module when we talk about the components. But usually when you see a piece of board and there are big cans like this and wires wound around it, odds are it's a power supply. So now, for example, AC power supplies take the alternating current out of the wall and turn it into the direct current that your device needs. Most electronic circuitry operates on direct current, which is actually what comes out of a battery. The energy comes out of the battery, goes to the device, and goes back to the battery in a closed loop. Alternating current actually creates a wave form of energy that is more easily changed in either power levels or voltages to allow more flexible management of that power. So in one way, for example, transmission, the higher the voltage, the farther the electrical power can travel with less loss. And so AC, it's easier to raise the voltage to the high levels to transmit long distances, which is why it beat DC out as the way of transmitting power across the country. Now, a power system changes that electrical current from, in the case of I said AC, 110 volts, to the device. Most devices use relatively low voltages of DC. For example, your cell phone may operate on around 6 volts, 9 volts, and that's just what goes into the device. Within the device, there will be separate, very small power supplies for the camera, for the display, for the LED lights, because each of the devices in your product need power of a certain type, and it's usually measured in a voltage. Now, as I said, AC is alternating current, which is more of a waveform of electrical power, and DC is more of a straight flow of electrical power, and that's AC and DC. The waveform can vary in speed, and that's the frequency. Now, in the case of voltage versus current, as I said, you've got the voltage and you've got the current, but what are they? The voltage, you could look at it as if electricity as water. Voltage is the pressure, and current, it actually does apply as to water, is the current, the amount. So for example, you could be subjected to a bathtub full of water. If it was just simply tipped upon you, the pressure would be relatively generally low because you're getting the entire amount of water in a single flow in a relatively large frame. Whereas if I took a glass worth of water and I forced it through a pinhole at high pressure, I could cut your arm off with that. Water pressure versus water volume, and that applies to electricity as well. So a power supply takes the electricity from the wall or from a battery, changes its pressure, voltage, and, well, it can't really change its current if it's a case of a battery, but it can regulate the current, in other words, allow less current to come through, because of course what's coming out of the wall may be too much for the device, like trying to drink from a fire hose. So the electronics are designed to step down the power, as it were. Sometimes you may have multiple sections of power within a device. I will show you an example. This is an LED light emitting diode. It's attached to a large heatsink because this is a demo. That's actually where this power supply comes from. This is the demo power supply for this LED. You see, they fit together like that. So now this power supply drives this LED. But this power supply actually takes another voltage coming in to convert it to what this LED needs. So I need an additional power supply to then, oops, wrong plug into the power to get the light to function. I remove the external power, the light goes off. This external power was generated by yet another power supply. So this power supply takes the AC, you see the plugs, and converts it, in this case, and it always says right on a power supply what it does. If it's a packaged supply, this puts out 12 volts. That's why this is relatively large. This is obviously just a general 12 volt power supply. It wasn't optimized for this system. So then this takes the 12 volts and converts it to the probably 3.3 or might be 5 volts that this device needs. Now the important thing with an LED, which I'll address again in the later module on solid state lighting, is that it takes a special kind of power to drive based on whether it's a voltage driven or current driven. In this case it's a current driven device, and I'll explain that difference as I said later on. Just remember, voltage is the pressure of the power and the current or the amperage is the flow, how much electricity is there. But remember, the electricity has to be converted from one form to another in order for the various devices to work. So that's our basic module on power supplies, what a power supply is. We know that a power supply takes electrical energy and changes it from one type of voltage to another, can restrict the amount of current coming through, and in some cases can actually increase current by using storage technology called capacitors on the board to literally store it, as if you were saying, taking a deep breath before blowing out candles. So, as I said, I'm Alex Pault with GlobeTech, your power partner. Visit us at www.globetech.com, and we'll be more than happy to help you solve your power issues. Thanks.
Ang power supply ay may apat na component. These are the transformer. Ito yung nag-i-input ng line voltage para sa desired level. Rectifier, ito yung nagko-convert ng signal papunta sa DC voltage. Filter, ito naman yung nag-filter ng mga DC voltage. And regulator, ito yung nagme-maintain ng output ng isang power supply to a constant level. Let's see the differences of these components in the help of the video clip.
A transformer is a static electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. A varying current in one coil of the transformer produces a varying magnetic field, which in turn induces a varying electromotive force or EMF in second coil. Power can be transferred between the two coils. Without a metallic connection between the two circuits, there are several transformer types used in the electrical power system for different purposes, like in power generation, distribution and transmission and utilization of electrical power. In this video, I will going to show you different types of transformer. There are 7 categories of transformer are made for different purposes. 1. According to construction. 2. According to core medium. 3. According to voltage level. 4. According to type of supply. 5. According to their use. 6. According to instrument transformer. 7. According to the place of use. According to the construction. The construction of a transformer is dependent upon how the primary and secondary windings are wound around the central laminated steel core. The two most common and basic designs of transformer construction are the court type transformer and the shell type transformer. Court type transformer. In court type transformer, windings are cylindrical former wound, mounted on the core limbs as shown. The cylindrical coils have different layers and each layer is insulated from each other. Low voltage windings are placed nearer to the core as they are easier to insulate. Shell type transformer. The coils are former wound and mounted in layers stacked with insulation between them. A shell type transformer may have a simple rectangular form or it may have a distributed form. According to core medium, based on the medium placed between the primary and secondary windings, the transformer are classified as air core transformer and iron core transformer. Air core transformer. The primary and secondary windings wounded on non-magnetic strip where the flux linkage between primary and secondary is through the air. The mutual inductance effect is less in air core compared to iron core. The reluctance offered to the generated flux is high in the air core medium, whereas in the iron core it is less. But the hysteresis and the eddy current losses, which are dominant in iron core type, are less or completely eliminated in air core type transformer. Iron core transformer. The primary and secondary windings are wound on multiple iron plate bunch, which provide a perfect linkage path to the generated flux. It offers less reluctance to the linkage flux due to the conductive and magnetic property of the iron. These are widely used transformers in which the efficiency is high compared to the air core type transformer. According to the voltage level, these are the most commonly used transformer types for all the applications. Depends upon the voltage ratios from primary to secondary windings, the transformers are classified as step up and step down. Step up transformer. On a step-up transformer, there are more turns on the secondary coil than the primary coil. The induced voltage across the secondary coil is greater than the applied voltage across the primary coil, or in other words, the voltage has been stepped up. Step-down transformer. A step-down transformer has less turns on the secondary coil than the primary coils. The induced voltage across the secondary coil is less the applied voltage across the primary coil, or in other words, the voltage is stepped down. According to the type of supply, these are the most commonly used transformer types for depends on supply line. They are classified as single phase transformer and three phase transformer. Single phase transformer. single-phase transformers accept single-phase AC power and output single-phase AC power. Typically, at higher or lower voltage level, energy is transferred from one circuit to one or more circuits via electromagnetic induction. Three-phase transformer. Three-phase transformer electric power is a common method of alternating current electric power generation, transmission and distribution. It is a type of polyphase system and is the most common method used by electrical grid worldwide to transfer power. According to their use, according to the necessity, these are classified as the power transformer, distribution transformer, measuring transformer, and instrument transformer. Power transformer. A transformer is located directly next to a power plant is called GSU, generator step-up unit. A GSU transforms the electric power from the medium voltage of the generators to the high voltage transmission level. To balance power flow between parallel power lines, phase shifter can be used. Distribution transformer. A distribution transformer or service transformer is a transformer that provides the final voltage transformation in the electric power distribution system, stepping down the voltage used in distribution line to the level used by the customer. Instrument transformer. Instrument transformer are highly accuracy class electrical devices used to isolate or transform voltage or current levels. Instrument transformer are classified as current transformer and potential transformer. Current transformer. A current transformer is an electric device that produces an alternating current in its secondary which is proportional to the AC current in its primary. Potential transformer PT. Voltage transformer, also called potential transformers PT, are a parallel connected type of instrument transformer. They are designed to present negligible load to the supply being measured and have an accurate voltage ratio and phase relationship to enable accurate secondary connected metering. According to the place of use, these are classified as indoor and outdoor transformer. Indoor transformers are covered with a proper roof like as in the process industry. The outdoor transformers are nothing but distribution type transformer. Dear sir, thanks for watching this video. More update, please subscribe to my channel Learning Engineering and get notification to press the bell icon.
These days, buying a power supply is pretty straightforward. Unless you're going for a really specific aesthetic, get an ATX power supply, which by the way are compatible with ATX, Micro ATX, and Mini ITX motherboards. All you gotta do is make sure it isn't some kind of bargain basement, no-name unit that will explode when you try and run Crysis, and that it has enough wattage to power your rig. And with high-end graphics cards getting more and more power efficient these days, and those are usually the most power-hungry part of a computer, getting a PSU that's sufficiently powerful is becoming less and less important by the day. But it wasn't always as easy as just slotting in the first thing you could find and carrying on with your computing. In fact, the power supply that came with the original IBM PC only provided 64 watts of power, pushed a whopping 5 volts through the CPU, which would fry any modern consumer-grade processor, and forget about fancy features like standby or soft reset. Old-school power supplies only had a hard power switch, so everything was either fully on or fully off all the time. With that said though, the really difficult thing about these older power supplies was their physical layouts. Even in the era of AT power supplies, the predecessor to ATX that lasted from 1984 until the late 90s, there were not only multiple different form factors such as Baby AT, XT, and some weird thing that worked with PS2, but some systems even had switches soldered directly to the computer case out of the power supplies. So good luck replacing your PSU if it suddenly fizzled out, further adding to the frustration of technicians and tinkerers everywhere. And then, as if that weren't enough, there wasn't even one uniform standard for the actual pinouts onto the motherboard amongst these different form factors. I mean, the power supply scene was basically chaos. But the ATX standard saved us from an eternal quagmire of proprietary form factors when it was introduced in 1995 by Intel, especially as it actually did a lot more than just make our power supplies mostly the same size. In fact, the ATX standard made things much easier for home PC builders as well as small shop owners who wanted to build or offer something different than what the IBMs of the world were cranking out. And not only did it make things easier, having just one standard made things cheaper, improving competition throughout the industry. And generally speaking, higher quality as well, as a single standard forced manufacturers to innovate and improve on quality rather than focusing their efforts on trapping us into proprietaryville. And that's exactly what happened, assuming of course you're buying from a reputable brand. ATX power supplies have evolved. They've come in large and small varieties with both 80 and 120 millimeter fans, yet they're still ATX compliant and can fit in a wide variety of cases. Combine that with improved efficiency in recent years, as we've seen with the 80+ rating system, and ATX has had fantastic staying power, in spite of several companies trying to replace it throughout the years, such as Antec with their CPX design a few years back, and even Intel, who tried to replace their own standard with the now defunct BTX form factor. ATX also brought us familiar things that we now take for granted, like the 20 and then later 24-pin connector, which serves as the primary power delivery for pretty much all modern PCs. The wires that connect to the motherboard to enable smart power management and a greater emphasis on 12-volt power delivery. You see, older power supplies often delivered most of their power on the 5-volt rail, with many actual sensitive components directly connected to it. These days, the smaller transistors on parts like CPUs and graphics cards play much more nicely with lower voltages. I mean, think about overclocking your CPU, putting 2 volts through it. You might kill it. Ugh. But on the flip side, as computer components have become faster and more powerful, they actually need even more current. That's the amount of electricity being sent through the chip. So modern power supplies have more power on the 12-volt rail, and then it gets converted to lower voltages for the many different components by voltage regulator modules or VRMs, and those will be present on the motherboard or on the graphics card itself. This way, the components can operate at a safe voltage and still get enough current from the higher capacity 12-volt rail. ATX has also changed with the times in other ways, introducing PCI Express power connectors as graphics cards went from sipping electricity to becoming the most power-hungry component in a PC, a further testament to its staying power when many other computer standards have been put out to pasture within its lifetime. But that doesn't mean then that all modern power supplies use the exact ATX form factor. There are also derivative form factors such as SFX, which is essentially identical to ATX electrically and in fact interoperable with ATX motherboards, but a heck of a lot smaller, making them popular for things like super small mini ITX builds. In servers, you'll find power supplies that have a couple of EPS connectors, so EPS standard power supplies, which actually is kind of funny because that 8-pin CPU power connector ended up making its way into desktops as well. And finally, there are things like TFX for slim tower systems, or, I mean, they still do exist, the dreaded proprietary power supply. Fortunately for you though, the PC DIY enthusiast, most of those power supplies are nearly irrelevant, unless of course you find yourself working for a YouTube channel where you have to solder connectors on weird power supplies you found in a scrap heap somewhere in order to get a computer to boot at the last moment in a competition, say for example. Speaking of getting things done in just a moment, Braintree payments, my friends. Braintree is the way to achieve easy mobile payments. Maybe you're working on the next Uber, Airbnb, or GitHub. Well, if you are, why not use the same simple payment solution that helped them become what they are today? Braintree makes mobile payments so fast, easy, and seamless, it's almost magical. It's not actually magic, it's science, but just stick with me here. You can add it to your app with just a few lines of code, and you are instantly ready to accept Apple Pay, Android Pay, PayPal, Venmo, credit cards, and even Bitcoin. And if some other way comes along, Braintree is going to support that too. Braintree's fast payouts and continuous support mean that you'll always be ready, whether you're earning your first dollar or your billionth. So see fewer abandoned carts and more sales with Braintree's best-in-class mobile checkout experience. You can learn more at braintreepayments.com/techquickie, linked in the video description. So thanks for watching, guys. If you like this video, like it. If you disliked it, dislike it. If you want to check out our other channels, boom. If you want to leave a comment suggesting future Fastest Possibles, boom. And finally, if you want to subscribe, then I like ya.
Have you ever wondered, how does my mobile get charged? Or what is the circuit present inside the charger? Or what is the role of rectifier in a mobile charger? To know the answers, continue watching. Hi, this is Benila. I make videos based on engineering concept. If you are into this, consider subscribing. In this modern world, the uses of portable devices like mobile, laptop, camera, electronic watches, power bank and tablets have increased. In fact, most of you would be using mobile phone for watching this video. The important question that we ask ourselves while leaving the home might be, did I take my charger with me? Yes, Charger has successfully managed to take part in all our travel checklist. First, let's come to our first question. How does my mobile get charged? Lithium-ion batteries are used in most of our mobiles. The cathode of lithium-ion battery is made of lithium metal oxide. The anode is made of graphite. They are separated by an electrolyte. The lithium present in the cathode have one valence electron. When an external DC voltage is applied, the valence electron moves towards the positive terminal of the battery and reaches anode. Now anode becomes more negative due to the extra electrons, and lithium, who lost its electron, becomes more positive. So they move towards anode through the electrolyte. After all the lithium reaches anode, the battery is considered fully charged. The main thing to consider here is the external supply applied is DC supply, but the electrical supply we have in our home is AC. Now you might have guessed the answer for the second question. What is the circuit present in the charger? Of course you are right. One of the circuit present in the charger is AC to DC converter. Rectifier is the circuit which converts AC voltage to DC voltage. Mobile charger is not the only application of rectifier. Few other common applications include electric vehicles, cranes, food mixers, welding, blowers, trains, vending machine and washing machine. Now let's see the type of rectifiers. Based on the number of semiconductor devices used, the rectifiers are classified as half-wave converter, full-wave converter and dual converters. Based on the type of semiconductor devices used, the rectifiers are classified as uncontrolled rectifier and controlled rectifier. Based on the type of input supply, the rectifiers are classified as single-phase converter and three-phase converter. In my upcoming videos, I am going to discuss in depth about each type. If you are interested in this, don't forget to subscribe and click the bell icon so that you will be notified each time I upload a video.
What is voltage regulator? A voltage regulator is an electronic circuit that provides a stable DC voltage independent of the load current, temperature and AC line voltage variations. A voltage regulator may use a simple feed-forward design or may include negative feedback. It may use an electromechanical mechanism or electronic components. Depending on the design, it may be used to regulate one or more AC or DC voltages. Electronic voltage regulators are found in devices such as computer power supplies, where they stabilize the DC voltages used by the processor and other elements. In automobile alternators and central power station generator plants, voltage regulators control the output of the plant. In an electric power distribution system, voltage regulators may be installed at a substation or along distribution lines so that all customers receive steady voltage independent of how much power is drawn from the line. Now let's look into the advantages and disadvantages of voltage regulators. Advantages. The EVR is the modern standard for voltage regulation in most power quality applications. While an EVR will be about 25% higher in cost than a comparable mechanical voltage regulator, the difference in correction speed often precludes the use of mechanical units. Output voltage regulation is good. Tap switching to very good double conversion. Ultra-fast voltage correction speed. No restrictions on the number of correction cycles. Versatility of kVA rating, voltage and configuration. Very low or no regular maintenance. Good line isolation. The ST type of EVR has a current overload capacity and durability that can surpass that of brush type mechanical regulators, since brushes can be damaged quickly when regularly subjected to high currents. By eliminating the inherent overload weakness of the FPS and double conversion units, the series transformer electronic voltage regulator is good in any application, but is the best choice for industrial, heavy commercial and medical imaging applications. Let's look into the disadvantages. Poor current overload capacity, except the series transformer design. More expensive than mechanical voltage regulators. As discussed above, the principal drawback of electronic voltage regulators is the limitation imposed by the SCRs or other power semiconductors. FPS voltage regulators as well as double conversion and UPS units can fail in a matter of hours or days when put in an application with high ingress or overload currents, without exercising due precautions such as sizing for the peak currents.
Ang power supply ay may apat na integration. Ang una ay inadequate air cooling. Ito ang major problem when we are integrating a power supply into a design. The power supplies generate heat and how it's handled affects performances and reliability. First, we consider natin the air cooling pass over the supply, whether the air pores or like electric fans. Second is when the airflow stalls, the fans actually speed up pero walang hangin. The second is incomplete supply sizing. An undersized supply's output na may tendency na magkaroon ng problema while providing more current than its related value. Third is open frame supplies issues. Meron ito exposed components na on their underside. The key is to ensure that they don't touch the enclosures. Stand-ups will provide adequate clearance in this case. Last is the multiple supplies. Multiple small supplies are often chosen when the physical system layouts lacks room for a single large, when heat sources must be disappeared or for the initials. Power supply, this is used for conversion changes incoming electricity to a format that the electrical device can use. Power supply is important to economic and environmental factors that are playing an ever-increasing part that the drive to improve efficiencies and reduce pollution from electronic equipment. Simply put, power supply efficiency is measured by comparing the AC power going into the power supply to the DC power coming out from the supply. Now, I will discuss the history of power supply, and after that, meron din akong video clip para mas maintindihan natin ang pagkakaiba nito. History of power supply, 1926 84 Motorola battery eliminator. The power supply industry date back to the early 1926 when crude devices were the first produced in the both industrial and consumer markets to act as battery eliminators for power radios. The demand for separate power supplies evaporated around 1929. when a built-in power supply was included in the most produced radios. In the 1930s, the need for standalone power supplies remained relatively poor, and into the 40s, during this time, the dominant technology consisted of vacuum tubes linear regulators. Power supplies use vacuum tubes for the power and control elements, typically a voltage regulator tube. In those days, we did not care too much about dissipation. But under normal circumstances, vacuum tubes get pretty hot, and unless the plates of the tube glowed red or the glass started to melt. Second model is Model 700 vacuum tube power supply, 0 to 350 volts. 3 businesses set up shop in a relatively obscure community in Queens, New York. In the mid-1940s, these firms, which eventually became industry leaders, were Lambada, Sorenson, and Kepco. Although all three companies exist today, only Kepco retains its autonomy and original ownership and continues to operate from Queens, New York. As semiconductors design proliferated in the market, concerns about dissipation and heat dominated the thinking of the power supply designers. Germanium transistors did not have the ability to glow in the dark as did tubes. They simply melted and gilt. These designers of this product suddenly had to take their thermodynamics seriously. Next is Kepco Type SE, the first transistorized power supply. Transistor products were limited to low-voltage models at the modest power levels or hybrid models that use semiconductors in the power. Next is Kepco Type SE, the first transistorized power supply. Transistor products were limited to low-voltage models at the modest power levels or hybrid models that use semiconductors in the power stage. Control circuit and vacuum tubes to make higher voltage products possible. Power supply products adopting technology that will satisfy those applications. Next is Kepco Type KM. This same time period also brought us to the concept of the first remotely programmable power supplies. A pioneer in the field was Dr. Kenneth Kufferberg, one of the founders of Kepco, who in his career was credited with 14 patents in the 1960s when the world was still analog. Sa time na ito, nagkaroon ng isang debate na ang focus ay analog computing for simulation and modeling. At yung concept na iyon ay tinawag nilang digital computing. Next is Model BOP featuring bipolar 4-quadrant power in the 1970s. The design and manufacture of switching power supplies can be traced back at least to the 1950s at the time. These products were produced in the huge quantities mostly to replace vibrators. In those days, vibrators converted an automobile 12 volts into the high voltage by mechanically switching. Later, germanium transistors were used to switch electrically. During the same decade, the high-gain series-pass linear power supply was enhanced with a new level of intelligence, the ability to follow commands from a host computer on a standard communication. Next is Kepco Model HSP N+1 redundancy with hot swap 1990. Modern fault-tolerant power system is typically employed to a technique known as parallel N+1 redundancy. Ang advantage nito ay over the traditional paralleling scheme, meron itong kakayanan na mag-distribute ng power and minimize the stress on individual units. Next is Kepco Model 16 to 27, an interface drives up to 27 remote power supplies. Another trend which has enjoyed increased interest in that is that which is sometimes referred to a point of use stabilization, distributing power at some intermediate voltage, 48 volts, 150 volts, and 400 volts. This technique is also known as distributed power. It relies on the use of a bulk supply to perform the conversion of AC from the mains into the DC, which then in turn powers any one of number of lower power DC to DC converter placed directly at the point of the load.
In today's video, we're going to take a brief look at some of the practical aspects of power supply decoupling and filtering. What we'll learn is that the size and placement of the various capacitors on a circuit board is largely driven by these various roles that these capacitors perform. Large value capacitors like these big electrolytic capacitors essentially form kind of charge storage reservoirs and do the bulk of the filtering for large, relatively low frequency current demands of the rest of the board. While the smaller surface mount capacitors are placed very close to various active devices, form a different role.
They also provide local charge storage, but not nearly as much charge as the bulk electrolytic capacitance. But more important, what they provide is a return path for high-speed signal currents. So the high-speed signal currents that might be flowing out of a pin are going to flow back through the ground plane and ultimately have to get back to the power supply. And they typically get back through these locally placed higher frequency decoupling caps. I'm going to attempt to illustrate this on a more simplified board. Now here's the simplified mock-up board that I'm going to use to illustrate the various roles that these capacitors play. I've got a 3.3 volt power supply coming in, running along a power supply rail, which could essentially be a trace on a circuit board running up to, in this case, an inverter chip that's running as an oscillator and then driving a 50 ohm transmission line into a termination here. And that transmission line is sitting over a ground plane. Now right now there is no power supply filtering on this at all, which is never a good idea, but this is where we're going to start. I'm probing the output of the pulse that we're generating here, and this is going to generate about a 3 volt pulse, so result in about a 60 milliamp current draw when the pulse is on, and a much lower current draw when the pulse is off. And we're going to also probe the power supply pin right at our active device, so we can see the effect of filtering right at the power supply pin. Okay, so the first thing we'll do is take a look at the effect of the bulk capacitance on the low frequency content of the noise in the power supply. In order to see that, I'm going to zoom in a little bit on that power supply. A better way to do that is to set up an offset that's equal to the power supply voltage, and that will allow me to set up a better vertical scale, say maybe 100 millivolt a division or 50 millivolt a division, to actually see that noise a little bit better. So we can actually see that when we're driving the transmission line, we're pulling an extra 60 milliamps through the supply, and that's causing a little bit of a dip in the supply voltage, and then it releases back up again. So if we place this bulk capacitor right near the power entry point to this board, we'd see we've collapsed that low frequency noise down to just about nothing, maybe a tenth of a division. If I move that bulk decoupling cap closer to my active device, it's basically about the same. It's marginally better, but it's basically about the same. And the reason for that is that this low frequency content really is very insensitive to this placement, because as far as the low frequencies are concerned, all of these points are virtually identical. They're essentially at the ground plane. There's no change in impedance between those various points. So typically you'll have these bulk decoupling caps right at the power supply or the power entry point to the board, because the placement isn't that critical. So let's actually solder this in place and then take a look at the effect of the high frequency component. Okay, with our bulk capacitor in place, let's change our vertical scale here so that I can now see the extent of the high frequency noise associated with the edges of our waveform. And we'll take a look at the placement of the high frequency decoupling cap and how the location of this on the board will affect how well it works in reducing that noise. Okay, let's start off by placing this 1.5 nanofarad capacitor right near the power entry point. And you can see a relatively small reduction in that high frequency noise. If I pull that cap off, you can see it grew about 0.2 of a division there and then reduced again. But now let's place that same capacitor very close to the chip. And we can see a very dramatic change in that high frequency noise. And this is essentially why we've got these capacitors located very, very close to the devices to get rid of that high frequency noise locally. Okay, so we've got both capacitors in place here now. Now let's talk about how the roles of these two capacitors differ. As we mentioned earlier, the large bulk capacitance is taking care of the large low frequency current demands and on the power supply, and helping to stiffen the power supply rail in that case. But the high frequency cap here is kind of forming a little bit of a different role. It is still kind of a charge reservoir, but it also is a high frequency current path. Let me explain what I mean by that. The active circuitry in here is creating this square wave that's coming out here with some very fast edges. And those edges contain obviously high frequency components. Now we've all heard the adage that current will take the path of least resistance. when we talk about current or at high frequencies, we have to modify that statement a little bit and say that the current is going to take the path of least impedance, which in this case really means least inductance. And the amount of inductance in a current loop is proportional to the loop area. So let's see what that means here. I've got power supply current coming in to power up this chip. That's creating the signal that's going out into this transmission line. So high frequency currents are going down this transmission line through the terminations into the ground plane. And they're going to go through the ground plane and ultimately return back to the power supply. But remember, we're talking about the high frequency currents here, and we want to minimize loop area. And that means that the high frequency currents are actually going to go into the ground plane and follow a path underneath the transmission line, because that will represent the least amount of loop area. It's not going to just go straight across this board, because that means that the current would have a big loop and a lot of inductance. So the high frequency currents are going to follow a path underneath the transmission line back towards the chip. So how does it get back essentially to the power supply? Well, it actually gets back through this cap. When we had this cap located up over here at the power entry point, that means the current kind of came back through here, because that's where the high frequency currents were flowing, but then had to kind of work its way all the way back around and come through here, so adding a lot more loop area. By placing the high frequency decoupling caps close to the chip, we provide a path for those high frequency currents to get back to the power supply, minimizing the inductance and minimizing the amount of noise generated. So this is really a very big part of the reason why if you look at any of the active devices and ICs on any circuit board, you will see local decoupling caps right here, right here. There was one actually I removed off of the board right there. There's plenty on the underneath side of this board associated with this chip, and these are providing that local storage and high frequency return path for any of the high frequency currents that are demanded by these particular chips. And this is essentially what we modeled here on my little mock-up board. Okay, so I hope you learned a little something about the different roles that the different power supply decoupling and filtering capacitors play on a circuit board, and why some of them are placed close to our active devices and some of them are not. If you like what you see, please give me a thumbs up. If you haven't subscribed already, please do so, and thanks again for watching.
Ngayon naman, i-discuss ko ang types ng power supply. Number 1 is switch mode power supply. Switching power supplies were introduced in the 1970s and quickly became the most popular way to supply DC power to electronic devices. Ito ay nagre-regulates na output voltage with pulse width modulation. Itong proseso na ito ay lumilikha ng noise, but it provides a high efficiency rating in a small form factor. Switch mode power supplies are here to stay, and the power supply are of choice for applications that aren't noise sensitive. It includes the devices such as mobile phones, chargers, DC motors, and more. Two kinds ng switch mode power supply ay switch mode regulator. Ito typically refers just to the electronic circuit na nagpo-provides ng regulation. Ito rin ay part ng overall switch mode power supply. Second is the switch mode regulator controller. Many switch mode regulator integrated circuits na hindi nagko-contain ng series of switching element. Second is UPS uninterruptible power supply. As the main power supply is lost, a UPS is an electrical system that allows a PC to keep running for some time. Protection from power flow is also provided in this unit. The UPS convert to DC battery and then inverts to AC power. It is because they can operate and they can connect equipment when incoming the power drops below or spikes above safe voltage levels in the times na blackout or voltage drop they provide. It is typically used to protect computers, data centers, telecommunication equipment, or other electrical equipment where an unexpected power disruption na nagkakos ng network outage na pwedeng mag-cause ng injuries, fatalities, serious business disruption, and loss of data. Third is AC power or alternating current. Usually the voltage from this main supply is acquired by an AC power supply, and the voltage can be increased or decreased by using transformer to the appropriate voltage, and the some filtering can take place. The various types of AC supplies are designed to provide an almost stable current, and the OP voltage will change depending on the impedance of the load. Ang purpose nito ay mag-filter ng AC power, at kung ang input at output voltage are identical, ang system ay mag-equip para makapag-provide ng backup power para dito. May be designated as an uninterruptible power supply because you can use it in case of power loss. Fourth is DC power supply, direct current. One that provides a consistent direct current voltage to its load is a DC power supply. A DC power supply might be controlled from A to DC supply from an AC supply, such as the power mains based on its plans. This type is to convert the power delivered to its input alternating means electricity supply into power available at its output in the form of a smooth and constant direct voltage. DC allows from a constant flow of current to a device because AC is delivered. Initially, power must first be converted to AC to DC. May dalawang components ang DC power supply. Ang una ay rectifier or charger, isa electrical device na nagko-converts as alternating current. Ito din yung main purpose ng rectifier. Second is controller. Ito ang nagsisilbing utak ng DC power system dahil the controller provides logic to the system, commanding the various components and providing insights into the UPS status and functionality. Fifth one is regulated power supply. A fixed circuit used to transform an unregulated alternating current into a stable direct current. A regulated power supply, meron itong multiple regulators na kaya mag-offer ng multiple output voltages for operating different devices. Kaya din itong i-maintain yung voltage para sa isang desired level. 6 is programmable power supply. Digital interface such as GPIB or RS232 allow remote control for the operation through analog input. For this form of power supply, present voltage, frequency include the regulated properties of the supply. Extended range programmable power supplies offer the ability para mag-deliver ng mataas na current at ng piling voltages na hindi kinakailangan na mamahaling gamit. Ito din ay safe at more reliable gamitin. 7 is computer power supply. The power supply unit in a computer is the portion of the hardware that is used to convert the power supplied from the outlet into usable power. The alternating current is converted into a direct current. Nagkocontrol din ito in case of the overheating by the voltage control, which can be manually or automatically changed depending on the power supply. Last is linear power supply. Linear regulators were the power supplies of choice until the 1970s for converting alternating current into a steady direct current for electronic devices. While these power supplies, this type isn't used as prevalently today, it is still the best choice for application that requires minimal noise and ripples.
Nagsisilbing barrier para ma-separate yung high voltage AC input from low voltage DC input, which also filters out any noise getting into the output voltage. Nagre-reduce din ito na AC input from 115 volts to 230 volts to approximately 30 volts, which can converted to a steady DC voltage. Kung ikaw ay pipili ng power supply, dapat ang piliin mo ay modern power supply na kayang mag-output ng at least 18 ampere on the positive 12 volts rails. Ang power supply ay tumatagal ng almost 5 to 10 years, pero kung maglalagay ka ng power supply na high loads sa matagal na panahon, maaari itong mag-overstress at masira agad. Take note that a complete desktop uses an average of 200 watt per hour. This is the sum of the average consumption per hour of the computer itself. 171 watts, the Ethernet modem is 10 watts, the printer is 5 watts, and the loudspeaker is 20 watts. Assuming that a computer is on for 8 hours a day, the annual composition comes to 600 kilowatt per hour. And if you want to check your monitor or PC power usage, all you need to do is to plug the device into a wall outlet, then plug your PC's power cable in the plug built into the power meter. And the next time you fire up your PC, the power meter will give you an accurate reading of how much electricity your PC is consuming.